Hello there and welcome to DataBash 2024 actually. So today we have a full day of content in 4 different tracks ready for you, and we're hoping that you really enjoy it. It's brought to you by the community in the DACH region. Many of us are here going to be moderating for you all during the day, presenting some great sessions throughout the day. We have a 90-minute break in the middle for lunch, and we hope to be finishing here in Berlin time, basically, by 5 p.m. So we hope you enjoy it. Right now, I'm going to pass over to our sponsor video and hope you enjoy it.
Hi, everyone. I'm Michael from So Digital Recruitment, and it's a privilege to be a sponsor for the DataBash conference. We focus on Microsoft data recruitment across the German-speaking region. If you're looking for new roles in BI, data engineering, or AI, then please get in contact. We have a number of roles with Microsoft partners and end users. Equally, if you are hiring for your team and want to see some good quality candidates, it would be great to speak. Lastly, thank you to all the organisers and speakers for creating a brilliant event. Enjoy the discussions, and I wish everyone a great day. Hi, everyone. I'm Michael from So Digital Recruitment, and it's a privilege to be a sponsor for the DataBash conference. We focus on Microsoft data recruitment across the German-speaking region. If you're looking for new roles in BI, data engineering, or AI, then please get in contact. We have a number of roles with Microsoft partners and end users. Equally, if you are hiring for your team and want to see some good quality candidates, it would be great to speak. Lastly, thank you to all the organisers and speakers for creating a brilliant event. Enjoy the discussions, and I wish everyone a great day.
Wonderful. So now that we've had the sponsor, thank you very much for our sponsors for the conference. We wouldn't be able to do this without them. I wanted to quickly introduce what we will be covering today in our sessions. Our first session that is coming up is with Amit Chandak, and he'll be talking about hands-on with Power BI visual calculations, a new DAX world to explore. After that, so that'll be for the first hour. In the second hour from 10 a.m., we'll be having demystifying semantic link in Microsoft Fabric with Pragati Jain, and she'll be joining us for that. After that, we will have 2 presenters presenting to us at 11 a.m., Fabric, Git, and Pipelines, a Chord in Harmony, by Marisol Steinau and Sebastian Steinau. After that, we have our 90-minute lunch break, and I'll have a countdown for you on the screen for that so that you know how long that's going to take. After that, we've got Data Democratization in Practice by Sofia Alieva. And after that, Alexander Klein will be talking to us about generative AI for data engineers in a 10-minute session, a very brief session there for us as well. After that, we have Andy Cutler speaking to us about Microsoft Fabric, warehouses for the database administrator, one that I'll definitely be taking notes in. And then Power BI monitoring from Power BI REST API through the data warehouse and back again to Power BI by Michal Debski. Last but not least, on our session agenda this time round, we have Andrew Madsen, who will be talking about the who, what, and why of data lake table formats. So we hope that you'll be enjoying this day that we've got. This is in room number 4, by the way. We have 4 rooms. So feel free to join the other rooms for other sessions that you might find applicable to you. And right now, I'm going to start introducing Amit to the stage. Amit, I'm about to put you on here. Let me see how it goes. And here we are. Hello there, Amit. How are you doing? Just waiting for you to get unmuted. Can't hear you yet. Testing 1, 2, 3. Amit is working out at the moment some of his audio issues, so let's just give that a couple of seconds.
Am I audible now?
Now we can hear you. That's great. Hi there, Ahmed. How are you doing?
I'm doing great. Thanks, Charlie. Thanks for the opportunity to be speaking in the Data Bash conference. I'm really excited about it. And thanks to the entire community who is doing this event. And I'm really looking forward to have talking to you about the Power BI visual calculations.
Wonderful. Thank you very much. And we will, in about a minute,
Am I still audible? Good morning, good afternoon, good evening, based on the location. Everybody who is joining in for this particular session of the Data Bash conference, I welcome you all to a session on hands-on with Power BI visual calculation, a new DAX world to explore. As you might be aware that Microsoft Power BI offers you different kind of calculation that include calculated columns, measures. In February 2024, Microsoft came up with a new set of calculation that is known as visual calculation. These calculations are a little different from what you were previously doing in terms of measures and calculated column. So today we are going to have a look at these visual calculations and see how can we utilize those. So my name is Amit Chandak and I'm a data platform MVP. I'm a Power BI community super user, a YouTuber, having channel with the same name. I also provide some courses from my website biworld.in. Most of them are free. And I am a chief analytics officer at Canerica, working on data analytics project, especially along with Power BI and Microsoft Fabric. So let's quickly understand what is visual calculation. And then what we are going to do is we are going to understand these definitions in first few minutes. Post that, I'm going to take you through the file where I'm going to do these some of these visual calculations. And in case you want that file, I have already given the link that will be given to you. So you can also download that file from where to start. At the end, I will also give you the link of the file which actually contains the complete visual calculation. A visual calculation is DAX calculation defined to execute directly on the visual. So this is different from your measures or calculated column one, which is calculated at the start of the loading, one which is calculated at runtime. Visual calculations are done at visual level, so they are very specific to visual. So beyond that visual, they don't have a scope. So you will not be aware of a visual calculation outside the visual. So visual calculation makes it easier to create calculation that are previously hard to create, leading to simpler DAX, easier maintenance, and better performance. Now, because the calculation will only happen at the visual level and it will happen on the data which is already available in the visual, it would be easier, it would be simpler, and it would be providing you better performance. The reason for better performance is that I have final data on which I'm doing these calculations. I don't have to do these calculations on the complete data or the source data which I have. Now, how visual calculations are different from other DAX calculations? So first of all, visual calculations are not stored in the model. Instead, they are stored at visual level. So they are only very specific to visual. So that's a difference. The visual calculations can only refer to what's on the visual. So let's say if you have, let's say, few measures or calculated column on the visual, your visual calculation can only use that. It cannot go beyond that. So neither the column boundary nor the row data boundary. So let's say when you use previous function, previous month, sometime what happens if the month is also not available, still we are able to get the previous month, because we are creating a measure, and measure can go beyond the boundary of what visual is available. But that's not going to happen in visual calculation. Visual calculation cannot find a previous month outside what is visible in your visual calculation. So both in terms of data as well as the columns, it cannot go beyond what is available already in your visual. Anything in the model must be added to the visual before the visual calculation can refer to it. Means if you want to use a measure or a calculation or a column, it need to be available in the visual. Then the next one is visual calculation visual calculation combines simplicity of the context from calculated columns and on-demand calculation flexibility from the measure. So they are as simple as calculating a column, but they provide you flexibility of runtime, because these calculations are done runtime. On-demand calculations, they are just like your measures. Compared to measure, visual calculation operates on aggregated data instead of detail level. So as I explained previously, this is going to happen on the data which is already given to your visual, and it is not going to work on the detail level data. So definitely it's going to provide you better calculation, better performance. Since visual calculations are part of the visual, they can refer to the visual structure, which is lead to more flexibility. So we have this challenge of having a concept of row, previous row, next row, etc. Now this can only happen in a visual. When in a visual we can call, okay, this is a previous row, this is the next row. So these kind of stuff can only happen at the visual level, and that flexibility is not available in calculated column or measure. In terms of visual rows only we are talking. So when the visual calculations were released, there were certain templates which has been released. Some of these visual templates for running sum, like I want to do a running sum. Moving average means average of from, let's say, row 1 plus row 2 plus row 3, and we can have a window of moving average, like I want moving average of 2 or 3. Percentage of parent means if I have a hierarchy, then I can have percentage of parent. Then percentage of grand total, very common. You want a percentage of grand total. Now, why to create a measure for that? You can have it using the percentage of grand total. Averages of children. So I have, let's say, brand level and category level data, and I want brand level data to be sum of category level, so that, or brand level data to be some average of category level, that I can do, versus previous row, versus next row, versus first in the data, versus last. These are some of the templates which are available. Now templates can use more than one function. There are functions which are available. They specifically has been given for visual calculation, but there are already existing functions which can also be used, and we are going to have a look at some of those. Now there is a concept of partition by and order by, which you might have seen in the functions which has been given to us some time back. Some of these functions are windows function, in offset function, index function, row number function, and rank, not rank, it's rank function. So there you have seen that concept. Now there, if you might have seen, there was an additional parameter at few places which is talking about axis and reset. So axis is one of the parameter which is very common in the visual functions or visual level calculation function. Now this axis is basically your row or column, depending on how you want it to use. So many functions have optional parameter which can be only be used in visual calculation. Axis influence how your calculation traverse in the visual matrix. So basically, you, instead of saying I want previous of brand, I can simply say I want previous of a row or a previous of a column. Now depending on whether you are using row or matrix, or row matrix row or matrix column. For a very simple example, matrix row or matrix column, then we can travel across row and columns. In any visual we have axis, like you have x-axis. So in x-axis I want to, based on the x-axis value, I want to go for the previous one. Now other than that, there would be reset. Why reset would be needed? Let's say I have a hierarchy. In the hierarchy, what would happen? Let's say I want to do sum of childs or average of childs, or I need those kind of calculation, then I need a reset. Now you sum up and then the reset start, and then you again get the next level. So reset should happen at the lowest parent or highest parent or none, or you can even use a number. So based on that, we can have the reset parameter. This is just very similar to partition by, where you want to partition. So specifically when you want to create MTD, let's say running some in MTD you want to create, you may want to reset, once the month is over. Now, these are some of the functions. Some of these you might have seen in the templates, but these are some functions which has been released at the time when the visual calculation has been released. Few has been added little later. These functions are designed to make sure you are able to do easy visual calculations. So collapse all, expand all, first, is at the level, last, moving average, previous, range, and running sum. Now what I'm going to do is I'm going to take you through some of these functions, and we are going to have a look at the file. In between, if there are certain questions, I would be happy to answer that. So let me share a file on my screen. I'm going to use this file today. This file is basically already containing a sales data model. So let me showcase you my data model before I start, and then I can, showcase you the visual calculations. I need to do a little bit arrangement so that the model comes. Okay. So in the center of this model, there is a sales fact table, and it is connected with date, item, geography, and customer dimension. They are master table or the dimension table. And all the joins are one to many single directional join, the perfect star schema you could have imagined. Now, sales is typically the retail sales data, and the items are sold in different geographies to different customers on different dates, and their different item brand. This is all cooked up data, but do have a good story. Again, this is available at my GitHub account, and I have already given the link of the PBIX where it is already being loaded. The same PBIX we are starting with. Now, let's start with a calculation. Let's say today, if I want to create a visual brand wise net sales. So I have a major net for which I created this visual brand wise net sales, and let me convert it into a table visual. It is not necessary to do that, but just for understanding, let's try it. Now let's sort it on brand also. Now, if I ask you, how are you going to get me the previous row brand? Now, if you are aware of index function or offset function or window function, which came really, very new, you may say, okay, maybe we can use offset -1. That could give us, okay. So let's try out, can we do, how easily we can do a measure to get the last row. So let's try first of all offset. We will do a little modification. Delta is going to be -1. I want previous one. Then relation is basically your table or your set of columns, and here in my case it could be all selected item brand, because brand is the only thing I have in the context. Then I need order by. Now if you don't give order by default is going to take what is there available in your all selected. I have one, so I can leave it basically, but just for our understanding, let's also give order by, which is item brand. Now let's first get what does offset give it to us, okay, and then we will try to complete this calculation. Let me rename it also as offset, or let me call it previous one. Let me drag it. Now it is not working because I just went to the offset. So I need to complete the calculation. So let's try out calculate net and then offset by -1. Let's try out this. So now you can see that my visual calculations are trailed by 1 row. So this is the value coming here. This is the value coming here. This is the value coming. I'm very happy with it. Now you went ahead and said, okay, no worries. I need this calculation on category also. What should I do now? I duplicate this. Okay, I have the calculation. Why don't I change this column with the category? Now this calculation is not matching with what I have in the previous, because my offset function was talking about what? It was talking about all selected item brand. Now to move from brand to category, I need another function which is going to be all selected category. So I cannot go and change it to category now. I need to write down another calculation. It means every time such thing happens, I need to go ahead and change it out. So this creates a lot of overhead. Now, is visual calculation can help us here. So now why don't we go ahead and, now we know that this calculation is not correct here in the second visual, but in the first visual it is correct. Now what I would like to do here is basically I would like if I can do the same job using visual calculation. So let me go ahead and add a visual calculation. First time I'm going to show it to you. So where is that option to add a visual calculation? So your visual should be selected. The visual should be selected. After that, go to the home tab. Under that, new visual calculation. So you will see this visual calculation here. And once you click on the visual calculation, you have some templates which you can use, or you can simply click on the icon. It will take you to focus mode kind of a screen where you can write down your visual calculation. So I would like to write down a new calculation which is previous to. And how would I like to do this calculation? We have seen few functions. So we have seen function like previous or last. These kind of function we have seen. So let's see the function what we want to use. So we want to use the function previous. Now in the previous function, it is asking for an expression step axis. What is my expression? Expression is net. Step is 1. And now it is previous. So step 1 means should be going into the negative direction. Let's try out this very simple calculation as of now. And as you can see, this previous 2 is matching with my previous. It means I am a row behind. I'm happy with the calculation, but what's the benefit? This previous one was also doing the same job. Why do we have another function to do the similar job? I was happy doing with the offset. Now let's try to change this first visual. So what I'm going to do here is in this first visual, now I'm going to go ahead and remember this is visual level calculation. I can't bring it into the second visual. So I go ahead and change this particular visual on category. What's the difference you observe? The difference which you observe here, now look at the calculation. This previous one is not working. It's not the previous row, but look at this one, previous 2. This is basically the previous row. So we have changed the row, but still we are able to do the visual calculations, or same visual calculation still applies. It means I don't have to do this entire rework of creating so many measures, handling so many conditions, is in scope, is filtered, has one value. Nothing is required. I just simply changed it and it worked. Okay. Now you created a visual calculation and let's say you want to edit it. Then how are you going to edit it? So go ahead. We will go ahead and click on this icon, edit icon. So this edit icon is there. I'll go back here. Now I can go and check out, let's say, other parameters. So it is talking about axis. What is the axis? Let's try axis with axis only. Axis with row. So what is our axis? Row. Not row function, only row. Let's try out row. It's not working. Rows. So rows is very similar. Basically, whatever is in the row category or brand, it is going to work on that. Now we can also use parameters like 1. Let's try that out. Okay, the same functionality is there. Now let me change it to rows and come out and do one more stuff. What happens if I add category as well as brand? Does this calculation still holds true? I add category as well as brand. Now let me move previous to little ahead. Or let me do one thing. Let me go to the calculation. There is a feature here. Now I don't want this calculation previous, which is not working. So what I would like to hide this. So let me hide this calculation. Now this is the only feature available only at the visual calculation level. We can hide the calculation and we can go back. Now previous is there in the visual, but it is not visible. Okay. Now again, you see these values are still working on multiple rows because we said, okay, do it based on the row. So the calculations are still holding true. Very happy with this calculation. Now let's look at some of the common calculations which I did. So how do I create some new calculation? So one of the ways, once I'm on the calculation, if I'm not editing, I can click on new visual calculation, custom, and it gives me here new calculation. Now I click on this FX, and one of the very common thing we do is running sum, isn't it? We want to do the running sum. That's very common. Let me do one thing. Let me remove everything and try out what does it do. Running sum. Running sum equal to field. What is the field for which I want running sum? I definitely want it for a measure. Net. Are there other parameters? Yes. Axis, blanks, reset means let's say now I'm using brand and category, and if I'm using it on the matrix visual, I will have a parent child and I would be able to reset. Okay. So it will become, instead of running sum, it will become the running sum within, let's say, brand or within category. So let's do it row wise. Optional parameter, but let's try that out. Okay. Now let's look at the calculation. It's matching with the grand total. So we understand, okay, this is actually an increasing calculation from bottom. So every row you can see the next value is getting added up. This value is getting added up. So we are getting a running sum here. Now let's go back. We have a running sum here. Now let's duplicate this page. One second. Seems like duplicate. Now let's say if I can use a matrix visual instead of table visual. So I'll go here and I'll convert this into a matrix visual. And let's move category back to the rows. Expand it. And so we have now let's look at the calculation, how it is happening right now. So brand 1 is the sum of these two. Then brand sum so what is happening here is, let's look at the last one. So last one is still the category 5 is still the sum of everything. It means what is happening is let's go one level up and let's understand this calculation. So if you see now here, this is still a running sum brand wise. Now let's go to the next level of hierarchy, and it is still a brand level sum. Even if we expand, now grand total will be a little difficult to understand, but this is a sum of these two, and here this is increasing, this is increasing, this is increasing, sum of these three. So it means our running sum is still working. Now let's try to edit this and add one more calculation, custom calculation. Same running sum we wanted to do now. So let me do the running sum. Again, I would like to do it for net. And rows, comma blank. Now let's go back. We can understand it here, but let's go back and try to understand this. Now what you see here is this is the sum of these two at the lowest parent. There are only two values, so brand is the first parent here, or the lowest parent or the highest parent, both it is, and then start increasing. But in spite of that fact, look at the thing, it has taken care that the brand level, the sum is still working out. So this turns out to be a really good option if I wanted to do, let's say, running sum. Now what I will do with running sum, I can have percentage of grand total. That's very simple thing which you wanted to do. So how do I do all these things on measures, percentage of grand total or something? How can we do in visual calculation? I have only one function running sum. How do I do that? So let's add one more visual calculation. And we want percentage of grand total. Let's see, do we have a template here? We do have percentage of grand total. So why don't we use it? Okay. So field, simple. Now I can use divide function here, isn't it? Net collapse all. Collapse all function is going to give me grand total. Okay. Net rows. Let's try this out. So I'm getting percentage of grand total. Now let's go back. So now I'm getting percentage of grand total, and very recently, if I remember correctly, on the formatting pane, we have been given option in the properties to data format these things, and instead of decimal number, we can use it as percentage. Let's see, do we have an option for percentage? Let's write down a custom format. Percentage. So now I'm able to see percentage. Now this feature has been very recently enabled for visual calculations, because what happens when we do percentage of GT, how do I do visual calculation? It is not available at the model level, and there is no calculation available at the format level because that was not known. So now we have the calculation also, formatting also happening at the three levels. And so visual level it is happening, at the model level it is happening, and then we have the individual formatting of the let's say labels or all the items which are there, like, so we can do the formatting for all those. So there are three level of formatting which is available, and this is one of the formatting which we were needing for the visual level calculation, so it is available here. So I am able to format it also at the visual level. So we are able to use these visual calculations, but what I'm doing here is I'm showcasing you all the functions which are came very recently. Second is, we have one question. that, okay, you are changing brand to category, but you are a developer. You are changing it. Can it work on field parameters? Because that's how we change the access. End user is not going to change. Now, till last month, this feature was not supported. And very recently, there is an announcement that field parameter has been supported on visual calculations. I've also not experimented, so I'm going to experiment with you together that the visual calculations, which has been there for like half a year now, can they work with visual calculation? Can they work with field parameters? So let's go back to our page 1. And here, let's make this visual a little simpler. And in this one, we have 2 visual calculations, previous and running sum. Now, let's try to create a field parameter. How do we create a field parameter? So, in between, if there are certain questions, let me check out. So first of all, I'll give the starting file, and let's see in case it is reaching to some of you on the who's watching on the YouTube. Let's see. Okay. Meanwhile, I'll continue. I don't see any comments or chat right now visible to me on the StreamYard. So let's try to create a field parameter. So I'll go to the modeling tab. And in the modeling tab, I have this option new parameter. Let me click on the new parameter and I'll click on fields. Now fields is something which we also call field parameters or field parameters. Once it is there, I can either opt for axis field parameters or a major field parameter. Don't try to combine those. So I would try to create a field parameter for my axis. And for that, from the item table, I would like to bring brand, category, subcategory, and from the geography table, I would like to bring state and city. And then I would like to click on create to create this field parameter. I can also rename this parameter as access or maybe access1. There is an option to add slicer on a page. It will automatically add a slicer on a page. I don't have to even do that. So let me create this. Okay, so we got a slicer here. Let's make it a little smaller. And we don't need the first visual, so we'll delete it. Now I got my axis. I have this visual which is right now running on brand, and I would like to now run it on axis. So I'll go to the axis on the right hand side, and from there I'll drag the axis here, and I'll remove the brand. Okay, let's see what happens. It's doing some job, but in between what I can do is I can click on the brand. So it is brand wise. Now I'm clicking on category. Now look at the calculations, the previous calculation and this one. Okay. And this is the running sum. As you can see, this is increasing. And as you can see, this sum is increasing and it is matching with the grand total. It means the running sum is also working. So it is working category wise. Let's look at the subcategory wise. Again, the previous row, the matching with the previous row, 200K for the subcategory 11, 200K for subcategory 12. So previous row, it's matching with that. State wise, let's check it out. It's working there. So what's happened? The new feature released a week back we have this very good feature. Now it is working with the field parameters. So now we are doing one calculation. Let's say we are doing previous, compare with previous month or previous year, and then I don't have to do, okay, if when the month is in scope, then do MOM. Then if the quarter is in scope, do QOQ. When day is in scope, do DOD, date on date, and I create so many complex formula. Whatever is by context of the axis, or whatever by axis is there, based on that, my visual calculation will automatically adjust. So I will, when it is year, I'll get YOY. When it is month, I will get MOM. When it is quarter, I will get QOQ. Such a easy calculation. So that's bring a lot of flexibility in our hand. But a question will come to your mind: are we limited by the functions which has been provided newly, or can we use some of the existing functions? And especially the very powerful Windows function, the set of 5 functions: offset, window, index, row number, rank. And let me add rank X to it, because I've already tested out these functions. Window function do have a little bit of challenge. When I tested last time, it may or may not work on the visual calculations. It will get supported, but yes, it has all the ingredient. You can make it support. We have a range function here, very similar. Means you can do the sum of a range or a window. You can do that. So now what I would like to do here is, let's duplicate this page. Now we got a lot of flexibility here. So why don't we duplicate this page? And now let me remove some of these visual calculations. I'm done with that only. Now I would like to add one more calculation here. And now I would like to use offset function. So let's go to a custom calculation and see can offset help us. Offset -1. So calculate, same calculation we'll try out here. Calculate net offset. So it's asking for delta. Let's give -1. It's asking for relation. So I don't want to give any relationship. I'll say take it from those. And what is my order by? Let me try if I can take net in the order by. I'm not giving axis or row. I'm not giving my row. I say why don't you take a major net here? Okay. And if you know the recent feature of offset function, they have been changed a little bit after they have been released. That previously everything need to be part of the relation. It need to be part of order by or partition by. But now majors have been excluded from that limitation. So major can be part of order by, or even if they are not there. So it's talking about relationship, partition by, match by, order by, some of missing. So let's try order by here and let's see, does it work? It's not working. Something wrong with this calculation. Let's try out. So offset -1 rows net. Let's try out only offset first of all. Okay, give me a second, just checking it out. Let's restrict it using rows as of now, and let's see what happens. Let's also put a calculate now. Calculate net offset. Okay, so started working. Now we have to understand these calculations. First, let's go back and sort it on state. Now you can see the offset is started working here. and it is one row behind. So we are able to use the offset function also. Now let's try to edit it. Now let's try to give order by again. Now let's try to see what mistake we were doing. So for order by, we have to use order by function. We can't simply give an order by. So order by net, and how do I want it? How was my order by? Actually, my order by was descending. So I want to give descending here. So now we give an order by function, and let's go back. Let's sort it on net. Now you can see that the offset function is actually giving me a -1 row based on sorting of my major. It is not sorting of my axis. So it is making my visual calculation even more powerful, that now I have choice of my measure in the offset function, and this offset function doesn't need a relationship which is fixed. Is it true? Does it need, have we used state? No. So can we use subcategory? And is it still going to work? Look at this. This is still working. It is working with subcategory. Can it work with brand? Yes, it is. So one calculation which has been done, and with the field parameter, with the index function, the sorting is now working. But can this sorting also be dynamic? And this is, as I said, I have not even experimented with visual calculation. So I would like to see, and this is going to be really interesting. Can I use the major field parameter inside this? So let's try that out. So we go to the modeling, and this is something we are trying together. New field parameters, fields, and let's call it major one. So we check out, is it going to support majors also? So net, gross, COGS, margin percentage, discount percentage. And let's add this to the pane. So we have all the majors what we have. Click on create. Yeah, I have another slicer here now. Now how to use this visual calculation into my visual? So I can bring in this major here in my visual. And let me check only one. Let me check gross. So I have gross, I have net. And let's not talk about the formatting. We can work on that a little later. Now my question is, can this offset function somehow take this measure? So I change it. I don't even have to bother about let axis change, let measure change, and the calculation continue to work. But now the moment I use that, let me now try out new visual calculation. And again, let's try to do the same. We'll not call it offset 2. Calculate. Now, first of all, what to calculate? Measure 1. Can we use measure 1 here? Okay. So measure 1 is right now gross, actually. Are we able to use gross? So we are not seeing that. We are not seeing the major calculation. Okay. And then when I try to use offset, I'll use -1, rows, and then order by. If I go to the order by, again, can I use measure 1? No. Let's write down forcefully. Measure one measure. Now it is not available in the visual, but forcefully we are writing down. They are writing down both of them forcefully. Let's try that out. So this is something which is right now not working. So we'll move ahead without having this. So let's remove this from the visual. So now we have learned how we can use the axis in the field parameters to make it dynamic, and we have already done some calculation using existing functions as well as some of the new functions which has been provided to us. Now there is a very common stuff which you've been asked, which is either rank or a row number, and the functions which are there with us, the rank function, the row number functions, they work with it. So why don't we go ahead and try that out? So let's try out the rank function first of all, the rank x function. And the reason for it, because rank x is a little different from your row number and rank function, because they are very similar to index offset. So we know, okay, this is working, maybe this also works. So rank x, table, rows, expression, net, values we leave it, order by descending, ties, dense. Let's try all this. And as you can see, we are getting a rank. And let's go back and understand this. This is the correct rank, isn't it? For brand wise, this is the top brand by net. So let's try that out. Let's try to change it to subcategory, category, brand, state, and city. So we are able to use this now. Now what we are going to do is we are going to use the row number function. And this is also acting as your row. So basically, if I have a visual and I need the row numbering, I can get it using this one. So let's go to the home, click on the visual, new visual calculation. And inside this new visual calculation, let's use row num. Function is row number. Relationship is rows. Order by is net, comma DESC. Blanks partition by everything I would like to leave as of now. Let's go back to the report. Now, as you understand, the difference between the row number and the rank would be the rank based on the ties. It will, so if there are two number having the same value, the rank would be same, but row number would not be. You can break the ties easily now. It will automatically break if you don't give. Otherwise, you can also specify additional order bys to break those ties. But row number would always be unique, continuous number. So you got a row number, and now if it is a table visual, let's say, so then you can actually move this column as the first one, and it's very easy for you to showcase it like a row. And definitely we have the properties data format, so we can call row number as a whole number. So we can give this. So now in matrix visual, we don't have a functionality where we can move this measure or the visual calculation as the first column. So we'll not be able to do that, but at least here we have the flexibility that we can on the table visual we can showcase it as a row number. I understand still it is a calculation, it's not a group by, so it's not something which is grouping your data, it is just one thing which is displaying your data. Okay, so it is little different. Same way we can format the rank. at the visual level. So now these are the various functions we have explored, and let me see if there are any questions here. And let me check with Charlie. Are we having any questions which has been asked on YouTube or somewhere where we wanted to answer some of those?
No questions yet at the moment there, Amit. Feel free to continue.
Okay. So what we are going to do is for next 10 minutes or so, we'll do a few more calculations. So let's go ahead, the new visual calculation. And let's look at the versus first. Versus first means I want to compare with the first value. So what is the field? My net field. So I clicked on versus next. Let me change that. FX versus first. So the field is net. Let's look at the argument of the first function. Net, comma, axis, which is rows, blanks and reset. We don't need it as of now. Now to understand this, let's go back. Let's change the sorting to the state. Now let's move a little near to the axis. So definitely there is nothing before Alaska, so it is the difference is 0. Okay, then net is, hold on, we're doing versus first value. What is the first value? 90,000. So first value is 90,000. The second value is 470k. So subtract that 90. So we'll get 381. Now the third value is 1.3 million. Subtract 90 from there, we got 1.2 million. Third value is 270k. Subtract 90 from there, we get 181. So this is versus previous. The first value I'm comparing with the very first value. So sometimes you come across a situation that I want to compare it with one particular value and I want to get the difference from there. So versus first versus last. This is something again which you can do easily. And now look at the calculation, how easy it is. Now think about that you have to do the same calculation in a DAX measure. Not only this, when you change it, it should work. So now when I change it, it is working for category for me. So how much effort you have to do to make this calculation work as a DAX measure? You need to write down a real complex measure in such scenarios to make sure that these things work. But with visual calculation, it is just like, very small calculation. This current calculation minus first, that's all. And you're done. The axis is changing, the calculation is changing, adjusting to itself. And we don't have to bother about, okay, what is in the scope right now. Let's again click on the visual and new visual calculation. And now let's try the index function, which is also can do very similar job, isn't it? So right now I'm comparing with the first. Can I compare with second or third? Isn't it? But previous function doesn't allow me. First function was not asking me a parameter first, second, third, fourth. So can't I use the index function for that? So let's try index function. Index 2. Calculate net index position, second position. I want the second topper. Relationship is rows. Order by, do I want to order by the axis or do I want to order by the measure? Let's type by measure. Order by net comma DESC. Second topper I want. And then I can subtract it from net. So I want to know the difference from the second topper. How I'm standing against my second topper. So some calculations are coming. Let's go back and understand. So we go back. We now sort it on the net. Now what is my second topper? This is my second topper. This is my value for the second topper. Now, as you can see, the second topper, the index 2 would be 0, 183, 256, 2,567 minus 183. This is the difference from the second topper. This is 1.7, this is 1.8, so little negative. This is 1.1, this is 1.8, so little more negative. This is only 615, so this is little more negative. So we are now able to have our visual calculations based on a function which is previously given to us of index, and now we are not only comparing it with the first topper or first value, we are also comparing with second value, third value. Same way offset can work both the direction, ascending, descending, +1, -1, so we can have that. So in this manner, what is happening here is basically we are able to use some of the existing functions which has been provided to us, and we are also able to use the new function which has been provided to us to do all these visual calculations, which is helping us to do all these things really quickly, and we don't have to change our calculation if our axes are changing. So it's so powerful that your axis can change and still you don't have to change your visual calculation. As we are nearing the session end time, just last one calculation, custom, and we will use this calculation range. Don't have here, let's use the range function. Steps, 2 steps, include current, axis is rows, let's try calculate net.
Couple of minutes left there, Amit.
Okay, fine. Let's wrap it up. I think there's some problem with the syntax. So any questions which we have, we can take those up. I'm just crossing this out.
Yep, looking at the comment section, there aren't any questions at the moment.
Okay. Fine. I think so. Thanks everyone who has joined this one. I hope you now understand the power of visual calculations, which you can use and do real dynamic calculation at the visual level. So go ahead and try that out, and you can comment on the video, and I can check out a little later that in case you need some more information.
Thank you very much, Amit. Thank you very much for the session, and thank you very much for all of the effort put into the demo. We've shared your link as well for the PBIX file, and so people can also take a look at it there as well. Coming up in about 1 minute, we have Pragati Jain, who will be talking to us about demystifying semantic link in Microsoft Fabric. Let's see how we can put her on there now. And here she is on the stage. Hello there, Pragati.
Hi, Charlie. Can you hear me properly?
Yes, we can. Hear you very well.
Okay, cool. I'm good. How are you?
Very, very well, thanks. Thanks for joining us. We hope it was easy enough for you to join the stream yard and everything like that. We're looking forward to hearing your session.
Oh, definitely. Yeah, I'm looking forward to it as well. Should I start?
Great. Yes, feel free. I'll come off screen.
Okay, thank you. Okay, so welcome everyone to my session today at Data Bash. First of all, thank you to all the organizers who are involved in bringing this conference together, because without their contribution and their effort, we would not be able to share this knowledge and understand different aspects of technical things on such a massive platform. So thank you to the organizers for organizing this conference for us. So, and secondly, thank you to everyone who's joining my session today. And today I'm quite excited to talk about semantic link in Microsoft Fabric. So today I'll be talking about this particular subject, and let's see what all we learn together. Just a quick update. I'll start with my introduction first before we go ahead and look into presentation. So a very quick update from my side. I'm not sure how many in the community know. I recently took up a new role of a mother, and my little boy has turned 8 weeks today. And I'm quite excited to be on Data Bash, starting with my engagements again after a break of 2 months. So that's something new update from my side. And apart from that, those who know me in the community, I'm a Microsoft Data Platform MVP. I'm also a super user at Microsoft Fabric community. So if any of you guys don't know about this community, definitely go and look for it, because this is the place I completely vouch on. I completely trust this platform. I have learned most of my Power BI and now Fabric from this amazing community. If you're not there, definitely go and join the community. I'm sure you're going to learn lots from this Fabric community. Apart from that, I've got nearly 10 plus years of industry experience, and currently I'm working as an analytics manager at Avanade here in London, United Kingdom. Outside my work, I'm also one of the organizers at Data Weekender conference. So Data Weekender is again a virtual conference like Data Bash that we do once in a year, and please watch out for a announcement soon for the next Data Weekender, which we are going to organize soon. And I'm also manager at Microsoft Fabric UK user group. And it's again a virtual user group that I run alongside Leon Gordon. And we welcome all kinds of speakers, and we very much, promote the new speakers. So if any of you guys are interested in starting with your speaking journey, or you want to share your knowledge, definitely reach out to me or Leon on any of the social platforms like LinkedIn or Twitter. One fun fact about me is I like to paint. So I just like to call myself a techie artist, because I do a lot of technical stuff and also being a painter. So that's the term I came up with. Okay, so a lot about, so that's something about my introduction. But yeah, let's dig into what we're going to talk and look at today. So just starting with the agenda, the first thing is I'll be going through the theoretical aspects of the PowerPoint deck very quickly. I don't believe in showing the slides and other stuff. I believe more in the demos. So we'll go and see the demos quite shortly, but still let's go and see the overview of semantic link, like what this is within Microsoft Fabric, how it can help us. And after that, we'll go into the demos straightforward. But one thing before I start or dig into semantic link is, like, if you're coming from a Power BI background like myself, in this session, I'm really going to show how semantic link can be really helpful to Power BI developers like me. It's not just about, something that data engineers or data scientists can use, but it is something we as Power BI developers can use as well, and make most of it while using it within Microsoft Fabric environment. So let's see what is semantic link first. When it comes to semantic link, I'm not sure how many of you have dig into this particular aspect of Microsoft Fabric, but in the last few months, semantic link has actually become one of my favorite areas within Microsoft Fabric. I've been working with Fabric for more than a year now. I've worked with some customers as well, helping them implement Microsoft Fabric. But the moment I started to look into semantic link, it kind of, wowed me with so many things. It kind of showed me so many different capabilities and strengths that as a Power BI developer, I can leverage within this particular platform. So when it comes to semantic link, if we look at the very straight definition, like what semantic link is, it basically helps to establish a connection between a Power BI semantic model and the data science experience. So those who come from Power BI development or Power BI developer background, they understand what semantic model is. And semantic model is basically the foundation of whatever you do on top of it as part of analysis or insight generation. So as a Power BI developer, when we generate semantic model, then we can actually use semantic link to do some kind of analysis on top of it to understand what the model contains, the details in the semantic model. Like, for example, what all tables are there within my model, what kind of relationships I've got within that model, what all measures or calculations I've created on top of it, what calculation groups I've got within my model, or the hierarchies. But why use semantic link? That could be the first question. I mean, people can ask, like, how will I use semantic link as a Power BI developer or as a data scientist or a data engineer? As a Power BI developer or data modeler, when I create a model, there could be other teams within my organization that may need to understand what my semantic model contains, and they might have a necessity to do some kind of analysis. Like, for example, data scientists might need to understand the details of my semantic model so they can run some kind of predictive algorithms or machine learning algorithms to predict something, or maybe do some other level of analysis. And what they can do is they can actually feed their all the outputs, all the results in a one lake, which is the strength of Microsoft Fabric. And from one lake, a Power BI developer can actually consume those results for further analysis or insight generations within Power BI. Now, the best thing about Microsoft Fabric is, like, it kind of gives you a collaborative environment, right? I mean, within an organization, there's never a team. There are multiple teams working on the same aspect of a project. So as a Power BI developer, I would do data modeling and report generation, but there could be data scientists and data engineers who might be working, like data engineers will be working more on helping me cleanse data, format data. Data scientists will help me more on doing predictions on my data and understand how my data is going forward using the historical data. So this semantic link can actually help you bridge that gap between teams as well, because as a data modeler or Power BI developer, if I have created a semantic model, I understand every aspect of it. But say if someone in my team as a data scientist, they want to understand more around what's in my model and want to generate something more on top of it, then semantic link can help them understand and generate and analyze the details within the model. And we'll see that in the demo, like how we can do that. But again, as I said in the starting, we are going to look at this session how semantic link will help more Power BI developers like me to build their strengths within their platform. When it comes to semantic link, we have already talked about it's like a data connectivity between data science experience and your semantic model. It helps in propagating all the details within your semantic model. It actually works with notebooks. So if you have to use semantic link, you have to actually write down some code in notebooks, and then that you can actually help analyze what your semantic model contains and what else you can do with that information. So if you have to use semantic link, you have to learn how to code within the notebooks. And we already saw this, that it kind of bridges the gap between the Power BI semantic model and data science experience. Now, when I talk about semantic link, as I said, to use semantic link capabilities, you have to learn coding in notebooks. Now, as a Power BI developer, I haven't coded before, but I would say this honestly, notebooks have become one of my favorite part within Microsoft Fabric. I mean, it has helped me upskill myself as well, but it has also helped me to learn something new that I haven't done before out of my comfort zone. Now, if I have to use semantic link using notebooks, then there is a Python library called SemPy, which supports this functionality. And it helps you to, extract certain kind of information from a semantic model, like the tables used in the model, the measures that you have created. You can get the relationships within your data, within your semantic model. You can also execute some DAX queries to understand and analyze your data in a different way. Another thing about SemPy Python libraries, it actually supports all these Spark native connectors. So if you haven't coded before, if you know Python or PySpark, then you understand what I'm talking about. So if you're coming from a SQL background, you can actually still start coding, because in notebooks, you can actually write a SQL query. If you know R, if you know Python, you can just go and start cracking with notebooks. This we have already talked about, but just to highlight, as I was mentioning earlier, that semantic link actually helps us propagate through the details of a semantic model. It also helps us to navigate and, access the information, like, for example, different data categories within my model. For example, geographic data categories like address, place, city. If I've got URLs, then web URL or image URL. If I've got barcodes within my semantic model, that also I can navigate. It also helps us navigating the relationships, which we have already talked about, and hierarchies as well. So if I have got hierarchies within my semantic model, I can get that information using semantic link. Now let's get into demos, because this was just about the theoretical information, but let's just see how the demos will help us. I'm just going to put my other screen in there. If Charlie, you can just confirm if you can see my browser screen here, where I've got my Fabric environment open. I hope you can see my screen, guys. Charlie, can you confirm if everyone can see my browser now? Okay, cool. Thank you. Thank you, Charlie. Okay, so before I dig into the semantic link demos, I want to start with something what I've got already. So this is a Microsoft Fabric trial capacity workspace. What I've got in here, you can see I've got few items already created here. And you can clearly see I've got a lakehouse, I've got a semantic model there, I've got a report on top of it. Now, again, as we are trying to understand what semantic link can do, let's dig into the semantic model, what I've already got in place here. So let's go into this semantic model first, just to give you an understanding what it has got. So I'll just open the data model here. So this is a very simple data model that I've got. If you, I'm sure many of you are already using Contoso Sales data or AdventureWorks. So yeah, this is the Contoso Sales data that I've got in here, and it's available online. You can just freely get it and use it for any kind of, learning that you want to do. It's freely given by Microsoft, so you can just use it. So it's a very simple semantic model. I've got a fact table. I've got few dimension tables. You can already see here, it's not a perfect star schema. It's a snowflake architecture here. That's fine. It works fine for me in this scenario. So yeah, I've gone for it. You can see there are some kind of bidirectional things also happening here. But yeah, we'll see. There's a reason why I put them there, because we are going to analyze the semantic model at different levels now. So simple semantic model with my sales table, and I've got some different dimension tables going on here. Then showing you a few more things. I've got some measures already created. So I can see, like, I've got the measures, I put in description alongside them. I've given them proper formatting. I'll show you why this is done here, so that, we see some semantic capabilities while assessing this semantic model. So I've got all these measures already here. I don't have any calculation groups going on within my semantic model or calculated tables. It's just the measures, tables, and relationships here. So this is about the semantic model that I have got. And using this semantic model, I just created a single page report. It's a very simple report, nothing. Just don't judge me on my visual aspects here. It was a very quick report creation. On the left, I can see overall revenue by country, and on the right, I can see revenue over time, discount on the products over time, and margin over time. It was just done quite quickly. So this is the report I created on top of this semantic model. Now, when it comes to demo, we are going to look at few different aspects of the demo. So, sorry, I started it in the wrong place, but let me just navigate to the last demo slide. Yeah. So in the demos, we are going to look at 4 different aspects today. First of all, we are going to understand what kind of relationships we have got within semantic model using SemPy library. Then we are going to check what kind of measures and measure definitions we have within the model. And we'll also see how we can evaluate these measures using this SemPy library and can analyze the measure output at different granularities or at different categorical levels or groupings. Then we'll also see how we can use SemPy library to understand model optimization. Now, if you are developing data models or semantic models, you understand the importance of model optimization, because your semantic model serves as the foundation to everything that you do on top of it. So if your model is optimized, if it's in its best shape, then it just works perfectly fine if you do anything on top of it. So optimizing a semantic model is the key aspect to designing it. It's not just that you create a model and don't optimize it. Otherwise, it's going to hinder a lot of processes while you're working with it. So we are going to see how SemPy library within SemanticLink can help us understand what kind of optimizations we can do on a model. And then the fourth scenario will be how we can analyze a report which is built on the semantic model to understand details like what objects are used on the report, what filters I have created, what measures I have created, what all visuals I have got, what all number of pages I have got within my report, if I've created any bookmarks or anything. So we'll see these 4 different scenarios within SemanticLink, how it can help us. And during these demos, I'm really going to tell you certain reasons why, as a Power BI developer, it's really important to learn now to code in the notebooks. If you are really working with Microsoft Fabric, just creating models and doing report is not going to help going further. You have to, expand your challenges and learn something new. So let's dig into the demos directly. So again, I'm coming back to my Fabric environment. I'll just go back to my workspace now. Let's start with the relationship demo first, like what kind of relationship aspects you can do. So I've created I've already pre-created notebooks because obviously I didn't want to type every single line of code within my notebook within this 1 hour session, because it will just take the whole time. So yeah, writing code takes time, and I'm no PySpark expert. It takes me time to generate it. So yeah, I pre-created things, but we'll still go into details like what these notebooks are actually doing. So let's start with a relationship demo, like how we can use SemanticLink to understand the relationships within our semantic model. So I'll just open this notebook and yeah, let it load. Yeah, while you're presenting, things are slow. So yeah, we'll give it a time. We'll give it some time. Perfect. So this is the notebook that I've created, and yeah, I'll share you some resources in the end. Everyone can create them. There are pre-written codes available. So Michael Korosky, who's actually the creator of this SemanticLink, he is the principal program manager within Microsoft. Thanks to his work, because this has just really helped us, because he has given us all the notebooks pre-created, and we can just modify them a little and make them work that suits our needs. So thanks for his work for bringing this SemanticLink feature to Microsoft Fabric platform. So what this notebook is doing, we are going to understand what kind of relationships we have built within the semantic model that we just saw. So let's start. So what this first code of line block is doing, it's just installing my SemanticLink. So it's kind of installing all the necessary packages that I want. So I'm installing SemPy library basically, and that's the library, as I mentioned earlier, that helps us navigate all the information within SemanticLink capability. So once I do that, then the next thing I do is I actually install or import all the necessary SemPy modules that are required to understand relationships within a model. So yeah, you can see there are a few different things happening here. Don't worry about the code. I'll be sharing the resources. You can see, you can have these notebooks there already. I've just modified them a little bit just to make sure it works within my requirement. Then the next thing what I do is If I go back to my workspace, now within my workspace, now whenever you get some data within a Fabric environment, what it does is by default, it creates a default semantic model as well. So like, for example, within my Lakehouse, I've got a Contoso Lakehouse semantic model, which is actually the default semantic model created. And on top of that, I created another semantic model just to work with my needs and requirements. So if I want to see within this Fabric Contoso workspace, like what all semantic models or or data sets. I don't like to use that data set word, but somehow the function that's been created is list underscore data sets. So if I want to get a list of all the semantic models within my current workspace, I can directly use this function called list underscore data sets. The moment I do that, it kind of shows me all the semantic models that are available within my workspace. So I can see my custom semantic model that I created as well. So I can see everything in there. But what I really want is I want to assess relationships within this particular Contoso sales semantic model. Let me also open the other screen on the side in case there are some questions going on. So let's go to the next step. Now here, what I'm trying to do is I'm trying to understand or list all the relationships within my particular semantic model. And once I do that, what this notebook does is it kind of just simply, I'm just running like 3 lines of code to understand the relationships within my semantic model. And the moment I do that, I get a list of so much information here. So you can clearly see, I can see all my tables here, from table to table, and then I can see the column on which the relationship is there between these 2 tables. So like, for example, let's take an example here that fact sales table is related to my channel dimension table on channel key column, and the relation is many to one from my fact sales table to dimension table. And I can also see that what kind of cross filtering is there. Like, for example, this relationship is active. I've got one directional cross filtering here. I can see some kind of security filtering going on here as well, and some additional details which we can see. But yeah, how cool it is. I mean, I can always check these things by going into my semantic model, but why not if I get this information simplified in a simple tabular form? It makes that information so clear to me. I mean, not just for data scientists. As a Power BI developer, this is more clear option to sorry, is my screen not readable? Just checking. Let me know if you guys want me to zoom in or zoom out. Yeah, I mean, let me know if this is more better. I know, Roman, you have added a comment. I'm not sure if it's for me. Just put a yes or no if this is what you meant. If that screen was not visible. So I was like, as a Power BI developer, this is more readable, is in a more readable format. I mean, I can always go back to my semantic model and see, okay, what all relationships I've got, how the relationships are built between the tables. But when I have that information in the form of a simple table, it's just more readable, more consumable. So that's why this is one of the reasons, like as a Power BI developer, why this can also help me, not like just data scientists to help understand the semantic model information, but as a Power BI developer, to understand the information in more clear way, I can just learn to code a little bit and just get this information out here. Similarly, further down the line, say I can also plot this, metadata information here, like whatever I got here at the top, like what kind of relationships are there within my semantic model, I can actually plot it in a nice small visual aspect here. Now, again, I come from a Power BI world. I mean, I love seeing the visual aspect of things. So this semantic link, actually, this SemPy library actually gives me the capability to see my relationships in like quite a good, nice plot here. So this is why I really love the notebooks feature. I mean, we have in Fabric, because you have everything within the same environment. You really don't have to go to a third-party environment to understand all these aspects. Definitely, we are not talking about them right now, because like, for example, I can go and talk about external tools for so long, because they are one of the most important and most used things as a Power BI developer. So, but still, having everything within the same environment works for me, because that's what the foundation for Microsoft Fabric is, having everything at a single place. So if you have got everything in here, it just works perfectly for me to just understand what my model has got. So this was around like how we can, understand the relationships within the semantic model that we have created. Now let's look at the other demo where I was talking about how we can understand the measure definitions within the model and how I can actually evaluate those measures if I need to understand something at different levels. So let's go to I'll just go back to my workspace. And I'm just going to open another notebook. And this notebook has got the measures demo. So let it load. And I'll just minimize this. So this notebook again helps us to understand like what all measures or calculations I've created on top of my semantic model. And on top of that, I can also evaluate those pre-created measures at different levels to analyze my data at more. So again, I'm installing the SemPy library here, same thing. I'm importing the necessary Fabric module here. Again, I start with extracting all the data sets within my workspace. Here it is Fabric Contoso workspace here. The moment I do that, I see all the semantic models here, but I want to understand everything on this particular semantic model. So I'm going to extract the list of measures from my particular this semantic model. And once I do that, I again get a nice tabular format listing down all the measures that I've created on top of this semantic model. So again, I can see, okay, I haven't got many measures here. I've just got 5 measures, but it still tells me, okay, under which table I've created my measure, what is my measure expression, what is my measure data type, is my measure hidden or not? And obviously I have consolidated or organized all my measures within a folder called measures. So it's showing me that as well, like what folder my measures are organized under. And it also shows me the description that I've given against my measures on my semantic model, and also the format of my particular measure, and so on. I can see a few more details like data category, which I haven't given for any of these measures because they don't need to be. So this kind of information, again, at a single place, I understand, okay, obviously I can go to my semantic model and see what all measures I've got, but I have to click on every other measure to understand what this measure is, what's the data type of the measure, what its definition is, what its description is, what formatting is given. But when I run this simple line of code, I see everything in front of my eyes in a single click. I really don't have to go to every other measure and see what that measure is about. So this kind of, again, helps me in understanding, okay, this is what all I've created on top of my semantic model. And again, that's why I like coding in notebooks, because it just makes my life easier. I see everything in just writing 2-3 lines of code. Then the next thing what we are going to look at is, okay, I've got these measures, but say if I want to analyze them at different categories, or say at different column levels that are within my dimension table. So like, for example, take an example where I want to understand my measure total sales. Now, once I evaluate that measure, okay, I just get an overall number, okay, what these total sales is on top of my whole data. But what if I want to understand my total sales by, say, channel or by, say, product name? So I can, again, evaluate this measure at different, so like I've got a channel dimension table and I've got a product dimension table. So I can understand how these sales have been at a product class and at a channel level. So this just helps me understanding that distribution around different aspects of dimensions that I've got within my semantic model. Again, further down the line, say if I want to understand or evaluate this measure at different groups, but also for certain brands. So like here, what I'm trying to do is I'm trying to understand how my sales have been for different product brands, and my product brand should only have these 3 different product brands. So once I do that, I can understand the distribution of total sales generated by these particular 3 different product brands. So it kind of, again, helps me understand what's really happening within my data. I could do that in Power BI, drag and drop these columns and then get it done. But suppose if I'm not creating a report at this stage, I want to understand everything before I go to the next step of creating the report, then this just helps me in understanding that ground level information, like what's really happening within my data, so I can understand and then try to frame things, okay, what kind of insights I can create on top of this data or what I've got. Similarly, say if I want to analyze it at like, say I want to analyze two different measures. So I can analyze using this evaluate measure function at say different channel and product class name. So I can again get that kind of distribution at different channel and product class. So this is how this can really help. I mean, we can do this very easily in the external tools that we have got. But suppose like the only challenge with external tool, what I sometimes see is like, for example, I'm working with a client where they don't allow me to download these third-party external tools like Tabular Editor, or say I use DAX Studio a lot as well. Then there's a challenge. How do I do this kind of analysis? And then this is the way I'm able to do, because I've got everything within the cloud, within my Fabric environment. I really don't need external tool, because this is kind of helping me to not wait for the client to, approve the download of these third-party tools, because sometimes when we work with clients like banking, they really don't allow you to download these things. They just block everything like these third-party tools. So when I'm in certain situation, writing a simple notebook can just help me do this. I mean, this is the main reason why I really love writing notebooks and using semantic link, because it kind of helps me understand everything about my semantic model. So this is the second demo we have got. I think there's a question. Do you know if semantic link is available within Databricks, or if there are similar options for querying Power BI semantic models using SQL or PySpark? Roman, I haven't tried within Databricks. Sorry about that, because I haven't used Databricks so far. But if you're talking about if there are options for querying Power BI semantic model using SQL or PySpark, so that's what this notebook is. I've written all my code in PySpark. If you want to write this code in SQL, you can do that as well. Let me know if that's what you're asking. If there's something else, go ahead and reiterate your question. But yeah, you can write this notebook in all these available languages. So if you come from SQL, if you're comfortable with SQL, you can write this notebook using Spark SQL. I'm comfortable with PySpark, so I wrote these notebooks in PySpark. So let me know if that answers your question. But yeah, I haven't worked with Databricks, so I have no clue about that, if semantic link works within Databricks. So this was the second part of the demo that we wanted to see. Let's dig into the third part of the demo, which is one of my favorite part, model optimization. So let's see how we can understand the optimization aspects within our pre-created semantic model. So if you have created a model and now you want to understand what's really not working right in your model, or is your model really have got everything from the best practice point of view, how big is your model? Can you optimize it further down? Are there any unused columns within your model? So let's see if we can find out that kind of information using semantic link. So again, I'll go back to my workspace, and I've got already another notebook for it. And here I'm just going to open the model optimized notebook. I'll let it load. Okay, so we have got the notebook, and this notebook again focuses on how we can assess our semantic model so our model optimization can be easier for us. Again, I'm installing some relevant packages here. I'm installing the necessary libraries here that I would need to understand the model optimization. Now, if you have worked with external tools, like, for example, Tabular Editor or say DAX Studio, one of the main key feature that these external tools give is they help us understand how our model is. They kind of help us understand at a overview level a summary of a semantic model, like what tables I've got, what columns I've got, what are their sizes, what's the overall size of my data model, can I actually go ahead and optimize them. And the key thing what these external tools have got, they've got the capability of running Vertipack Analyzer. But when we see the semantic link, I can actually run Vertipack Analyzer just in a simple notebook. Now, in this case, what I'm trying to do is I'm running Vertipack Analyzer again on my semantic model, which is within this workspace. Once I run that, I end up seeing model summary. Like, for example, if I click on model summary, I can see, okay, this is my semantic model. Total size of this model is this. There are total 9 tables within my model. There are total 128 columns. It's compatibility level, and currently it's in an import mode. That's what my model summary is. Further down the line, I can actually see table level summary. So I've got all the tables. I've got a number of rows within those tables, their size. I can see whether they've got any hierarchy or not, a number of columns within the tables, and some more information. So if you have used Vertipack Analyzer in other external tools, this is a very similar information that we get here. And that's what we do as data modelers or Power BI developers. We understand how our data semantic model is, and then we find out the areas where we can actually go and optimize the data model. So this kind of understanding what I've gotten in this same environment, for the very same reason I mentioned earlier, the challenges where I couldn't download the external tools, I have got everything in here, and I can start optimizing my models by taking the right decisions. I can further go down the line. I can see if there are any partitions. I can see column level details as well, like at every column level, what the size of the column, can I optimize it, percentage of table proportion that column takes, and so on. We can see its data type and so on. Again, yeah, you can have some more information like relationships here. So again, I can see all the relationships that I've got within my semantic model. And if I've got any hierarchies, I'll have it here. Currently on this semantic model, I haven't got any hierarchies. That's why I don't see here. So having that capability of running Vertipack Analyzer is one of the strongest feature for me as a Power BI developer, because I can just understand what's my model is taking, what is taking the maximum space. Can I optimize it? Are there particular ways I can, make my semantic model much better? Further down the line, I can actually run Best Practice Analyzer on my semantic model. Now, if you've heard about Best Practice Analyzer comes with some inbuilt rules, which are actually considered which needs to be applied on your semantic model to work in a more optimized way. You can also run your custom best practice rules as well, but I'm not covering that currently in this notebook, but I'm just trying to run Best Practice Analyzer using the default rules that should be applied on a semantic model so that it runs perfectly fine. Once I run Best Practice Analyzer on my semantic model, I can clearly see I get understanding or sorry, I get details at 3 different levels. One is if I've got any formatting issues, if I've got any maintenance that can be improved, or if there are anything within my semantic model that is, affecting the performance from best practice point of view. So like, for example, within formatting, I can see that it is telling me I should be adding data category for the columns like geography, where I've got city name, continent name, or country name. I have summarized my numerical columns. It kind of telling me it is not the right way to do it. So it's telling me do not summarize your numeric columns. So I can go further down. It gives me all the information, like, for example, mark primary keys within your table, hide your foreign keys, and so on. Now let's go to maintenance. Now within maintenance, it again tells me some information like remove unnecessary columns. Like, for example, I'm not using this. I can remove it. If I go in the performance aspect, I can see some more information that Best Practice Analyzer is telling me. Now, if you remember the semantic model that I showed you earlier, it had a bidirectional relationship. So it is telling me, check if bidirectional relationship is valid. Do you really need it? It's telling me it's not good to have it. And I already told you or showed you in the starting, I don't have a perfect star schema within this semantic model. So after running Best Practice Analyzer, it's kind of telling me you have got a snowflake architecture, consider using a star schema. We all as Power BI developers know. Sorry, Roman, I never had a session on Power BI and Databricks. Not sure what this is about. Sorry, we can chat offline. Sorry, I never gave a session on Power BI and Databricks. It was a long time back where I might have given a session on Azure Databricks, but I haven't used Databricks within Fabric, so I'm not sure whether semantic link is available using Databricks within Microsoft Fabric. So let me know if that helps. Otherwise, we can chat offline. So yeah, again, Best Practice Analyzer is telling me that. It's also telling me do not use floating point data types because it kind of affects performance on your data model. I should have a date table. So again, if you're a Power BI developer, you understand the importance of having a date table within your semantic model. So I haven't got that. So again, Best Practice Analyzer is telling me to go with the best practices and add a date table. So this is what I love about this notebook. I again get everything here. I don't have to go somewhere else to do it. So this was about like how we can actually understand the optimization on the semantic model, and based on the analysis what we see here, we can actually take necessary steps to make our model more performant, more optimized. Now the last demo that's remaining is, okay, I'm good with the timing. The fourth demo, which is more around how can we use semantic link to analyze the report that I've created on top of the semantic model. So one thing on this particular side of demo is like, I have created one report on top of this particular semantic model. Now, if I want to use semantic link to understand the details on the report that I have created, I have to make sure my report is in PBIR format, which is Power BI Enhanced Report format. Now, if you guys have worked with Power BI projects, then please go and look at it. PBIR format was released some time back. It's something new that came out. Apologies, I'm not good with timing when it came out, but it was released some time back. And to understand and use semantic link at a report level, you have to make sure you have the Power BI report format for this particular report. And the other thing is this PBIR format is not, it's still under preview. And PBIR format Power BI reports can't be directly published into service. You have to actually use Git control to get that report on your workspace. So that's another thing. You just can't directly use publish button on the PBIR format report to publish it to your workspace in the service. So what I did was, I'll just take you to my workspace again. I saved this particular report in the PBIR format. And let me open this report. And I used Git control to get this report. So when I open this report, I can clearly see message at the top that this report uses an enhanced Power BI report format, which is the PBIR format. And I did this deliberately so I can use semantic link to understand what's going on my report as well. And if you go, this particular workspace has been connected to a source control. So I'm using Git source control, using which I actually got this PBIR format report within this particular workspace. So that's the only thing. If you read about PBIR, you'll get all the details how you can use Git source control to get your PBIR format report within your Fabric workspace. So let's go to that particular report analysis demo. Once your report is in PBIR format and you have used Git to get that report in your Fabric workspace, then you can actually start using SemPy library to understand what's really happening on your report. Now, again, as a Power BI developer, the foundation level is my semantic model. But on top of the semantic model, when we create reports, it's again a duty as a developer to make sure the reports are most performant. There is no lag on the report. There's not something weird going on the report. I haven't got unnecessary things going on the report, like so many filters, or say I've got like say 40 visuals on a single page within a report. So I need to make sure that the report is fine. It is usable by the end users. So this SemPy library can actually help you analyze that report before you actually, distribute it to your end users. So again, I'm installing the SemPy library here. Then I'm trying to import all the necessary modules that I'll need to analyze this report. Again, I created this particular report on top of my semantic model, which is Contoso sales analysis, which we saw here. And I'm trying to analyze it within Fabric Contoso workspace. And once I do that, and I want to list, say, all the objects used on my report. So once I do that, I actually get the list of all the objects that I have used on this report to create the visuals. So if you see, this is a very simple single pager report. I've just got 4 visuals in there. And it kind of tells me that I'm just using these 10 columns on my report to generate this single page. That's it. So it's telling me from which table my object is coming, from which which column it's coming, whether it is a column or a measure, what kind of visual that it's coming to a visual, and on which page it is coming. So I'm not showing you this report in the edit mode, but if I edit this report has got 2 pages. One is the overview page, which is my report page here. And then there's another page which is hidden, which is a revenue tooltip, which I have just got on one of the visual. So it's kind of showing me on which page I'm using which column. Even on revenue tooltip, it's kind of showing me, okay, what all columns I'm using to create this particular tooltip. So this is kind of really a very good high level information on understanding, okay, what's really happening at a high level on my report. But now say if I want to understand the number of pages on my report, now I have seen reports where they've got like 50 pages, but yeah, we can't help it sometimes. But yeah, still it's good to understand what's really going on at the report level. So in this report, I've just got 2 pages. So it tells me I've got an overview page and a revenue page, a tooltip page. It also tells me what page is hidden or not hidden, whether that page is active or inactive. And then it kind of gives some kind of formatting details around that page as well. So we can see all that, like at every page, how many visuals we have got and all that certain information. So again, it shows me like, okay, what's really happening at my report level. Then further down the line, I can also list the number of visuals within my report. So once I do that, I can see, okay, what all visuals I've got. So I can only see there are 8 visuals on my report, out of which 7 visuals are on my overview page, which I can see here. And yeah, so there are like different things going on here, not just these 4 visuals. I've got a few more things here going on. And then on revenue tooltip, I've got 1 visual. So that's what it is showing me, what all I have got. So I've got area chart, I've got shape map, I've got 2 text boxes on my overview page. Then at revenue tooltip, I've just got a line chart. So it again tells me the distribution at a page level within my report, what really happening. Again, as I said, at a report level as well, it is our duty to make it more optimized and, as fast as we can, because we really don't want to hinder the end user experience, right? We have to make sure it's kind of very good for them when they're opening the report, when they're accessing the report and trying to use filters or understand insights. So yeah, that kind of gives me, okay, what all visuals I'm using. Again, I can also see at a visual level what kind of objects I'm using. So for example, on the overview page, I've got a date column that's been used at a certain visual. So I can get that kind of information as well. So again, it tells me, okay, what's really been used on the report. Then further down the line, I can have some more information. Like, for example, if I want to understand different kind of filters that I've been using, like, for example, report level filters or page level filters or visual level filters. So currently, I haven't got anything on this report. That's why, oh, my bad. I did something wrong, but it's fine. So that's why I don't get anything. I can also see like, okay, what kind of, if I've got any report level measures, I haven't got that. That's why I don't get it. But if on a report that you're working with, you have this information, it will get displayed here. Then further down the line, if you've got any visual interactions on the report, then it will get listed here as well. So again, from a Power BI developer point of view, this is again a very strong thing for me, because I have, again, what I like about Fabric is everything is under single hood. I really don't have to go somewhere else to do an additional thing. So that's why I love these notebooks, and Semantic Link helps me understand that information as well. And another thing about writing these notebooks is you can actually share these notebooks within your team as well. You really don't have to be like, okay, this is a notebook I've created for myself. No, you can actually share it with the data scientists or data engineers as well if they want to understand the semantic model that you have created on top of the data they have given you. So you can just go and share it with your team as well. And then you can actually work on a collaborative way on these notebooks. So again, why Power BI developers learn it? Learn it because you need to know things. You really don't have to, rely on data engineers or data scientists to do this for you. I mean, you do your own level of analysis, and then you can share this with them, and they can help you build more detailed analysis on top of this. So this is, again, why I love using notebooks. So these were the 4 different demos that I wanted to cover. I wanted to cover another demo, but today, but somehow that was broken last night due to some issue within my notebook code, and I didn't get time to sort it. But hopefully in some other event, I would love to share that particular use case as well. But yeah, these were the 4 different demos I really wanted to share today as part of this Semantic Link. And in this This PowerPoint I have shared in the private chat with Charlie. This PowerPoint is available on my GitHub repository. So Charlie, if you can share that link in the comments, that will be really great. So if you want to have access to this PowerPoint, you can have it. It has got all the links to some of the resources. Again, thanks to Michael Korosky for his work on Semantic Link. Now Semantic Link labs are available. So you can just go to his GitHub repository and see what all Semantic Link labs can help you in doing. And there are also some featured scenarios that Michael and his team has already pre-created for us. We can actually use them on our existing scenarios. So just go and reference these links. You'll have all the details around Semantic Link labs and what all use cases, under what all use cases you can make most of these Semantic Link feature. And yeah, that's what I had to share today, everyone. So thank you. If there are any questions, I'm happy to answer them. And in case you want to ask the questions later, not now, that also works. You can connect with me. I've got my own blog. I'm on LinkedIn. I'm on Twitter. I'm on Fabric Community, as I said. So you can just reach out to me, whatever works best for you. So yeah, thank you, everyone. I'm not sure if there are any questions. I'll just stop sharing my screen for now, Charlie. I don't think I need to have it. But yeah, if there are any questions, I'm here for a few more minutes if anyone wants to ask anything. And Roman, let me know if your questions were answered. If not, just reach out to me offline. Happy to answer anything that you have in mind. So
Thanks,
yeah, that's it,
Pragati.
guys.
Thank you very much for all those demos. Very demo-led session. Thank you very much for that. Good on you for coming back so quickly after childbirth.
Oh
That's
yeah, it was. I think it's quite quick because my baby is just 8 weeks old, and but yeah, I think it just worked out, and I
Wow.
always I love speaking, so I think that's what motivated me to come back soon. But
Good
yeah,
on you.
that works. Yeah, that
Good on
worked.
you.
My baby didn't cry in the background, so hopefully everything was fine.
No
But yeah,
worries.
thank you so much for giving me opportunity to speak at Data Bash. I always love speaking at this event, and thank you everyone for attending my session. Definitely reach out to me if you've got any questions.
No
Thank
worries.
you
You're a
so much.
regular over the years with DataBash. So no, it's great to have you on board with us, and we look forward
Pleasure.
to seeing your next sessions as well as they come up. I've posted
Yeah,
your
definitely.
presentation link to the chat there on YouTube. So if
Thank
anyone
you.
has any questions in the remaining couple of minutes that we've got, feel free. Otherwise, I think we'll switch to the agenda pages, and from there, everyone can see what's coming up next on the different rooms. On our side, we have Marisol and Sebastian Steinau starting with us in the next session at 11 o'clock our time. So feel free to grab a coffee, take a nature break, do whatever you need in the next couple of minutes until we go to the next one. So thank you very much,
Thank you.
Pragati, once again, and hope to see you
Thanks,
again
Charlie.
soon at one of the next
Oh yeah,
conferences.
definitely. You see me at other events. So yeah. Thank you so much. Thanks,
Thank
everyone.
you. Ciao.
Bye.
Bye, Pragati. So, hello everybody. So we're about to start the next session here with Marisol and Sebastian Steiner. I'll quickly bring them up on stage. Here we go. Hello, hello.
Hi, everyone.
Okay.
Okay, so hi, everyone. We're really excited to present this session, Fabric, Git, and Pipelines are Chord in Harmony. So as we all know from our social media streams, Fabric is here. And with Fabrics, there are also tools that support DevOps practices, namely deployment pipelines for continuous deployment. Then on the other side, we have Git, a powerful version control system heavily used in DevOps, which has also been integrated in Fabric. So yeah, this is great. So it should feel like everything is aligned for using DevOps practices with Fabric. But if you listen to the music created by deployment pipelines and Git, it still sounds somewhat, I would put it, dissonant, and there are gaps waiting to be filled. So DevOps is about automation. And in that regard, Fabric currently has half the orchestra missing. That's how we would put it, as some players still need to learn notes. But the good news is that we can fill that missing half of the orchestra with Azure DevOps pipelines. Pipelines can also compensate for the dissonant tones, so that in the end, Fabric, Git, and pipelines, they work together to play a harmonious chord, if not an entire symphony. And that means that we get a practicable user workflow that automates the annoying parts away. And we want to show you how to get there. So this is us. My name is Marisol. I have been working with the Microsoft Data Platform for more than 8 years by now. I work as a data solution architect. And in the last 10 months, I have been mainly busy with Microsoft Fabric.
Yeah, hi, I'm Sebastian. I do Azure, I do .NET programming, I do DevOps, and, well, with Fabric, I'm doing my first steps into the data world.
Okay, so this is the agenda for this session. So we will briefly describe what is DevOps, and we will also talk about version control with Git and why you should definitely use it. I know that a bunch of people of you are already working with Git, which is great, but the thing that the reason why we decided to still talk about Git and to explain how it works is because I still see a bunch of people saving code in SharePoints in my daily business, which really gives me a headache. Yeah, we will also show how Git works in Fabric, what the limitations are. We will have a look at CI/CD in Fabric. And then we want to show you the idea that we had and implemented on how to improve Fabric with Azure DevOps pipelines. And finally, we want to share the learnings that we got from all of this. Okay, so DevOps is like a really huge topic. There's this nice DevOps handbook, which is like about 400 pages. But in a nutshell, the whole point of DevOps is delivering value as fast and as often as possible, and in small increments, because even a small increment means more value, and it usually can be delivered faster than like compared to, let's say, a huge Moloch feature. So over time, what the customer gets is a compound value from all the small value increments. And now this process for creating value is often described with this cycle that you see here. So first, we plan what the value should look like. This could be a new report, a bug fix, some new feature. Then we develop that feature, and throughout the process, we collaborate with everybody that needs to be involved. When we're ready, we deliver the value to the customer, and then during operations, we gather feedback. We gather feedback on what's working, what isn't, what's being used, what's missing, and then we drive all this forward, continuously adding value. So now, by running those small cycles, developers create changes. And for those changes, we require version control in order to manage them effectively. These changes are then integrated into the whole solution as often as possible. This is continuous integration. Then we have testing to ensure that nothing breaks, but if something breaks regardless, the harm that is done is just little because the change is small. The next step is continuous deployment, where the validated changes are automatically deployed to the next environment. So for example, from dev to test or from test to prod, ensuring a fast and frequent delivery. And now this fast pace of delivering value only works if a bunch of those steps are automated. Okay, so now let's jump into version control. And here the question is, why would I want to use version control in the first place? Why would you want to use version control in the first place? What do we want to get out of it? So in the first place, I want my source code, my files to be versionable. So if something breaks, I want to be able to go back to a working version. Furthermore, I want to have my code, my files in a central place. So I want to have a single point of truth, because this enables me doing a backup of the code, preventing loss in case of like hardware failure, let's say, or some other issues. Then I want to be able to track changes. So who made a change, why, when, because this makes it easier to track progress and resolve issues faster. And finally, I want to have integrity in the form that if I put something in the version control system, I want to get the same thing out. So version control should protect me from any memory corruption or disk corruption. Now, one argument that I have quite often is, do I need version control if I'm a team of one? And my answer is always yes, because even as a team of one, we commonly have multiple versions of the same file as we work on it over time. I want to show you something, namely this. So does this here look familiar to you? This is like a frequent occurrence of someone writing some type of thesis or solution design without using any version control. And this is a nightmare, because by having a look at it, nobody can tell me which one is like the final version. And this is why a version control system is useful, even if it's only used by myself, because what I get is a central place to store and track my content. So at the end, I only have one single file to work on, which is the current version. And if I make a mistake, I can just go back to a previous version by using the version control system. But now, if multiple people work on the same things, then version control becomes rather a necessity. Okay, so now that we all know that version control is really a no-brainer, let's talk about Git. So we believe that mastering Git is a core capability that everybody needs, no matter what you do in IT. The ability to version control the work that you do is just critical. And now in enterprise environments, people are working simultaneously on different things, like developer 1 is working on a bug fix, developer 2 is working on some new feature, developer 3 working on some new major version. And at the end, what we want to have is to bring everything back together to see the changes that other people have done, but in a very controlled and consistent way. So we need the possibility to roll back things in case that something breaks, and we can do all of this with Git. So Git is a free, open source, distributed version control system that enables collaboration, and every change is logged in a consistent way. So with Git, we can version control our files, our code. We have a single source of truth, which is immutable, so we cannot manipulate it. So in Git, I can just go and, let's say, try to put some bad code in a file or try to cover up something that I broke, because Git will notice. So if I want to change something, I can do that. And people always talk about rewriting history. This is possible, but then I have to use the dedicated tooling that Git brings along in order to ensure consistency. So I am sure that all of you, if you have heard of it, of Azure DevOps repositories, GitHub, Bitbucket, GitLab, hopefully you're already using them. But just to get everyone on the same page, what all of them have in common is that they provide a remote repository to which I can go and sync my work to, and which acts as a single source of truth for me and my co-developers. All of them are based on Git. Now, they might offer some additional features or capabilities, which are really nice, but not always free. But fundamentally, their toolset is just Git. So the key point here is that we just have this remote repository out there, for example, in Azure DevOps, and then I can clone that remote repository, develop locally, and then synchronize my changes through a pull and push mechanism. And this we will see next, how it works. Okay, so now we will have a look at the structure of Git and the basic workflow. Git utilizes folders and files in the local file system. And conceptually, Git is divided into 5 areas, but we will only have a look at 4 areas because time is limited, and it's totally enough to understand how Git works. So those 4 areas are the working area, the staging area, also referred to as index, the local repository, and the remote repository. So we work and develop here in the working area. So this is what we essentially see as the file system. Here is when I can go and start developing my code, for example. And now I might be working on different things at the same time, some of which are unfinished. And now I do not want to go and put all of those things here in my local repository. So what I want to be able to do is to only stage specific files. And for doing so, between this working area and the local repository, we have the staging area. So here is where I can go and just book specific files and basically tell Git, hey, this is the file that I want to include in the next commit. So for example, here only file 1. And this command that you see here, git add followed by the name of the file, is the command that you would use in the command line. There are other ways of working with Git, like using Visual Studio Code or other types of clients, but the command line is just like the most basic thing. And honestly, from my experience, if you master the command line, you can master any tool. All right, so as already said, in this staging area is where I go and put the files that I want to commit next. So now I have added this file 1 to the staging area. And once I am confident that my file is ready to be committed, I can go ahead and do the commit. And in that commit, I can describe what the commit is about. So I provide a commit message. So in this case, a commit message is added new file. Okay, so on this process just moves the file to the local repository. And afterward, I can go back to this working area and continue doing changes, continue doing work. And at some point, I just repeat the whole cycle, adding the files to the staging area and then committing them to the local repository. Okay, so far so good. I have committed this file 1 to my local repository, but remember that we have that remote repository out there, for example, sitting in Azure DevOps or GitHub. And this remote repository doesn't know anything about the changes that I have made locally. So what I have to do now is to push those changes from my local repository to the remote repository. So then this file is now also present there. So basically now the content of my local repository and the remote repository match. Okay, but this is only me. What about other developers? So this is now my colleague. And if we have a look at his repository, he doesn't have that file there yet. So in order for him to be up to date with the current version in the remote repository, he needs to pull the latest commits into his local repository. So this way he can just keep in sync when working on some new feature and also detect conflicts early. Okay, so this is now how his repository looks like. So now he also has this file there in place. And that's basically how it works. So you have to do the push and pull yourself because there is no ongoing background synchronization. And now I just mentioned conflicts. So what about conflicts? The thing is that in this setup, Git is a distributed version control system. So it could be eventually the case that 2 developers are simultaneously working on the same file on their local copy, and then they synchronize and realize that there is a conflict. But Git is able to resolve those conflicts in a consistent way. And developers just have to know how to deal with conflicts, and conflicts are not a bad thing. I always get irritated when I read or hear you should always avoid conflicts at any means because it's not really a big deal. You just know how to solve them. Okay, so now let's have a look at this from a different perspective. So now this is the commit that I have in my remote repository. And as I continue doing work in my local repository and I push the changes, I create further commits. So now I have 2 commits, and in Git, each commit references its predecessor. And through those references, what we get at the end is a chain of commit that emerges, and this is the so-called history. Now in Git, every commit has a unique ID, which is immutable, so we cannot change it. And each commit is a full snapshot of the repository. So Git does not only record the changes, but we get the changes by comparing one commit to another. Now, regarding those changes should be kept small because this makes it easier to understand what has changed. And as a rule of thumb, commit early and commit often. Remember, we want to have small increments of value. And even if you're not done with your work, you should still commit it because this keeps your work safe. And again, I just want to underline to remind you to make small commits, because when you make like huge commits and you have a tiny mistake, and doing that huge commit for that tiny mistake is like really painful. I've been there. Okay, so now if we have a look at this structure, it appears linear, but in real work scenarios, nothing is that straightforward, unfortunately. So people are working on different things at the same time. And this doesn't really, I would say, fit well in a purely linear structure, because changes would be scattered all over the place, leading to chaos. Okay, so that's why now imagine that I want to create commit number 6, but instead of appending this commit number 6 directly after commit number 5, what I could do instead is appended after commit number 4, creating here an alternative path. And those alternative path is what we call branches. And branches are a really useful thing because they allow us to work on something independently of whatever else is going on. So we can work isolated on some feature, for example. Okay, so in Git, we can have as many branches as we like. We can create a branch from any commit, even a commit that is already in another branch. But at some point, the whole idea is to bring everything back together. So to reintegrate those so-called feature branches back into what is called here the main branch. And this is one aspect of integration in continuous integration. So now let's have a look at how this process of integration looks like. So I am going to reset the commits. So here I only have 2 commits in the main branch. There are no other branches inside. And now I get the task to develop a new feature. So the first thing that I do is I create a feature branch. I'm just going to name it feature 1. And then I start doing my job. So I create my commits, and as I do further work, I create further commits. At some point, I am ready with my feature. This was only a small feature. And now what I want to do is to integrate my feature branch back into the main solution, so back into the main branch. So what I basically want to do is to merge the content of my feature branch with the content of the main branch. But there is a tiny little detail, which is that main branches are, I would say, precious things. So I can't just go and throw my changes at it. So the idea here is that instead, I ask I would say, the lords of the main branch to have a look at my changes, at my code, to review my code, and to consider my changes for integration. And this is the so-called pull request, where I ask for my changes to be pulled onto the main branch. Okay, and so now when you create a pull request, the changes get reviewed, and it might be necessary to put some additional work into it to make it right. For example, better formatting, or if there was a bug that was discovered during the review, that sort of thing. So these additional changes might lead to further commits that I have to do in my feature branch. So for example, commit number 5. And during the review process, it is also checked whether the changes are compatible with the main branch. And if they are not, I have to go and resolve the merge conflict before the pull request can be approved. Okay, so then at some point, when the approval is granted, the merge into main takes place. And this is also part of the whole process, of the whole workflow. So you create a feature branch, you develop your feature, and then you merge back into the main branch. So we can have multiple feature branches at the same time, but the idea of feature branches is that they are short-lived. So they should get deleted after the merge into main takes place. So the only persistent branch is the main branch. And this is at least one way of working with branches, referred to as trunk-based development. Trunk, because the main branch is the only persistent one. There are other ways of working with branches, such as Git Flow, but this would just go too far for this talk. Okay, so now that we have an understanding of how Git works in general, and that all of you now, hopefully, at least by now, should know that you never develop on the main branch, let's have a look at Git in action in Fabric. So for this, I will jump into my Fabric workspace. And in this workspace, So in this workspace, I have, I have a bunch of workspaces. So let's have a look at this workspace NYC Taxi Dev Storage. So this is just playing around with this NYC Taxi data.
I don't see anything.
Oh, sorry. Okay. I am presenting.
Did you share presentation, not screen?
Yes. Okay. Okay, now, sorry. Okay, so now hopefully all of you can see my screen. Here I have this workspace called NYC Taxi Dev Storage, which has all this NYC Taxi data that probably all of you know. And in this workspace, we have a lakehouse and a warehouse. And this workspace is connected with a Git branch. So if I go to workspace settings, this is how it works. You can connect a workspace to a Git branch. So under Git integration, I have already connected this. I can see that it's connected with the main branch. And since we have a branch protection set up, so this means I cannot do any changes and commit into main because it's protected. So what I have to do is to create a feature branch. Okay, so now let's have a look at my NYC Taxi warehouse. And there I have this table called passenger. And now I just want to add a second table to it. So first of all, I have to create a feature branch. And for doing so, I jump back to the workspace from which I want to create a feature branch. And if I go under source control, and under this icon here for branches, there is this nice option called branch out to new workspace. And then I have to provide a name for my branch. So I'm just going to call it feature product. This is based on main. So I'm branching off from main, and I have to provide a name for the workspace. And I just use the same name for the branch as well as for the workspace. And then I click on branch out. And what happens now in the background is that a new workspace is created and already connected to a feature branch. So I call it like a feature workspace because now I can develop a new feature branching off from main. So this means that all the content that was in my main branch is copied into the feature branch. And now I have the possibility to develop something without affecting the main branch. And this thing takes a bit, depending on how many items are copied. In this case, it's only a lake house and a warehouse, so it should be quite fast. And it was quite fast. Git is telling me your content was synced. Okay, and now I am going to jump into my warehouse. And this is just a really very, very basic example. I have the code here prepared because I hate typing in front of people. So I'm just going to create a new table called product in my feature workspace. I'm going to run the code, and then my table should be present here. And there it is. There is my table product. And now what I want to do is to create a pull request to merge my feature branch back into the main branch. Okay, so for doing so, I just go back to my feature workspace. And if I now go to source control, first of all, Git, it's telling me, hey, there is a change that has been detected. So this change concerns this item, NYC Taxi Warehouse. I can see that the status is telling me this item has been modified, which is true because I just added a new table. It would be nice, though, to see what the change is exactly about. I mean, I know it because I just created the change. And now I can commit my change. So I just select this item. And I have to provide a commit message. Just going to type this here, added product table, and then I do the commit. So it's committing my changes. And what's really nice concerning this Git integration in Fabric is also that the push to the remote repository in like DevOps, in my case, it's already done for me. So now it's syncing, it's telling me it's sync, and I don't have any changes yet. So they anymore. They have been already committed and pushed to the remote repository. And now I want to merge the content of my feature branch with the main branch. So I can go and select this here, which leads me to the remote repository. It's telling me that I have updated my feature branch, and now I want to create a pull request. And since we have a branch protection here set up, I have to put a reviewer, which is not me. So in this case, Sebastian, and I'm going to create a pull request.
Okay,
So-
now it's my time to shine. Okay, I'm function as a reviewer. You can't see it on screen, but what I basically do is I go to the pull request, I review it, I look at the files that have changed. And since I just watched what she was doing, I know that it's a good change, so I can just approve it.
Okay,
And
so
now Marisol is capable of completing the pull request.
thank you. So now my pull request has been approved. Normally this takes like a few emails and a few days. So this was quite fast. So I can just go and complete the pull request. And when I complete the pull request, this option of deleting the feature branch after merging is already selected, which is nice because, as I said, the idea of feature branches is that they are short-lived. So they should get deleted after the merge into main takes place. So I am going to complete the merge. And fine, there were no merge conflicts. So now the merge into main has taken place. And now I want to see those changes back into Fabric. So if I jump now back into Fabric, here I am still in my feature workspace. And if I do here a small update, it's telling me, hey, this Git branch was deleted, which is true because I just deleted the feature branch. But the kind of thing now is that I still have this feature workspace. And this is annoying because remember, we want to have small value increments when working with DevOps techniques. And so the more you create things, you have to remember to delete all those feature workspace, because if not, it gets really messy at the end. And I think the Fabric tenant is going to be not going to be happy about it. So we want to avoid getting in trouble. So therefore, I am going to delete this workspace, which is not needed anymore. I have to do this manually. And as I said, the more features you create, the more annoying this manual deletion gets. So my workspace has now been deleted. And now I want to see the changes in the dev storage workspace since I merged my feature branch with the main branch. Okay, let me just close this. Okay, so there it is. And now if I go, okay, it's loading again. We're just gonna load the page. Yeah, this is the thing about live demos. Okay, so let me just go again to my dev storage, workspace, and now to source control. And now it should tell me that there are some changes coming from the remote repository. And there it is. It's telling me, hey, there are some updates that have been done in the remote repository. In order to see them here in the workspace, you have to do an update. So I am going to do an update all. So now it's updating my workspace. And depending on like the number of changes, this could take a bit longer, but it's almost done. Okay, so my content has been synced now. I'm going to close this. And now if I jump to my warehouse, I should be able to see that second table that wasn't there at the beginning. And here is the product table. And that's basically how it works. And I just want to point out two things. I think it's really great. First of all, that Git has been integrated into Fabric and it's GA, I think, since 3 weeks by now. But what I am still missing is that not all Fabric items are supported yet. And the other thing is merge conflicts. In order solving merge conflicts in the Fabric UI, it's just partially possible. And I hope that this changes in the future. And if you really want to solve a merge conflict, you have to know how Git works. And this is why for us, it was important to do a recap or to show you how Git works, because you are going to need it. And the final thing is this option of branching out to a new workspace is really great, but you have to make sure that you have the permissions, and you need the permission to create new workspaces in Fabric. Otherwise, it won't work. Okay, so now let's go to CI/CD.
Okay. Yeah. now that we have a good understanding of Git, let's have a look at CI/CD in Microsoft Fabric. The good part is that continuous integration can be handled really, really quickly because it does not have to be compiled, unlike software. So that compilation step just falls away. And the other part, automated testing, that means your unit test, your integration test, your smoke test, your end-to-end test, and whatever else sort of test you can think of, that's currently just starting to ramp off. So there are frameworks for testing that you can use, but I would think that there's nothing yet that you absolutely have to use. But that's for the moment. That may change. And right now, that means when you complete your pull request and your changes land on the main branch, you're basically done with continuous integration, at least for the moment. And continuous deployment, however, is totally another story. For getting things from your dev environment all the way into production, Fabric has deployment pipelines. And deployment pipelines in Microsoft Fabric have the purpose of moving Fabric items like your notebooks, your data pipelines, your warehouses, your lakehouses, and everything else across the different environments. And in this case, the environments are development, test, and production. And these stages obviously serve different goals. So in development, you develop your features and your new functionality, and eventually this functionality is ready and then moves on to the test stage, where it is hopefully thoroughly validated. And once it passes that validation, it then can be deployed onto production, where it hopefully will make your customers happy. And by isolating the work in each stage, you minimize the risk of disruptions and interference between like development and testing, and ensure that only well-tested items reach production. So, well, this presentation could have ended on the last slide, yet here we are looking at what currently doesn't work that well. And the first point is that deployment pipelines deploy from one workspace to another. There is no consideration of Git whatsoever. So that means you have to manually ensure that the workspaces and Git are synchronized. That means before the deployment pipelines run and also after the deployment pipeline has run, which are two manual actions you need to do every time. And you also have to trigger the deployment pipeline manually, which is a third one. And I myself am a very lazy person, so I just would have liked it very much for these things to be automated. And that's not enough, because we have a fourth thing to do. Because after the deployment pipelines run, the items that were just in dev are now in test. And they have just been copied over. So that means your notebook in test or your data pipeline in test still references the lakehouse or the warehouse in dev. And these references need to be adapted, because you want your data pipeline to work entirely within test and reference the test lakehouse. So that's a fourth step we need to do. But to be fair, Microsoft has recognized this as a problem as well, and they offer deployment rules together with deployment pipelines that promise to solve that. The problem here is that deployment rules currently don't support very much. Notebooks, yes. Data pipelines, no. And during my testing, I also found them to not be very reliable. But let's say if we are able to automate the first things, maybe we can also achieve something more than what deployment rules currently can do for adapting these references. Okay. That being said, currently a full automation isn't yet feasible since Fabric currently only supports like half the items in either Git or deployment pipelines. That's also current snapshot. This is bound to get better. For example, Event House support has just been announced for deployment pipelines a couple of weeks ago. So this is a matter of time until this is like really fully supported. But for now, that's what we have to work with. Okay, but if we were to fix all the previously mentioned points, so how would that look like? So first, we want version control for all workspaces. That's just a no-brainer, because if tomorrow my Fabric instance just goes up in flames, I want to be able to reach down into the ashes, pull out my Git repository, unharmed, unscathed, and restore everything from there. That's a really nice capability to have. Next, we want to adapt more references than deployment rules currently can. Ideally everything, but let's not get presumptuous. And since we want to do automation, we need a trigger, and for us the logical choice is a pull request because we already have everything in Git. And last but not least, workspaces or Fabric workspaces should be synced to Git automatically before and after a deployment pipeline runs. And that also means that when a pull request deletes a branch, the corresponding Fabric feature workspace should be removed as well. Otherwise, this would be a fifth thing I would have to do manually in addition to the other four. Okay, if we put all this together, this is what we get. On the top, we have three different environments: dev, test, and prod. And each is being backed by a Git repository. Sorry, that was too soon. And we have three different areas: storage, compute, and reports. And put together with the other environments, we have 9 different Fabric workspaces. And the workspaces for one environment are consistent because they share the same Git repository. They just map to different folders in that repository, and each of them has a main branch and eventually just feature branches. Mostly test and prod just have a main branch. And finally, for each area, we have a deployment pipeline that shovels items from like dev compute to test compute to prod compute, and analogously for storage and reports as well. And this basically takes care of the thing that everything is backed by Git. Every workspace we have has a backend Git repository. Okay, so how do we implement our other desired features? Automatic workspace deletion after a branch deletion, and automatic triggering of deployment pipelines with a full Git sync. Luckily for us, DevOps and Fabric already have the necessary ingredients to do that. Azure DevOps has pipelines to automate things, and and Fabric has the Fabric REST API for things to be automated. So given the architecture from the previous slide, and this here is just another view of that, focusing more on the process, we start off by developing our features on a feature branch. We do one commit after the other, and eventually we're done and we do a pull request. And that is where the magic happens, because Azure DevOps pipelines can trigger based on pull requests. So when the pull request completes, 2 pipelines start running. The one on the left here uses the Fabric REST API to remove the feature workspace that is left over. So one branch has just been deleted during the pull request. So the pipeline just has to search for the workspace that is still connected to that branch and then just delete that. So not nice. That's done. Fully automated. One more manual or one less manual thing to do. Okay, the other pipeline does the automatic triggering of the deployment pipeline and the Git sync. So after the pull request, our changes are here in the dev repository. So we first need to do an update to have everything within the dev workspace, so that afterwards the deployment pipeline can be triggered, and then it shovels everything from dev compute over to test compute. In this example, works exactly for storage and reports the same. Okay, then everything is here. We commit that to the test repository. So that's 3 things less I have to do manually. And we still got one left to do. That is adapting the references, and this is ideally done in the Git repository, because there every Fabric item is represented as text, and the references is just a tiny piece of that text that points to somewhere else. So, for example, the dev lakehouse. And in order to get the test lakehouse in there, we just replaced that text that represents the dev lakehouse with a text that represents the test lakehouse. And we do that for all Fabric items and all the references we can find. Then we save all that, do another commit, and then these changes need to be synced back up again to the test compute. And then we're done. We have adapted references, everything is automated, everything is fine. Okay, this was just from dev to test, but from test to prod, this is exactly the same. All right, now you've seen that in theory, and you might just not believe us that this is working. So let me show you with a demo. Let me just switch over to the browser where you see my Fabric workspace. We are here in NYC Taxi Dev Compute. We will change a notebook because these data pipelines here and the notebooks have the references we want to adapt. I couldn't show you that with a warehouse. So it's currently synced with Git, and we want to do a change here. We cannot do that in the workspace because that branch is protected. We need to branch out first. Let me just copy over the name here. So we want, basically the notebook should save something to a table. So we just call that feature save to table. What the change does is really not that important. Okay, so we create a new branch out workspace. It creates a feature workspace. It creates a new feature branch, and then syncs everything from Git back up to the workspace. That also means for something like warehouses and lake houses, the data is not copied, because otherwise this would take way too long. Okay, so everything is synced here. We go into our notebook. This notebook does some schema conversions of the data. That is not really important. So let me just copy off the real change, because I'm not capable of writing that down in that. No, I don't want that. So let's just copy that. Okay, we append it in a Delta format to a table yellow taxi. So that's just our change. Okay, let's kill that. We should have a change. We commit that. Let's do the check mark. And well, for once in my life, I can do a proper commit message because I already have that copied over. Okay, then commit that. Now it syncs that back into the Git branch of the workspace. And now I need to do a pull request. The easiest way to get to Azure DevOps is to click on that current branch link here, which takes me to Azure DevOps and also to the right place in the repository, which is NYC Taxi Development, our development repository, dev in our little schema architecture there. And it tells me you updated feature save to table now. And I'm also capable of creating a pull request there. So pull request now saves to table, create that. And let's hit approve. And well, damn, I can't because of the branch protection. At least one reviewer besides the author must approve. So Marisol, would you please?
Yes. So I'm approving the pull request. There it is.
Usually pull requests don't go that fast, so I usually have time to drink something. Okay, now let's complete it. We keep the check mark that deletes the branch, and we just complete our pull request. And now something should happen because we have two pipelines. We have the delete branch out workspaces pipeline that deletes the leftover workspace. And we have the other pipeline that does the git sync and the Azure, the Fabric deployment pipeline triggering. So just to get this straight, we have Azure DevOps pipelines, which are these things here, and they trigger Microsoft Fabric DevOps pipelines. These are two things. Okay. The runners should pick them up hopefully really, really soon. They are on a 30-second timer, so depending on when we do the pull request, this could take some time. This is also why it's a live demo, because everything does not go smoothly. Okay, now this has been picked up. It starts running. Let's just click in there to see what it does. And it starts logging in. It gets the pipeline. It syncs the source workspace. It triggers the Fabric deployment pipeline. It syncs to the target workspace. Then it translates ID, means adapting references. And then it syncs that up to the other workspace. And this takes some time. So in the meantime, what we can do is we can go to let's say a data pipeline, this NYC Taxi per month data pipeline. We can go and see how references are adapted. So this here is like the text file that represents this data pipeline. And in there, we have somewhere a reference like here. This one's, it's of type Lakehouse, and it has two IDs, the ID of the Lakehouse and the ID of the workspace that it's in. So what we can basically do, this is the idea of the dev Lakehouse and the dev workspace. Just trust me on that. And we just can replace that ID with the IDs from the test Lakehouse and the test workspace. And then we save that and commit it back. And this is also what the Azure DevOps pipeline does. And we can verify that later. So let's see what our pipelines are doing. That should be about finished now. Okay, nice. So everything went smoothly. It just has to do the last sync after adapting the references so that the workspace is up to date. That takes usually about 20 to 24 seconds. So we just have to wait a little bit longer. Okay, 25, but fair enough. So that pipeline ran absolutely smoothly. Now we have to go to the other pipeline and wait until that one's picked up. So that's deleting the workspace that is left over. And well, the effect should be that when I go back to that feature workspace in Fabric, I should get some sort of error message telling me that it's no longer there, because it isn't. So let's just wait until that is picked up. This is not a video, so I can't cut that part out. Sorry. Yeah, so this takes longer than usual. Little streak of bad luck with the timing. Okay, but now it's starting. It should go really, really quickly. So it gets all the branches from Git. It gets all the workspaces with their connected branches, and it just looks which branch isn't there anymore, deletes that workspace, and finishes that up. So both pipelines ran successfully. Let's go back to Fabric. We are still connected to that workspace. So if I refresh the page, I should probably get some error message. Yeah, sorry, you don't have access to that group. Okay, yeah, that's deleted. Okay, nice. So I don't have to do that anymore. Let's go to the test compute workspace. I don't have to do git sync. Okay, this is because of formatting of Fabric. Fabric does, after the git sync, some formatting. It's obviously having something to change, but that doesn't matter. These changes are irrelevant. So let's look in our notebook whether that change is there, and indeed it is. We have that safe table line here, and let's look at our data pipeline. It was NYC taxi per month, and this one has a copy activity somewhere that shovels data from like a web source to the lakehouse that is somewhere in here. So the source is like a web URL and the destination is a lakehouse. And as you can see, this is the NYC Taxi Lakehouse in the NYC Taxi test storage, no longer the dev storage, which is exactly what we wanted. We have the git sync, we have the deployment pipelines triggering, and we have adapting the references. Okay, so that works. Let's go back to the slides. Okay, so that was CI/CD in action. What would still improve what we just showed you? That really awesome would be support for everything, because right now for all the items in green here, you basically have to work in prod, which is not a good idea. And the real worrisome caveat is, the most concerning point is that the Fabric REST API only partially works with service principal. Service principals are used for automation, and we currently have, for a lot of endpoints, we have to use user account, which are problematic because they need interactive login. With automation, you can't use interactive login. And for the activating interactive login, you need to compromise the security of your entire Azure tenant. So please do not try this at home. The solution we showed you works and is probably really awesome, but can't be used until that is fixed. Service principals need to be supported for all endpoints. Otherwise, that solution is absolutely worthless. But Microsoft is working on that, so let's hope that this comes yesterday. Okay, let's get to best practices. Marisol, please.
Yeah, so we just want to sum up the best practices. So always develop on feature branches, never on main. And if you have good DevOps engineers, then they will protect that main branch. Use branch protection for the main branch, as already mentioned. Do small commits, because as I already said, if you make a huge commit, it's really painful to undo that commit for just like a tiny mistake. Learn UseIt Git properly. That really helps. And finally, use service principals for automation.
Okay, then thank you for your attention. Any questions? Thank you for attending this session and your attention. And thank you, DataBash, for having us.
Yeah, thanks.
let's look through the comments and see whether we have any questions. So, is there a way to auto-delete created workspace from branching out when you delete a branch during completion? We showed that. That should be definitely clear. When you made a new feature workspace, it copied the whole lakehouse and warehouse. What happens if my lakehouse is very big? So it doesn't copy data. It copies only code. Depending on how you look at it, this can be a good thing and this can be a bad thing. How to deal with like not copying over the data or having to go to another lakehouse to get the data. This is like a very different topic. So yeah.
I just want to add one thing regarding lakehouses. When you copy the lakehouse, only the lakehouse is copied, but not the tables and the schema. That's still missing.
Okay. Then Jap again. Wouldn't be wiser to have workspace integrated with develop branch, which has the same code as the main branch? Doing develop, publish, main branches, that's akin to Git flow. That's basically a choice you can make. There's nothing that prevents you from doing that. That's just basically comes down to the way you work and the preference of you or your company. Our architecture we showed works with trunk-based development because we just feel that's easier for us. That's our personal preference. Each of these approaches has different drawbacks, different advantages. So as everything in IT, it just depends.
There is also another question. So on Git, you have main, develop, branch, which are always aligned, but we don't touch main branch with Git integration. Yeah, because the idea of the main branch is that you keep this main branch clean. So that's why you develop in a feature branch and first test that everything works and then create the pull request to merge the feature branch in the main branch. And then someone has to have a look at it to make sure that the code is good, that there are no bugs. And like I said, the main branch should always be kept clean and working. So I hope this answers the questions. Are there any more questions?
We can maybe elaborate on the last point of Ricky B. Does it duplicate the whole thing and add cost? You can set it up, or you can probably set it up in a way that it doesn't. Because in like OneLake, you have this one data store and you just reference the data in there. You have something like shortcuts. So I'm pretty sure you can avoid the duplication of the data with OneLake. But I'm new to the data world, so I might be wrong on that.
Yeah, but the idea would be to use, to use the data amount for the different workspaces should be different. So like your test should never has as much data as the prod environment where you mainly have like the whole data, just only a subset, and dev is also a subset of that. That's how you avoid having like huge cost for storage.
Okay, yeah. Also, thanks for the feedback, Diana and Yep.
Yeah, and if you have any questions afterwards, you can just get in touch with us. We want also to share the code at some point. We just have to have the time to load it to our GitHub accounts, but we will. If we forget, just please remind us via LinkedIn.
Thank you very much, guys. That was a great session. A lot of demos, a lot of points there. A lot of us aren't good with Git. Data guys generally aren't good with Git, so thank you very much. Really, really informative. We are now actually going to be going to a lunch break. So thank you very much, Sebastian and Marisol. Very, very well done. And we're looking forward to the next sessions. Let's flip over now to the agenda again, just so that we can have it clear for all the people coming up for the next set of sessions. What we have coming up after lunch is data democratization and in practice, and that'll be done by Sophia. And after that, we have a couple more sessions before the end of the day. Looking forward to seeing you all there. Right now, we're going to cut out to our lunch timer, let's call it, and hopefully if it works, which it does, great. We'll see you all very soon. Thank you very much.
Thank you.
Cheers for
Bye.
now.
Nice lunch.
Thank you.
But we have to worry about also that
confirming.
So, welcome. We have a few minutes to go until we start the second part of the day today. So, we've had a 90-minute lunch break. My name is Charlie Hinania. I'm a Data Platform MVP and one of the organizers of the wonderful Data Bash conference. This is our third year running, and we love this conference. Now, next up, we have Sofia Ilieva, who will be speaking to us about data democratization in practice. And looking forward to hearing that session. We have basically a minute to go. I'll pop Sophia's presentation on screen, see if it works. Great. And hopefully,
Great,
Sophia, you'll
Charlie.
be able to get things working. I think we've tested the audio and all is good. So I'll hand it over to you. Cheers.
Thank you. Thanks a lot. All right, shall we wait for 1 extra minute just to be exactly on time? All right, 13:30, I think I can start. Welcome, everybody. I hope you had or are having a great lunch. My name is Sophia. I work as a data engineer at IMEC R&D organization. Today's session is about data democratization. So the talk is 15 minutes. We're going to discuss about data democratization, what we mean by it, and look at 3 personas. Their problems are addressed by these 3 strategies to democratize data access. Data catalogs, notebooks with exploratory data analysis, and custom solutions. You will see the progress bar on the bottom of the slide, so let's dive into this. Next slide. First, let's think for a minute what we're talking about here. Data democratization is the process of enabling everybody, no matter their technical background, to work with data comfortably. What is not is universal access to all of your data. It is, though, about broader access to data to enable a wider range of people. For our specific company, the goal is making the researchers more efficient in going from raw data to insights. So let's approach this from both perspectives, from the technical perspective and the cultural perspective. Our recipe for success, technical and cultural. What we've got here, we've got data infra, data governance, and data education. Data infrastructure is about storage, compute resources, infrastructure to facilitate your ETL pipelines, etc. We also got there self-service tools. Those could be data catalogs, documentation on the platform, custom platforms, etc. By data governance, I mean, we should address data ownership. Data ownership, data policies, policies on security, on management. Data catalog can also be a tool that can help you with data governance. And there we've got data literacy programs. Those are to give your colleagues different types of knowledge. Declarative, something exists. Procedural, how to do something. This will make your colleagues more aware of the type of data in your organization and how to work with this. All right, so we've got both approaches covered, technical, cultural. Let's see who we can help. There we've got our personas. To encourage this data-driven mindset, we know these people need help. We've got Jack. Jack doesn't know the data he needs. Lean has the data, she knows the data she needs, but she doesn't have the right tools to make use of the data she has. And we've got Vadim. Vadim has the data, but he doesn't trust the data. All of these people, all of these employees, they should feel comfortable asking these questions in your company. Each of these personas, of course, also could have a problem of getting access to the data. For this, you could have a look at purpose-based control policy, but unfortunately, we don't have the time to review this today in depth. Just know that purpose-based control policy could be something very useful if your company has people whose roles are very versatile. It's not one specific role. One person is doing a lot of different things at a time. All right, let's have a look. How can we help Jack and how can we help Vadim? Jack comes to us. Jack says, hey, I don't know the data I need. We would like to have some tool to help Jack understand the data he needs, browse different data sets on the topic that he's interested in and decide, is this something for his project or not? Next, we also got next to him Vadim. Vadim can't trust the data. So he has the data, but maybe he's not sure about the origin of the data. He's not sure about the quality of the data accuracy or consistency. These two problems can be addressed with data catalogs. In our company, data catalog is still in the process of implementation, but let me show you what we've got. I don't think I can have the pointer on this one, so let me just navigate you. So you can see that on the left, we have different filters for different data sets. You see name is a data set or asset type, could be a data set, could be a report. And we have different documentation on that. A data catalog shows you the descriptions, documentation of everything. So this helps Jack understand where to look for his data. But that's not it. It can also show you the complete journey of a data set. So we have data lineage. This shows how data was manipulated. You can also track metadata. For example, who updated the data, when it was refreshed, etc. This can help our Vadim persona with confidence in the data relevancy, in the data quality, who touched the data, etc. Let me show you here. In this example, we can visualize the relationship. There is not much of a relationship, but we have two assets here. We can also see on the top left that this data set has been validated and it has one of the relevant documents attached in the relations. So a data catalog, it can allow you to see the whole history and the people involved. I blurred out the names on the right here. You see context, assets owner, subject matter expert, etc. It shows you who the owner is, who created it, who updated which field, can show you full data lineage. So this promotes transparency and increases our trust in the data. We've covered data catalogs. Now we have Lean. Lean is another colleague of ours, and she says she doesn't have the right tools, to explore the data she already has. What we could offer to her is pre-made notebooks where she just needs to click run and see some data output. Now, notebooks audience is more of exploration. It's more people who need to explore the data temporarily just to have a general idea of how the data set looks. So this could be backup engineers. For example, I was once backing up a coworker of mine, and I had no clue what I needed to debug. And he had some notebooks made for me, for himself and for me. So I just run the cell. I already have an idea of how the data looks like. I understand what the data set is about. I have already potential clues of what I need to debug. Another audience could be also analysts who would like to get a closer look. They do functional analysis. They don't want to explore the data in depth. They don't want to do a cleaning. They just want to have a look. Okay, here we've got this columns, this frame, etc. So the notebook offers you pre-made cells with connections already set up and some basic exploration already built in. For a more technical profile, we have also online project IDEs available that you can click and spin up an online IDE with your project's image, so your Docker image already in it. But today, let's focus on the notebooks. And here we go into my other window. So somebody already built a great notebook. I'll just quickly run through it. I will not show you exactly how to make an exploratory data analysis notebook. I will show you the general overview. And there we switch to my other screen. Thank you, the moderator. All right. This great website, great free information. Let's quickly run through this. So they have a data set of some health data. The general overview is they're going to load the data. They're going to clean the data if needed. They're going to visualize the data frame and maybe do some basic reporting on this. So the whole idea of this is exactly for a person who had no clue what the data set is about to understand the data. All right, so here they visualize the head of the data. Exactly, now you didn't know 2 minutes ago what this is about. You can see already this has some pregnancy count, glucose, blood pressure. So you understand this is about health data. Next, he runs some outputs, prepares the data. For example, he's going to drop the nulls. He's going to round some things up. This is only if needed, right? This step doesn't have to be in your notebook, of course. And then he decides to visualize. So that's the general idea. You load the data, maybe do some basic cleaning, and you visualize for somebody to understand. Here, what do we see here? We see a diabetes plot. Yes, no, how many? We see a count. Most people didn't have diabetes here, right? Half of the people those who didn't have diabetes had diabetes. Okay, that's easy for you to understand. That's easy for your analyst to understand as well. You can also go into more complicated plots, depending on your audience, of course. If you're a researcher doing computational physics, maybe you need to describe something and you want to visualize something, and this is your first step before you make an actual proper report. All right, so let's go back to the presentation. This is just basic analysis here. This is useful if you work with different types of data. I worked with HR data. This was useful. Okay, what kind of people do we have? What kind of profiles? Is it employees? Is it payroll? Are they flex force, etc., etc.? I also worked with research data. So if you work, let's say, with some chips or wafers, all right, how many defects we've got here? What kind of data we are looking at? So that's about notebooks. Let's go. Next, we have custom solutions. Unfortunately, sometimes you need to build fully custom solutions, full platforms from scratch because the existing solutions maybe don't answer your questions. So at IMEC, we have a lot of researchers and we have a lot of tools that produce data. For example, it could be electron microscopes. Now we're building a platform for accessing and interacting with data generated by these tools and tool operators. So the goal of the platform is to facilitate secure sharing of this tool data between the tool operators and other teams. So everybody else, there are researchers in their own bubble and there is everybody else. So we would like to give broader audience, for example, a product team, more control to interact with the data produced by these tool operators. So we're building a centralized platform where people can see both raw and already processed reports on various tools. This addresses both Vadim's and Lynn's concern, because they can see both raw data, they can see the reports built on this. So this increases our transparency and user-friendliness. Let me show you, it's still being built. It's still being built, so this is the beta version of the platform. I can't show you the actual reports because they are confidential, but this doesn't stop us from looking at the platform. So on the left, you can see the menu. You can select different tools that we have. And there, the researcher or the product team, they can select the exact thing they want. For this, we can't address Jack's problem because you already need to know what you want. But this addresses our transparency and our tool problem. Okay, so here for this specific tool, we can choose different views. We can upload, download the data. The user can also specify the objects they're interested in. And from that, download all of the images. Next, we've got another tool. We've got Scanner. This Scanner tool allows you to get relevant scanner reports. Again, the same. Upload, download data. You can select the layer, the job, the trend. A lot of customization there to get exactly the data you need. All right. Next, we have some tools that produce images as well. So what we did, we built a functionality to allow researchers to annotate the images and measure the distance of them. So you see here on the slide, and this is the distance measured from the computer. These annotations are saved as a separate layer in the application. So after creating an annotation, they can create a view to compare the original and the annotated version of the image. So as you can see, the platform can encourage transparency, but also can provide different users, in this case, researchers who would like to measure the distance, maybe some product people as well. This allows them to be more efficient. This makes their life easier, and that's our goal, right? I believe my time is about to be up, so let's summarize. Final word on collaboration. You can promote data learning across teams by establishing communities of practice. What is this? You organize a meeting where you gather a bunch of employees with interest in your data. They come together, they share knowledge, and they share their best practices. Of course, also, I think the most important is data ownership. You should assign responsibility for the management, for the quality, for the security of data to specific people, specific roles. This puts accountability on people. This will help Vadim to trust the data more, knowing that Vadim has a question, he can always ask the data owner. So in general, I think it's good to focus on data product thinking, let's call it that. Data has a customer side, with value creation, and a producer side with responsibilities. Those two should be in balance. Data product is also something functional, right? This makes it easier to lend ownership in the business. Business likes functional things. Data ownership, exactly about that. I think all personas in your company become at least enabled or more efficient in doing their day-to-day job if you embrace this mindset. All right, so my time is up. Thanks a lot for having me here. If you have any questions, feel free to shoot me a message on LinkedIn or in the chat. And thank you.
Thank you very much, Sophia. That was great. Very quick session there. You covered actually a lot of stuff within there too. Great for democratizing, basically making the tools available so that people can actually use it themselves, bringing data in, ingesting, and actually getting stuff out of it. So very, very cool stuff that you're doing at your work.
Thanks a lot. Thanks a lot, Charlie.
Thank you very, very much. And I think we're about ready to go to the next session. It was a very quick one, as we said. We've got now Alexander on the screen now too. Alexander, we're going to hand over to you if that's okay.
Okay.
Adding your presentation to the screen. How's that? Oh, we've got a bit of a time warp. Okay, brilliant.
So that's better.
Yep, we can hear you and all good. Oh, we've lost your presentation.
Yes.
One more time.
Back. Oh, not. I didn't hear anything. So, okay, I try it again.
Yeah, please, go ahead. Go ahead.
I click presentation. I want to share my screen. I want to share my whole screen. Hold this one and share. So, and now you must see my slides.
Yes, we do. We see your PowerPoint deck.
Okay.
And your desktop.
Yeah. And now you see my whole slides.
Yep, and now it's the full screen. Perfect.
Okay.
Yep,
10 minutes or 15 minutes about Gen AI and data engineer.
Go ahead.
Yeah, okay. Who am I? I'm Alexander Klein. I'm more the BI consultant. And I do some stuff with the SQL Server, and since many years I do all the same stuff in the cloud, especially Azure and AI, and this is one of the reasons why I want to present you what you can do with Gen AI if you are a data engineer or a consultant. So, generative AI. No one knows what it is, so it feels like the manual in the IKEA. You have no clue. So what's the first step? The first step is, okay, in this case, ask someone who knows something about that. Yes, we can ask the Gen AI. What is Gen AI? If we do that, we have to talk first about some buzzwords, like artificial intelligence, AI. This is the big thing. If you talk to your manager, you say, yes, we want to do some fancy AI stuff. And the manager says, that's cool, that's great. But you don't have to talk about machine learning, deep learning, or Gen AI to the manager. He had no clue about that. So it's okay to talk about AI with the management, but if you talk more with the developers and the people in your team, talk about machine learning, or in this case, you go more deeper in deep learning, Then you have the big LLMs, language models that are trained by big companies like Microsoft, Google, or AWS. And this you can customize with your own training data. And on the other hand, you have the Gen AI part, where you see the first part of that was ChatGPT. And now there are different versions, like from Microsoft, the Copilot. It depends what you want to use, or it depends what the customer has. If they had your own instance, please use this instance that they offer, and that all the data that you use are safe. If you don't have your own instance, then there are some check mark that you can set that they don't use your input data for further training and so on. Okay, now, if you work with AI, it's in my mind, it's very helpful if you have a positive mindset. If you are more in the panic way, says, oh, AI takes over my job, then I think you're more in the Terminator scenario. That's not good. On the other hand, if you say, no AI, no whatever, I don't want, I think this doesn't work work out in the future. So I think you need a positive mindset. Says, okay, I can use the AI as a new colleague. I can ask him anything, and I can be with him insanely productive. This is the mindset I think you need to work with AI in general. If we had this positive mindset, then you can say, okay, hey, I have my own Albert Einstein. Okay, it depends on how much data your AI was trained. Maybe you have a high school teacher, Einstein, or you have the cool Albert Einstein who knows everything about the Relativitätstheory. It depends on the training data. How much more training data, more knowledge he has, and I think, yeah, it's a good colleague, a virtual colleague that you can use as a sparring partner, or you can ask him anything that you don't. I have no idea. I have this problem. Okay, we can talk, and we will see what the solution is. He will suggest you. Okay. One part is writing code. For me, as a BI consultant or a data engineer, yes, I spend a lot of time during the week of writing code. Like I have to connect to JSON files, MongoDB databases, Parquet files. And if you do this with a notebook, then you normally have the connection for the file, and you have normally a definition of the structure. And for this definition of the structure, you can write it by your own struct type, or you can use the AI. I send the AI the file, and the AI analyzes the structure and writes me the code that I can use with cut and paste in my Python notebook. Yes, of course, you have to look at the code, be careful, but in 90% or 95% of the cases, it works very well. And in at least the last 5%, you have to write something better, or have a look where's the issue, correct it, and then, yes, it can save me a lot of time. The next step is writing no code or low code. In this case, is no code. If you talk about the Azure Power Automate, or the Power App in M365, there on the main screen, he asks what you want to do. Like, think about, I want to create a new app, and then I can describe what the app should do. I want to create a new app for my inventory, and then I give him more input and says, okay, I want to have the information about the item, the employee, the in date, the out date, and so on. And he builds the table structure in behind on base what you write, or you can talk to him. The same thing is on the Power Automate. There you can say, yes, I need a workflow every Monday. He had to check my emails. Every email with an attachment should be saved on OneDrive or on a SharePoint or whatever. then you can just write and describe, and he built it for you. For people who have no clue about developing, yeah, that's good. And for us, on the other hand, as IT professionals, we can use it as a template, because I think 90% of the whole work is to think about what they want to do, where came the data from, how have I to transform the data in the right format. And if they had all the work done, for me, it's very easy to say, okay, this is the step, the next step, and that's fine. Okay. We go to the next step, writing text. Yes, I can use the AI for writing text, like write an email to my colleague that the backlog item 1, 2, 3, 4, 5 is finished and ready for testing. And please write me in the email with 300 words in a professional way. Yes, and then the AI writes the text and I can send the email. On the other hand, I can do the same thing the other way around, like checking my incoming emails and give me a summary of the email with the long text. But if I use the AI to send the email to my colleague and my colleague uses the AI to summarize the incoming email, then it doesn't make sense. The AI writes text and the other AI use the text from the AI to get out all the main phrases. Yeah, okay. So one point is generating images. Yes, from day to day, some people came and asked, yes, we need a new workspace in Power BI, and our workspace needs a cool background image. Can you create one? And I say, okay, you don't have any images that I can use? No, we don't have any images. Okay, then I can ask Copilot, please draw me images for whatever, and he draws me in images. I get normally for different images. I can choose one, or I can ask him, yeah, use this one, and I want to have more color in the background or whatever. And then I have an image that I can use in Power BI, or I can use the images here in my PowerPoint presentation, or I can use the images for whatever I want. That's very, very easy. In the past, you need to have access to huge image libraries, and you have to pay for that. And now you can use your AI and you get your own images specially created for you. That's impressive. Okay, here I ask him for draw me an image for the Data Saturday number 50 in Germany. And here I got 4 different images. Mostly he used the right text, but sometimes he write different text in the right or wrong version. And here he found out, okay, there is also some text about the event. And that was interesting. Normally he just draw the images, but here he found in his data also information about the event here in Germany this year. Okay, gain new insights. As I mentioned some slides before about the your personal Albert Einstein, yes, sometimes or in the past you do a brainstorming with your colleagues, you sit in a room, you think about and so on and so on. At the end you have on the whiteboard all new things that you say, maybe we can use that, or we do it the other way. And now if your colleagues don't have time, you can use your personal Albert Einstein to talk about the problem. And sometimes, yes, you get interesting inputs that is possible to solve this problem because he knows everything he was trained from. And yeah, it is a good way to say, yes, let's talk about that. And of course, it's also necessary to ask him questions where you know the answer, to figure out if he gave you the right answers, or if he just says something wrong and thinks, yes, I'm right, but I told you something wrong. And this is necessary because from month to month, they set up new versions of their Gen AI tools, and then it's important to test the new version with questions where you know the right answer, to think about, okay, if I ask a question where I don't know the answer, if the answer from the AI is right or maybe is it wrong. Okay, so sorry, I forgot about Gen AI. Yes, Gen AI, yes, but you have to think about data protection. Be careful
Hey
what
there,
data
Alex.
you use as an input. Yeah.
I think we're pretty much on time. So let's have a quick wrap up and then we'll head on to the next session.
Yeah, this is my last slide.
Perfect. Thank you very much.
Okay. Think about data protections. Be careful where you upload your data, integration in existing software like Office, Teams. Also think about human is the limitation. Albert Einstein, he knows everything or the most, more than you. Test each new version and don't trust blindly the AI. And at least the only way to keep AI from taking your job is to use AI to do your better job. Thank you.
Thank you very much, Alex. That was great. We covered a lot actually in the 15 minutes. Thank you so much for that. We now have Andy coming up, and we'll quickly put him on screen with us as well. Let's see, as it's coming up. And cheers, Alex, and we'll talk to you again later. Andy, are you ready for us to present?
Yes, can you hear me okay?
We can hear you. We can't see you at the moment.
Okay, let me try and fix that.
I'll try it again.
Oh. Okay.
Yeah, I can see you now. Great.
There we go. Okay.
All right. So I will also add your screen to the stage, and then I'll hand it over to you. Thanks for joining, Andy. And
brilliant. So please, Charlie, cut in if there's any issues with the screen or the audio or anything like that.
Will do, most definitely. Over to you.
Thank you very much. I'm just going to put my stopwatch right in front of me so I can see everything that's going on. Well, so I hope you've been enjoying Data Bash so far today. I think this is now the third Data Bash, so it's really great. It's a perfect time of year as well. After summer holidays, kids have gone back to school, and we can get back to some proper learning. So welcome to my session, and we're going to be attempting to look at a platform from a specific viewpoint. So we're going to look at a platform from the database administrator perspective. I'm just going to hold on for 1 second. There we go. So we're going to look at it from the perspective of the database administrator. Now, it doesn't necessarily mean that you have to be a database administrator. This is more about understanding that sometimes things aren't magic and you do need to look after them. And that's the case here with Microsoft Fabric. So we're looking at the warehouse service itself. So a little bit about me. That QR code will take you to my link tree. And from there's my company blog, my personal blog, my YouTube channel. But I work predominantly with the Azure Data Platform services. I'm independent. And I've worked with Microsoft technology for 20 years now, well over 20 years in the data space. So if you could imagine back in the 2000s, it's the traditional MS BI stack, SQL Server, analysis services, so on and so forth. More predominantly in the 2010s into cloud. I actually started doing AWS before Azure. Azure started to come into its own, I think, in about the mid 2010s, so about 2015 onwards, really, when I started to use Azure SQL Data Warehouse or dedicated SQL pools. So firstly, massive thank you to the organisers. Look, this is a community-focused conference. It's free. So everyone that you see here has taken their time to not only create the conference, curate the sessions, monitor everything that's required to run these conferences that, you know, me as a speaker, I could just turn up and speak, and you as attendees, you can watch and learn a whole bunch of things across. So massive thank you to sponsor and the organisers. So when we're looking at aspects of the Fabric data warehouse that might be relevant to the role of a database administrator, and these are the things that I've put together based on understanding the things that might be most important to a DBA. Between you and me, I was a DBA many years ago for probably a couple of years. And that was back in the early 2000s. And I was administrating Azure SQL. I was administrating SQL Server 2000 before I got into the world of data warehousing and development. So I like to think I have empathy, and I'm not just going to bring a server to its knees, that I will help my fellow DBA. So we're going to look at the compute itself, the Fabric compute and the SQL engine. The connectivity. So it's a cloud warehouse. How do we get to it? How do we connect to it? What are we going to use? What do we see? Storage. So as any DBA knows, storage is an incredibly important aspect. How do you set up storage? Are we in the world of being able to configure storage like we normally do? Yep.
Your camera seems still frozen again.
Okay.
Maybe your screen as well. No, the screen's working okay.
The screen's working okay.
You can go to the screen if you like.
Yeah, okay. So what I'll do is let me just try one thing with the camera, where I'm just going to change it into a different port. Okay, so let's see if I can start the camera up again. Okay, I think you can see the camera. So let's go back there. Thanks, Charlie. I think it froze USB 3. Okay, so if everything's okay, we'll carry on. So storage, yes, the world of the DBA. We'd be involved in setting up storage, RAID, configuring RAID arrays on disks. What are we doing here? What about looking at the system itself? Do we have any way of looking at who is connected? What aspects of Fabric Warehouse do we have that we can look at and see how many people are connected? That kind of thing. So we'll look at that with metadata and DMVs. Transactions. Being many a developer who's brought down a server with some errant transactions, what do we have in terms of options here? What isolation levels do we have? How can we help developers better write their queries? Security. How do we lock down the warehouse? With this service in Fabric, there's a couple of caveats to be aware of when we're applying security. How do we see what's going on? You know, we look at a platform like SQL Server. It has many ways of monitoring, many well-established third-party tools to monitor SQL Server. We've had these for decades, and they are fantastic tools. What do we have here? What can we do here? What happens when things go wrong? So we'll look at a bit of disaster recovery and source control. Okay, this might be a little bit of a Venn diagram with developers, but how are we linking this into a source control system? What source control systems are available to us? How do we deploy? Developers are like, well, I've done my thing. Can you get it live now? And we'll look at some performance tuning or some things, some aspects of Fabric Warehouse that we need to look at to be aware of. So what I want to do is set the scene a little bit. So it's Friday. It's late afternoon. Obviously, we've had a code freeze for the day, so nothing is being deployed. And we're ready to leave the office. Oh, we get a WhatsApp. We get text. That person with no planning ability has messaged you, the DBA, to say, hey, look, we got this new thing. You have to look after it. Okay, sorry, I've just seen this. I'm about to leave the office now, so maybe I'll check it out in a bit. But I see Fabric Warehouse, and I think, well, okay, so what's a Fabric Warehouse, and why do I now need to look after it? And that person with no planning says, well, hey, it's going to solve all our problems. Yeah, no problem at all. Yeah, we're gonna migrate. We're going to do these amazing things in the cloud. So with a bit of a weary sigh, us as DBAs or our local DBA friend might say, okay, you know what? Let me have a look at it then. Let me solve the problem for you. Let's have a look at Fabric very quickly. When Microsoft created Synapse Analytics, which was the cloud analytical system, they built a new studio or a web app and brought some Power BI functionality into it. I don't think I ever really saw many people use that Power BI functionality, to be quite honest. So what Microsoft have done here is moved SQL computing, Spark, there's real-time streaming, into a more familiar world of Power BI interface, more familiar to people who use the reports themselves, people who build reports, people who build data models, maybe less so for data engineers, maybe less so for DBAs, database administrators. Okay, so the first thing is it's moved into, and I like the GUI of Power BI, but it has moved into the world of Power BI. We're not really purchasing servers. We're purchasing what's called a capacity. We'll look at that in a little while. One thing to note is that a lot of the control is abstracted away from us. Spark configuration we can do. We can create clusters, size of clusters, auto-scaling policies. Fabric Warehouse, less so. The biggest departure in terms of storage is that it's all now underpinned by Delta format. And this logical concept of one lake, which is essentially Azure Data Lake Gen 2. So we're not having to configure disks. We're not having to configure storage. This is all managed for us in Fabric. So we're not even responsible for creating Azure storage accounts and linking to Fabric. It's all part of the platform. So again, why would that person text you and say, well, we've got Fabric now, we've got a Fabric Warehouse, and you think, okay, well, why would you want to do that? So with Fabric, we're really looking at building an end-to-end data platform solution. We've got a bunch of source data, APIs, relational databases, third-party services, file systems. With Fabric, we've got the services there to connect and ingest that data. We can process that data. We've got notebooks, data flows, T-SQL. We can store that data. We've got different storage methods, lake houses, warehouses, real-time streaming databases. Ultimately, why are we doing all of this? Well, we want to push some reporting downstream. Maybe we want to do some of that funky artificial intelligence and machine learning. Ultimately, Fabric is a software as a service platform, which essentially means that Microsoft are looking after the compute for you. They're looking after the service. They're keeping it running. They're keeping it patched. They're maintaining it. You don't have to worry about having to take the service down for maintenance. It's all being done for you. However, you are responsible for the data. So whatever data you're ingesting into Fabric, well, that's your responsibility. As is security. Various options within Fabric to do with security. But ultimately, we're on that left-hand side in terms of software as a service. You know, Microsoft are looking after all of the physical side of things and the software side of things for you. You're just looking after the data. So in terms of the warehouse service itself, yes, it's T-SQL software as a service. We're not having to install SQL Server. We're not having to provision any form of Azure SQL database compute or dedicated SQL pools compute. It's there for us when we enable Fabric. So this concept of serverless, there's always servers, right? There's always servers, but from our perspective, we see it as serverless because we don't have any servers to manage. Great news. There's automatic maintenance, you know, behind the scenes in the Fabric warehouse as well. But the interface is going to be very familiar to anyone with any SQL experience. Creating tables. You've got columns, you've got data types, stored procedures, views, functions, all the familiar T-SQL and relational database constructs. There's limitations because this is doing a very specific thing. This is for analytics. It's for data warehousing. It's not really for your row-by-row transactional system processing. And it does now truly separate storage and compute. The warehouse service itself is a little bit more of a closed system. So the way that it works with storage is not really that accessible to services outside of the warehouse other than to read the data. So we can't modify data outside of the warehouse service. But the storage is what you would consider open source. We're using Delta Lake, which is based on Parquet. So as a DBA, you're looking at the data and the structures and the logs, but they're stored within files. Those files are going to be stored somewhere on a system. It's not like I like to think of Parquet files as the MDF and LDF files within SQL Server, but Parquet files hold a lot of information. They hold the data itself, the structure of the data, they hold statistics. Just like, you know, an MDF file for SQL Server would hold all of that. Delta itself then adds the logging ability. Hey, well, that's an LDF. And we have transactional consistency. There's been some arguments that it's not really full ACID, right? And maybe we'll look at we're going to look at the transaction aspect in a bit. But we have the ability to read and write data and ensure that that reading and writing aren't blocking each other. And more importantly, is committed and isn't corrupt and isn't left in an unusable state. So in terms of what are we using the warehouse for? Well, it's for the right-hand side. If you're going from left to right in your data flow. Is it for raw data? Probably not. Is it for cleansed data? Maybe. Is it for facts and dimensions? Definitely. So that's where you want to be putting your cleansed data that you've modeled. Think dimensional model. Now, I'm just going to pick dimensional modeling as a data warehousing methodology. Other methodologies are available, but you will have to look into whether the warehouse is suitable for that. But if someone's asking you to look after a fabric warehouse, have an eye on the fact that it's going to be a warehouse, a data warehouse you're looking after, not a line of business application, row by row inserts. Well, I think after 17 minutes, it's 18 minutes past the hour. It's all magic, right? It's all done because it's all in the cloud. So no one has to look after it. No one has to be mindful of any considerations. Microsoft takes care of everything. So yeah, I think that's it. I think that's 42 minutes left. Except it's not quite magic. There are some considerations. So the first thing is all about the fabric compute. Well, what's running compute? So we can go into, someone can go into the Fabric/Power BI admin portal, click the button that says let people use Fabric, allow Fabric workloads. Oh, fantastic, brilliant. Okay, well, what do we need to actually run it? So there is compute. You do need to provision compute. That compute is provisioned within Azure, and there are various tiers of compute, starting all the way from an F2 SKU, scaling all the way up to about an F2048, I think the maximum is. I think you have to ask Microsoft if you want to provision an F SKU that much, and you probably need to get out quite a few credit cards to be running that sort of SKU. But if someone's coming and saying, well, how do we use Fabric? Well, just as you'd be buying hardware and installing SQL Server or any other relational database on that hardware, you're going to have to provision compute. You're going to have to go into Azure and say, right, I would like a Fabric SKU. It's going to be this size. Start. Then you can start assigning your workspaces within Power BI to those SKUs. Now, a single Power BI tenant supports multiple SKUs because a SKU, or sorry, a capacity is region bound. So if we create a capacity in UK South, the data is going to be stored in UK South. If we create a capacity in America, data is going to be stored in one of the regions in America. Yes, capacity planning. We do have to make sure that we're going to be provisioning compute that is going to meet our workload expectations. So when you're buying a server, you're not just going to close your eyes, pick a server size and hope it's going to work. You're going to be saying, right, well, I need 16 cores, or I need 32 cores, or 64 cores. I need 128 gig of RAM. I need a terabyte of RAM. These are all the considerations that you need to go through when you're doing your capacity planning for any other system. And it's the same here. But a couple of the concepts don't really have a lot of time to go into are called bursting and smoothing, where for periods of time, if any of your workloads need more resources than your current capacity can handle, your capacity will burst beyond its means. You are essentially borrowing from future compute. That's the smoothing aspect. So you can't burst all the time. Otherwise, you're going to get penalized. You'll get throttled and you'll get charged for it. However, when we're looking at these workloads, if we were provisioning a server, or we're buying hardware, or even provisioning a server in Azure or one of the platform as a services, we're going to have to provision our service to meet the demands of that tallest spike, that spike that's reached about 150, 160. But otherwise, our workloads are going to fail. Fabric, on the other hand, it's more of a smoothing out of the workloads. So we don't really have to care too much about the spiky workloads, because, or more accurately, we do care about the spiky workloads. We just don't want too many of them. Otherwise, it's going to affect the capacity's ability to smooth out that workload. So when you're looking at your workloads, understanding when data loading processes are happening, this is what you're going to be looking at. But if we're going to put a hard value in terms of what these capacity units mean, so for the warehouse service specifically, even though the documentation talks about 1 CU equals half a core, well, I can't provision a capacity that's only 1 CU. I've essentially made it so that 1 core, 1 virtual core, equals 2 capacity units. So for example, if you were to provision an F64, that's going to give you 32 cores, or the equivalent of 32 cores for the warehouse service. But of course, that capacity will be shared by any other workloads in workspaces that you've assigned to the capacity. So think about not just the warehouse service itself, but also the other services, pipelines, notebooks, semantic models and reports, so on and so forth. So with the bursting, Microsoft are giving you extra compute. However, with the warehouse service, there are guardrails. It's not just going to burst to infinity and give you a massive either throttling or bill headache further down the line. You've got some scaling factors. So, for example, if we were, to look at that F32, it gives you a 12 times scaling factor, right? So it's going to take you up to a much higher skew for the duration of the bursting, or that's its maximum that it'll take you up to. After F8, the scaling factors are the same. So you're going to get 12 times that scaling factor. I can only imagine how much compute is if you scale up from an F2048. But all of this is automatic. You don't have to do anything here. But you do have to monitor. We'll come on to that in a little bit. Now, in terms of ingestion and querying, the Fabric Warehouse, it has a concept of workload isolation, where a warehouse will isolate its ingestion processes from its querying processes so they don't affect each other. So the guardrails actually apply independently for ingestion and querying. So it's not all just lumped into one thing. So in terms of the SQL engine, so I'm just going to bring it all up here. This is the world of distributed computing. So all the things you know about on-premises SQL servers, they apply somewhat here. And there is SQL Server within Fabric SQL. But the journey started, over 20 years ago. Microsoft purchased a company, Datalegro, and its technology, wrapped it in a bit of SQL Server love. We end up with the parallel data warehouse and the analytics platform system. Microsoft then Azurified it, put it in Azure and made that. And we got Azure SQL Data Warehouse Generation 1 and then Generation 2. Generation 2 is what we have in Synapse Analytics, with a new service that Microsoft created based on a new engine, Polaris, serverless SQL pools. That's the engine that we have in Fabric SQL. So it shares some heritage with SQL Server, but its architecture is different. So I'm not going to dwell too much. Obviously, I'll make the slides available afterwards. But really on the right-hand side on the Fabric Warehouse, look, we're not installing anything. We've really got no control. It's all auto-scaling behind the scenes for us. based on the query and the workload demands. At the moment, we can't partition any tables. At the moment, there's no indexes. The data itself is the index. The Parquet files are column store compressed files. So it's like creating a table in SQL Server and applying a column store index. That's what those Parquet files are. So there's no non-clustered indexes on tables, for example. And we don't have the full range of isolation levels because really that warehouse is designed for loading and for loading data for warehousing and then reading. So we don't have to have all those fine-grained isolation levels that transactional systems need to have. We've got an isolation level that is standard across Delta and a lot of the cloud, let's say, ACID compliant services that work with file formats like Parquet. So we've got Delta, we've got Iceberg, we've got Hudi. By and large, they have a minimal set of isolation levels. So when we're connecting to this magical Fabric warehouse system, well, firstly, we're creating objects. Okay, yes, we can create objects, or rather Fabric items programmatically. We can use the API. Interestingly enough, the Fabric Terraform module has just been released. It's very beta at the moment, but if you like to wrap up all your infrastructure into code, Terraform is going to be there to support how you would do that within Fabric. Want to manage how to deploy your warehouses and pipelines and notebooks? The Terraform provider is going to help. Ultimately, when we look in a workspace, well, we've got a whole bunch of items. And obviously with Fabric, we've got a lot of items that we can deploy. Really, if we go to one of the common tools that's used in SQL Server, which is SQL Server Management Studio, well, we can see warehouses as if they were databases. When you create a warehouse in a workspace, really what you're doing is you're creating a database on a server. A workspace is in effect a server. We can connect to it using database projects in Azure Data Studio. So common tooling that we use. Every warehouse and Lakehouse SQL endpoint within a workspace exposes a SQL endpoint. The thing is, the SQL endpoint, it's the same for the top level workspace. When you connect in your client tool to your Fabric workspace using the SQL endpoint, you're going to see the warehouses and the Lakehouse SQL endpoint as databases. It's going to enumerate as databases. So whenever I'm looking at the endless discussion in forums about, well, how many workspaces should you set up and where should you put your services, I always think about the fact that, okay, I'm looking at a workspace almost like a server. If I'm going to look after a workspace, I'm almost going to look after it like I'm looking after an individual server. But when we create workspaces, those workspaces are connected to a capacity. So you can have 10 workspaces which look like 10 servers, but they're all running on the same capacity. So with storage, now, this is an area in which up front, I'll say we don't have an awful lot of control over. So we're using Delta. Microsoft chose Delta. Delta is what is providing that transactional capability. That's what's ensuring that when you're reading and writing to these Parquet files, There's no corruption when you're writing, that everything is left in a consistent state, adhering to ACID principles. Atomicity, consistency, isolation, and durability, making sure that when you're writing data, it's not becoming corrupt. And also when you're reading it, you're not going to read uncommitted data. However, with this storage, there comes some issues with it. Parquet files are essentially immutable. Once you've written a Parquet file, that's it. You can't go back to an individual Parquet file and update some of the rows or delete some of the rows or insert some new rows. So what Delta is doing, it's managing how those Parquet files are being written. If you're constantly writing small updates to the warehouse, what's going to happen is you're going to get lots and lots of smaller Parquet files being created behind the scenes. So if I do an insert and then another insert and then another insert, more likely I'm going to have multiple Parquet files under the hood. Now, lots and lots and lots of small Parquet files are not really very good for reading, because whatever engine is reading those Parquet files, it has to enumerate the Parquet files. It has to crack them open, look at the metadata, and read them. There are options, and these are standard options with Delta tables, so Databricks, lakehouses in Fabric. We can optimize and vacuum. Optimize is all about hoovering up lots of small files and creating a fewer larger files. Yeah, column store compression, which means we're going to get a lot of compression into the files, obviously depending on the cardinality of the column. But that's going to make read performance a lot faster. We can't control any of that. We can't set or trigger any form of optimization. The warehouse is doing it behind the scenes. It is looking at your querying. So it's not just doing this for every single table. Based on the queries that you're running against your warehouse, the warehouse service will think, okay, so you're using these tables quite a lot. Tell you what, I'm going to go and optimize them. So it will go and either rewrite the data to optimize the Parquet files. And vacuuming is essentially just removing old data once these new Parquet files have been written. So at the moment, I believe the 7-day sort of vacuuming period has been increased to 31 days. But this is all automatic. You have no control over any of this. And we'll talk about the V ordering later on in the performance analysis. So with metadata and DMVs, well, there's a cut down number of DMVs. So we don't have the full range of DMVs that we would have with SQL Server or Azure SQL Database or dedicated SQL pools. And to be honest, it makes sense because of the whole bunch of DMVs that are just not relevant here. So for example, you're not going to need any DMVs related to files, or sorry, related to MDF and LDF files and things like this. But we've got connections, right? So we can look at DM exec connections. We can see who's connected, the client address that we're coming, the authentication method. We've got sessions. So we can see number of active requests and the status of those requests. And, well, exec requests as well. So if we've got any queries that are currently being executed, we can see those in the DMVs as well. Now, you as the DBA, you do have, well, if you've got permissions, which you should have, if you are a workspace or Power BI / Fabric workspace admin, then you're going to be able to see all of these DMVs. And more importantly, if there's anyone who's run something that's clogging up the system, we've got the option to kill the session. Now, everything is magic, except when it's not. We do have to look out for how we're writing data into the warehouse, because we still have transactional capability, we still have isolation levels. Okay, now a big thing is said around the differences between lake houses and warehouses and which should you use, and Microsoft have a table to tell you if you're going to be doing this, the lake house, if you're going to be doing this, the warehouse. So at the moment, we have these two objects to choose from. One of the aspects that Microsoft call out is the fact that you've got this multi-table transaction support. So if you're trying to read and write to multiple tables and you need that consistency across those tables, then we can wrap multiple table workloads into a transaction statement. The fact that we've got snapshot isolation is the only isolation level supported, it kind of makes sense because we're using Delta, and that's essentially the isolation level available for Delta, which is the most optimistic of the concurrencies. I mean, if you have a favorite isolation level, for me, as predominantly a data warehouse developer, yeah, I like Snapshot, right? Because I can query data as I'm loading it. Things aren't gonna lock each other. However, at the moment, the locks are at the table level. So what this means is that statements can affect each other. Now, insert statements, there's far less chance of locking becoming an issue because Parquet files are immutable. Inserts are always going to go into their respective Parquet files. Metadata will be updated. So I don't see many issues with multiple concurrent insert sessions into the warehouse. Where I find the trouble is updates and deletes. Updates and deletes are the process is like a kind of a first past the post. If I issue an update statement and then 5 minutes later, whilst that update statement is running, my colleague also runs an update statement. If my colleague's update statement finishes first, my one gets kicked out. And it's the same with deletes. I see it quite a lot on forums. People post the error message to say, I can't quite remember the exact error message, but it's, this transaction has failed because it can't access the table. So it's something to be aware of. But you can see the locks, right? We've got the DMVs to show the locks. And there are really only a handful of lock types that we're going to see. If we're selecting data, we're going to see a schema stability because we don't want the table schema to be changing while we're reading that data. On the table level, we're going to see intent exclusive. Inserts, like I said, I don't see too many problems with concurrent inserts. But deletes and updates, you're going to see some problems if multiple statements are hitting the warehouse at the same time. And yeah, a table is going to have a schema modification lock if you're doing any form of modification on the table. We're limited in terms of what we can do with schema modifications on the table. We can only really add primary keys, unique keys, and foreign keys, which are not enforced, or we can add a new column. We can't change the data type. We can't drop columns. So I find this less of an issue. So in terms of security and permissions, so this is where I said earlier, we've got a couple of caveats. And again, I see a couple of questions on forums about this. Now, what's one of the most common duties that a DBA performs? Access. Hello, friendly DBA. I would like access to that lovely production server. Well, okay, let's discuss it. But doesn't matter whether you've got workspaces dedicated to dev or test, UAT or production, we're going to need to set up security. And it's multi-level. It's not just at the warehouse. Other levels of security are going to affect how this happens. So essentially, we look at the workspace level. So these are roles that have existed for many years within Power BI. We can be an admin of that workspace, i.e. we've got full control over that workspace. We can be a member, we can be a contributor, we can be a viewer, right? Those permissions allow you to do certain things with certain objects within Fabric. From the warehouse perspective, if you're given any of these permissions, it has a drastic effect on what you can and can't do within the warehouse. I'll come back to that when we look at the SQL granular permissions. So yes, by all means, if you have warehouses in workspaces, set these permissions. However, if you set someone as an admin, a member, or a contributor, they get control permissions on the warehouse. Quite high level. In fact, very high level. If you add them as a viewer, they get added as a data reader. They can read all the data within the warehouse. Not particularly granular. So let's say we've got a couple of items or a couple of warehouses in our workspace. What we can do is we can share the warehouse. That's initiating the permissions process here. Again, one of the common things I see is when the share pop-up appears, you've got some checkboxes and you can say, right, I'd like to, actually, I'm going to bring them all up here. I can read all data using SQL, so a DB data reader. I can read all data using Spark, i.e. I can get in to the files that underpin the warehouse themselves and can build reports, right? So if I'm a BI developer and an analyst, I'm going to be able to be given permissions to build reports. However, there is another permission that you can set when you do this sharing process, and that is no permissions at all. You click on share, up comes the pop-up, everything is unchecked, is deselected, and you share with the user or the group. What that does is that gives them connect permissions. It does not give them permissions to do anything else. You then have to go in and you do the granular permissions on the objects. Now, this is important with workspaces because if we use constructs like row level security and column level security, we can do the necessary grant. So grant select on, this table and these columns. I'm initiating, to such and such. So I'm initiating column level security. As soon as I were to apply a workspace permission, that completely overrides all of the row and column level security. So one to be aware of there. Now, in terms of monitoring, okay, yeah, everything's been magic so far. We haven't had to do an awful lot. Our capacity will be consumed by multiple services. So what Microsoft provide is an out-of-the-box report that tells you per service, per workspace, what's going on, how much of the capacity is being consumed by these items. So you can see pipelines, notebooks, the warehouse itself. So with the warehouse, you're going to see reads and writes. I'm just going to bring up the fact that with Lakehouse SQL endpoint queries, they're reads. So you will see those in SQL endpoint query. But ultimately, what I'm interested in as the DBA, I'm interested in that CU. I'm interested in how many capacity units did that particular workload take, because I need to then make sure that that workload is not overrunning the capacity. At the moment, we don't really have much control over workloads within a capacity. So I'm interested in how many capacity units, how many total capacity units are my workloads taking, or other people's workloads taking, right? And we've got some OneLake stats in there in terms of reads and writes for the data. Now, with Query Insights, this is a warehouse specific functionality. So when you create a warehouse, you're going to get this Query Insights schema. And we've got 4 very important views in this schema. We've got the requests history, right? So it's going to show us, and I've got this note at the end, but I'm going to say it up front now. We've really only got 30 days or 31 days of history in these Query Insights table. If you want to store it for a longer period of time, use T-SQL, load it out of Query Insights and merge it downstream with something. The 2 that I use a lot are the long-running queries and the frequently run queries. Every single Query Insights view has the SQL command. So you're not going to have to join onto something like, well, now I'm being tested, sys.dm text, something like that, that brings back the actual command that was run. That isn't even supported within the Fabric Warehouse. The command is a column within all of these views. So if you need to pinpoint specific queries that are run, it's all there for you. The frequently run queries, that's the one that I look at the most, because it has statistics around the average time it took for a query to run, the minimum and the maximum. What's clever is what the Fabric Warehouse is doing is when it receives a SQL query, if it has seen that SQL query before, it's going to add it to these statistics. So for example, if a query's been run 5 times, it's going to take those 5 runs and compute your statistics for you. So the average is probably important to track over time in case any queries are starting to creep up in terms of their average time that they're running. You might be able to head off a potential performance issue if you're tracking these queries over time. Now, I am working on something, and I'm hoping to get it onto GitHub pretty soon, which merges the world of the Fabric capacity metrics with the world of the Query Insights, because we've got a common key that we can use. In the world of the capacity metrics app, it's called the workload ID. In the world of Query Insights, it's called the distributed request ID. That's the ID that you would give to Microsoft to do it. But what we can do is we can join an actual SQL query to the capacity units that used. We can't do that in Query Insights, but we can merge the 2 worlds together. And the reason I want to do that is because I can actually do some cost calculations. So let's have some fun and do a cost calculation here. Now, the metrics app, it's going to show you the total capacity units that a workload used. I'm going to take an example. Let's pick an F2. Now, the pay-as-you-go pricing at the moment for an F2 is 31 pence per hour. I go into my Fabric Capacity Metrics app, and I've seen that a particular warehouse workload for a given day has used a total of 8,000 CUs. How do I equate that to an actual dollar or pound or euro pricing? It may be that we're able to charge different departments for our usage. That's the goal. That's the end. That's the dream, right? So because these are capacity units a second, what an F2 really means is you're getting 2 capacity units per second. We do our calculations. So every hour, we're allowed to consume 7,200 capacity units. I'm not going to go into bursting or smoothing at this point, but that's what we're paying for, right? So if I do a calculation based on how much the capacity units are per hour, I can get to a price of, 0.159 per CU. So I'm going to do that calculation. And that's, by the way, that's not a pence. That's less than a pence. It's 0.15 of a pence. So I'm going to do my calculation. I'm going to say 8,000 times 0.159 divided by the number of seconds there are in the hour. I get my total price. Now that, if you eyeball it, that kind of looks right. I'm paying 31.8 pence per hour for 7,200 CUs. My workload has actually used 8,000 CUs. So yeah, 35 pence, a little bit more. But that's how you can work out how much each workload is costing. And the thing is, this calculation is going to work across the different SKU sizes as well, because the prices are scaled linearly. Now, with disaster recovery, a bit tricky here. So we've got restore in place, right? So we can restore a warehouse, just like we could do with dedicated SQL pools. Microsoft are just making these checkpoints behind the scenes, or these recovery points that you can restore to. So if anything happens to your warehouse, you can restore to a previously good known state. The only problem is it's the whole warehouse. It's not piecemeal restore. We can't do individual tables. Really annoying right at the moment. But the restore points, we've got automatic restore points. So we don't have to do anything. And I think that actually the days available has now increased to 31 days. But essentially, Microsoft are creating these restore points for you. However, you can do those yourself. So you can initiate manual restore points. So if you're told about a big deployment that's coming up, or a substantial data load, it might be worthwhile before that happens. Let's do a restore point. Let's create a manual restore point where we can sort everything out afterwards. Workspaces, if you delete a workspace, it can be restored. Warehouses, if you delete a warehouse, can't be restored. And we'll just finish up. So source control, we can integrate the whole workspace in Power BI/Fabric into Azure DevOps or GitHub. So all the items are going to be source controlled. We can do that though with Azure Data Studio. So if you use another Git provider, use Azure Data Studio with SQL database projects, and you're going to be able to source control. And we've got the option to use deployment pipelines to push those changes across workspaces. The problem is that if you do any form of modification with tables, be prepared for the table to be dropped and recreated. It can delete the data as well. And the last thing we'll look at is performance tuning. Yes, you can create statistics. There's manual statistics being created. There's histogram statistics. You can create manual statistics yourself. Unfortunately, you're constrained with using single column statistics at the moment. You can enable and disable V-ordering. V-ordering is Microsoft's special sauce to enhance the performance of Power BI semantic models when querying data directly in the data lake. We may want to disable this V-ordering if we're doing a lot of write operations in the warehouse, because it's very write intensive. So it's an increased amount of time and capacity units when V-ordering is enabled. Like we said, look, you come in at the warehouse service and you're using it as a warehousing service. Little trickle loads, they don't really work here. And there's a warehouse performance guidelines document for you to go through and make sure that all those pesky developers and pesky data warehouse developers are adhering to some performance best practices as well. So I think with that, I'm going to hand back. Thank you very much. Thank you to DataBash. Thank you for listening. I hope it's been helpful, and I'll make the slides available on social media.
I think I'm on mute. Thank you very much, Andy. How are you doing? Thank you very much for that. It was a great session. I was watching it intently as a DBA myself. So thanks a lot for the effort of putting that together. And
let's have a conversation, Charlie, at some point, because
great, let's do that.
It's my empathy towards the DBA, and to make sure that that DBAs know that unfortunately there is a role for you very much so within the world of fabric warehousing.
100%. There's still work to do, isn't there? Always.
Yes.
Oh, yeah. Brilliant. So thanks a lot, Andy. And we'll catch up later, definitely. And our next session starts in a minute. I'll quickly put up the agenda onto the screen there so that we can all look at it. And Andy, I'll let you sign off while we bring Michał on. Michał, would you like to enable your camera? That way we can come on board together. Brilliant. So welcoming on board here, Michał, and I'm taking Andy off. Yes. Welcome, welcome. So Michał is,
hi.
Am I pronouncing it correctly? Is it Michał or Michał?
Yes, it's perfect. Your pronunciation is perfect. It doesn't come very often like this one. So thank you.
I'm happy to hear it. Good. I know it's a hard one. So you're always getting your name butchered by all the Europeans and Western folk, for example. Well, we just came off Fabric DBAs and including in there data warehouses. So we're going to be speaking this time, a good extension to it, I guess, Power BI monitoring from the PBI REST API through the data warehouse and back again to the PBI. So Michał, we are on time and I will leave it to you. I'm putting your screen forward now.
Thank you very much, Charlie, for the introduction. I believe that we can very smoothly start our next session, which will be delivered by myself. So yes, it will be about Power BI monitoring, but also a little bit about Fabric, because the REST API is exactly the same for both Power BI and Fabric right now. So let's start very quickly with a short agenda. Okay, it does work smoothly. So I will start with the proper introduction. Later, we'll move to the governance and adoption challenges in Power BI. This is extremely important from this background perspective. I will try also to describe you why you should care about monitoring of all of the activities that are happening within your Power BI tenant or Fabric tenant. And also, you will see it clearly grouped into three categories, like this governance administration one. Later, there will be the adoption challenges, and last but not least, also the financial perspective of all of this. Just after this theoretical or a little bit also practical background, we'll move directly to the tool. I will present you one of the possible architectures of the solution that will help you to capture almost everything which is happening within a Power BI tenant. I will describe a little bit Power BI REST API calls that you should take care on, and later we'll move a little bit to the data warehouse. The final part will be a short demo, the overview of the repos that you can build using the data from a data warehouse, and I will also share a few information about the cases and where and when Power BI tracking and monitoring, from my perspective, was a pretty neat solution and answer some challenges. I believe that we'll have also some time for the Q&A. However, if you have any questions in the meantime, you can just put them into the comment section and I will try to answer them with the flow of the presentation. Okay, so let's go, like a quick introduction of myself. So thank you, Charlie, for the correct pronunciation of my name. So it's Michał, and my surname is Dębski. You can see two funny characters in my name and surname. Those are the characters from the Polish alphabet, and I am Polish as well. So who am I? I'm one of the founders of Astral Forest Consultancy Boutique, and right now I'm doing like the three things, let's say. First one is deeply related to this monitoring part as well, because I'm really into the topic of administration, governance, and setting up Power BI or Fabric environment correctly, knowing who is using what, and applying some kind of the governance practices, tracking the adoption as well. I'm also a little bit engaged into the prophecy solution. So once again, it's a little bit more from the master data perspective, but also touches the topics of governance of the data. And I like the analytics in Casino. So this is the things like this. A little bit from my past, which is relevant, I believe. I started like my career in MicroStrategy. Right now, MicroStrategy is all about Bitcoin. But before it went crazy about Bitcoin, it was a very neat tool. And this software taught me two important lessons. One of them is the importance of the good data modeling. The standard old way good data modeling dated back to the 90s, I believe, or 80s, with the Kimball approach. And the second one is the importance of the metadata, because this part of the metadata was even included in MicroStrategy solution. There was like a separate database with this metadata. And this is something that I like to imitate, for example, in the ETL design. Okay, so just a private slide as well. I am big dog lover, sidehunt lover. So if you like dogs or other animals, just you can ping me, and I will be extremely happy to chat about those magnificent creatures, especially the sidehounds or greyhounds or anything that runs very quickly. Okay, so that's all for the introduction. And right now, let's go and let's try to deep dive a little bit into the challenges of governance and adoption within Power BI or Fabric as well. So first of all, I've grouped those kind of challenges into three different categories, as you can see. Once again, governance and administration, adoption, and finances. As I work quite a lot with those kinds of topics, finally I realized that we have three different audiences or populations interested by tracking the usage of Power BI and the metadata of the objects within Power BI service, but they are paying attention to the different aspects. So let's start with the first one. The first one is someone who is responsible for maintaining, keeping in order the Power BI platform. Most probably it will be someone called Power BI administrator or Power BI architect, senior Power BI guru, or governance lead as well in some circumstances. Depends really on the organization. And how do I like to approach it? I like to see this person as a gardener, as someone who is responsible for gardening. You'll see very quickly why this metaphor is quite useful. So let's imagine that you are joining a new organization and you are this kind of a person, you are Power BI administrator. So first of all, you would like to know how many different objects do you have within your Power BI tenant? How many different semantic models, how many different reports, how many different data sources, workspaces, users, and so on. And Power BI itself service, you cannot very easily find this kind of information. And this is just like the first level of the information that can be useful. It is useful basically to your job. The other one is how many used and unused objects actually do I have within my Power BI tenant? Because if I have like 10,000 objects, Power BI reports, and half of them or even more is not used, so what's the purpose of keeping them? And this is when you should, this is the moment when you should thinking about this. You should be thinking about the garden, because if you have in the garden like lots of different lots of different herbs and the different trees that are collapsing, that are rotting away. It's not a nice garden. You should just remove the branches which are not longer needed, the plants that are developing too quickly, and they are overriding the space of the others. This is exactly the same, which is what is happening with the reports in the proper scale. You have too many reports, some of them becoming unused and redundant. You should remove them. But in order to do so, you must answer the question, which reports are really used or which reports are not used at all. The next thing is also that the fact in Power BI, you can attribute the accesses very easily. And you can attribute the access on so many different levels, because you can give the access on the application level to some people. You can also use workspace level accesses, the report level accesses, and even like the build permissions on a specific semantic models. So this is like the way you can attribute those accesses. But there is even more. You can also attribute these accesses either on the individual users, or you can use also Entra ID or Azure Active Directory groups. And right now, as far as I know, in Power BI service, there's no way to know who is a member of a given group, of a given Entra ID group. So it's kind of messy to, for example, check very easily in Power BI service through the user interface to what kind of the objects a particular person does have the access to. Or the other way around, who can access a particular Power BI report and how? It can be done, but it's not so intuitive. It's not that easy. So what's more, what comes very often, the question is who are the owners of the reports in Power BI, especially if you are producing lots of different reports and there's some kind of the rotation also among the employees in the organization, some people leaving the organization. If you have the proper scale and you don't have very strict processes, you can find yourself in the situation you don't know who is responsible from the business side for the given report. So you'd like to know it, because sometimes you just need to manage this kind of report, because maybe the data source is impacting some or 2 or 3 reports, and some decisions must be taken, but before they are taken, they must be verified by the business. A typical case that I had like a few months ago, there was a data source, SAP instance that was to be terminated. So first of all, what needed to be done was to check all the dependencies, the lineage, basically the lineage of the data source on the report zone. So this was the first thing to do. Once the lineage was discovered and all the dependencies were covered, we needed to see if the reports are used or not, because if they are not used to, we don't need to bother. But if the reports are used to, there's a next challenge, next step that must be taken in order to just move forward, the definition of the business owners. The way I'm doing it, I'm just looking for the people who are the biggest consumer of a given report. They are using the report the most often, and I'm asking them to become the owners. The other perspective is also, how are your semantic models going? How are the refreshes going? Because especially if you have the dedicated capacity, you would like to know as well. You would like to identify, for example, the troublemakers, the semantic models who started to become heavy to refresh, started to consume lots of resources, either from your Power BI or maybe from the underlying data layer as well. It's not also, there is also a challenge about the self-service, because even in some organizations, okay, I have my capacity, I'm taking care only about the capacity, but sooner or later, there are some business users who are either developing the reports in their own personal workspaces, or if you have the special, like the managed service workspace for them, they are contributing to this managed workspaces as well. And it's very good practice as well to track the usage of the self-created reports. There are 2 reasons why it's a good practice. The first one is that if some kind of the report is getting the traction and it's becoming to be used very heavily in the organization, this is a perfect candidate to be migrated from the self-service zone to the enterprise one. Why? Just because of sometimes the data trustworthiness issues. You want to be sure that the data is trustworthy and everything is clear and there are no mistakes that can be done by the business user in the Power BI report. And the second thing is just the security of the report itself and taking care of it, and the central department of BI in the event of a person responsible for creation of the report leaving the company. If someone leaves, it may be difficult just to find out why the report was built in such a way, what was the business rule that was applied, and the usual stuff like this. So you are just reducing the potential backlog from the future if you are picking up this kind of report and making it enterprise. Last but not least, you have also the security aspects, because, for example, in many companies, you have these guest users and the users from the other organization joining the company temporarily or for the few weeks or for the few months or even few years. I would like to know, for example, if they are not abusing Power BI functionalities like export to Excel. So I'd like to define this people from the other organization and check if everything is used correctly. You don't have any kind of suspicious activities regarding your most valuable data assets. And all of these challenges are attributed to this, let's say, administrator. Another perspective is the adoption one. And in this adoption perspective, once again, I have like the two different levels of the adoption, public adoption audience. So first one will be a little bit more strategical. So strategical will be, first of all, interested in what is our Power BI adoption or penetration. So how many users with the accesses to Power BI platform or Fabric platform are actively using it. So this is the first case. Another scenario that I would be interested also, what is our data trustworthiness? So how many certified data assets are consumed, or what is the ratio of such a consumption? The other thing, which is also extremely useful, is just to define the 20% of the top data assets within your organization. If you know the consumption of Power BI reports, which are at the top of all of this data infrastructure, you can identify also the underlying layer. And in the scenarios like the migration of the underlying data layer, you know where should you start, because you know the statistics. You can identify very easily your most important data assets. Or in case, for example, in the implementing, if you want to implement the new initiatives such as ETL tracking or the data quality of your ETL processes, you know also where to focus. You know what kind of ETL flows you should start with to ameliorate them, to make them better. So those are those kind of categories, let's say, more strategical. The other ones are more tactical, I would say. So imagining that I'm a leader of one of the departments, let's say pricing department, and I already have tons of reports because I was working very heavily with my BI team in the last 3 or 4 years, and I developed like very well thought of 30 or 40 different report pages. I'm very neatly covered right now when it does come to my analytical needs. Maybe I need some changes, or if in the event of a completely new business initiative, I will need a new report. But 80% of my basic needs are already covered. I don't need any new reports to be produced on the weekly basis, let's say. But right now, I change a little bit my focus. Instead of report creation, I would like the reports that are already there to be used as much as possible by the people who have the access to them. So I'm reorienting from the development mode to the mode which has the goal to increase the adoption. So if I want to increase the adoption, I shall know my user base. So I would like to know what are the most frequently used reports within my BI department. Who are the users, like the top users? Who can be my Power BI champions? So the people who will help me to lead the mission of making Power BI adoption bigger. I would like also to have the list of the people with the access to my reports, but the people who are not using Power BI at all, because I would like to ask them the question. So why you are not using Power BI? Do you even know that you have the access? Did you have like the complete onboarding process? Do you have like the trainings, or maybe you don't understand the report because it's too complicated and it needs to be simplified? All of these questions should be asked, but should be asked the correct group of people, so the people who are not using Power BI. And of course, once you are already putting the measures to increase your adoption in place, you want to track them. You want to track the progress. You want to know if you have more users, what is happening with your Power BI champions, what is happening also with the people lagging behind, all of this information. If you know also the advanced and not advanced users, you can better address the training programs to them as well, because you can propose something simpler to the people who are barely viewing Power BI reports, and something different to the people who are already, let's say, a little bit more advanced. And we have finally this third perspective, so the finances. So first of all, how much do I spend on my Power BI, on licenses, on capacities? Can I save some money on it? And like the very nice and hot topic right now, Showback and Chargeback reports about my Power BI consumption. So this is also something interesting. Okay, so let's move forward a little bit and just cover very briefly right now the default ways of getting some of information about the usage of your Power BI platform that are available by default. So you have like the feature usage and adoption, activity overview. You have also this classical usage metrics from Power BI report, but you have some serious drawbacks of this kind of the solutions. So you don't have the historical data in it. So this is the biggest one, because you have up to 30 days of the data. So it's not sufficient, for example, to run the periods comparison. So where are you today versus the same period last year? The reporting itself is pretty basic. So you cannot, for example, answer the question, what kind of reports, or name just the top 5 reports consulted by my key account managers in my company. This is something which is impossible, because very often those kind of reports will be on the workspace level and not necessarily on the tenant level. If you don't have the data, you cannot see the trends, the tendencies, and as I mentioned, it's not that easy to just reason out of a single workspace. You don't have the information about the accesses and licenses consumed. And if you don't have this statistics, you cannot find the unused or rarely used objects. But from the BI perspective, the biggest drawback is the fact that you don't have like the proper data warehouse about all of this data. All you have is like the black box, the semantic models in your Power BI tenant, which are created by default, but you don't know from where exactly this data is flowing. And you cannot use it to, for example, add additional source of information into it to make your analytical platform about Power BI or Fabric even better. Okay, so after this introduction, let's move to the architecture of the solution that you can build. So this is, of course, only just an example of one of the possible architectures. Let's start with the data sources. So first, and the most important data source is Power BI REST API. And from Power BI REST API, you can get basically the two categories of information. First one is the user's activities. So you can get all the information about the user's activities. So who entered which report, who downloaded the report, who modified it, etc. And also the metadata of the object. So all the dependencies, so in which workspace a particular semantic model is located, and in which workspace a particular report is located, what kind of semantic model is behind, etc. And also the accesses of the people or the groups to the given Power BI objects. The second data source presented on this screen is simply Graph API. And for Graph API, you can get the information like the licenses on the individual level. So who has the access to Power BI using Pro license or price or a premium per user license. Plus, you have also the information about Entra ID groups and group members. So this is the way to know who exactly has the access to a given Power BI object within your Power BI tenant. And if your Entra ID, or as it used to be called Azure Active Directory, is well maintained, you can also get the information about, for example, the job positions of the people, the departments they are in, the cost centers, the geography, stuff like this. Those are only like the two main data sources. Sometimes you can get this HR information also from the other systems, if this is available, or you can also connect as the next data source Microsoft Forms, for example, with the surveys asking the people about the quality of your Power BI platform. So all of these data sources in the given example are connected using service principal with the correct accesses, and there is Azure Data Factory, which is responsible for the data acquisition and also for the data orchestration. So Azure Data Factory connects using service principal credentials, service principal to the Graph APIs, downloads the data, and later schedules all the treatment. And the treatment is done in small Azure SQL DB, which is divided into 3 zones. You will have like the bronze, silver, and gold. And Azure Data Factory is used to launch SQL procedures, the sort procedures, to flatten your data acquired from API. This would be like the JSON-like structures, and using the SQL stored procedures, you will transform them to the gold schema with the facts and dimensions. Once it's done, using this data model, the Power BI semantic model can be created, and upon the semantic models, you'll find different reports depending on the audience you want to address. Okay, so let's move forward a little bit right now, once we covered this aspect of architecture, and go to the data acquisition. A few information, the key information about REST API. So first of all, the documentation does exist of Power BI REST API. I would say it's not bad, but you need to learn how to read it. At least it was my case. At the beginning, I was a little bit, over reading about all the informations. But later, once I learned how to read and process all the information, the documentation became much more clearer. So you can get basically the list of all the API calls that you should make. You can retrieve the information about the users, workspaces, capacities, reports, semantic models, tenant settings, which is also interesting, the refreshes, the endorsement, which is also interesting because using this information from the endorsement, you can track your data trustworthiness, let's say. But there is one special API call, and this is workspace info get scan result. And I would like just to bring your attention to this one. This is the admin API call, because in Power BI REST APIs, you have 2 categories of the API calls, non-admin and admin. What's the difference? Extremely simple. For the admin, you need to have the higher privileges. So how to obtain these privileges? You create your service principal within Azure. The best practice is to add the service principal to the group, Entra ID group, and this group you are assigning the privileges in Power BI tenant. You need to have administrator privileges to access Power BI tenant admin pane, and in this pane you can just add your group with service principal to the correct options, to the correct settings. Okay, a few words also about the Graph API. So using Graph API, you can download all the information about Entra ID and Entra ID objects. Once again, your service principal needs to have the correct privileges to be able to get all of this information from the API. I know that in some organizations it can be challenging to get such privileges, but if you try really hard, normally it's possible and feasible to get this done. And once again, you are getting the information about the entry ID groups, about the members of these groups, the licenses, and different users' attributes such roles, departments, and so on. And here on the screen also you can see an example of Azure Active Directory flow, which is used to get the information about the memberships of a particular entry ID groups. One thing just to consider as well, be careful what kind of entry ID groups you are getting information from, because normally you need only those who exist within your Power, who are used, not exist, who are used within your Power BI tenant. You don't need every single entry ID group that exists within your organization. Okay. So this is a short examples of the data warehouse. So you can see a few facts. I will show you very briefly how does it look on the report level. The most of the facts are the snapshot facts. So this is something to consider as well, that normally, for example, this fact, the one which is called RLS, role level security, or user report access. This is the snapshot, which is just taking the information of all the security setup as it was at the end of a given day. In the SQL DB, you can just have like the normal bronze, silver, and gold layer. Bronze, silver, gold, also basically those are the schemas. I strongly encourage you as well to have the fourth schema, which is like the configuration, with as much of the metadata of all your data flows as possible. The cost of this database is not that high. As far as I recall, it's under 100 euros per day or per month, all of this infrastructure. And of course, it depends also on the size of your Power BI deployment, but in the most of the cases, the costs are not that high. Okay, so I believe this is the end of this part of the presentation, and I will just show you some Power BI reports right now. Okay, so the Power BI reports, of course, everything here is dummy. I hope that you can see it pretty well. So let's start. So this is the Power BI applications, and you can see to the left that I've grouped the reports into 3 categories. At the beginning, like we have this governance part, we have adoption and finance part, and let's start with this governance report. So first of all, here we have the list of not used reports. So this is the table. There will be lots of tables actually in this example because it's extremely operational, I would say. So here you can see, for example, the information about the reports which are not used at all in the organization. You can define like the period you would like to find your reports in. So here I just put the number 15 last weeks. So I'm looking for the reports that weren't opened or used, or nobody interacted with them in the last 15 weeks. Of course, I can also filter to just, for example, exclude the reports that are deleted. I can check also the workspace type. If I'm going for the personal workspaces or the classical enterprise workspaces, I can limit my just to the workspace or even a given report if I would like to. But what's the most important for me here? If I choose like the correct time parameter, I'm just exporting, most of the cases, I'm exporting this table to Excel, like a classical business user. So I'm exporting this information to Excel, and this report ID is the column of the data, which is the most important to myself, because later I can just take this ID and run a PowerShell script that will just run through my Power BI tenant and put all of these reports which are unused into archival. And here I may share a story from the beginning of this year. So at the beginning of this year, I had like almost 3,000 reports that needed to be put into the archive. So I prepared such a table, and later I ran the script in PowerShell. So everything later was stored into Azure Data Lake storage. And after this archival, I anticipated some Jira tickets. People asking, okay, so I had a report over there, but I cannot find it anymore. Do you know what happened? But you know what? There was absolutely zero Jira tickets. Nobody cared about this unused object. So it just shows you that even if the scale can be pretty big, because I was talking about like 3,000 reports right now, don't be afraid. Mostly if they are not used, you can just put them into archival. The parameter I used was like the 12 months here. So this is something to consider as well, because sometimes you do have the seasonal reports as well. Okay, so let's go through the next one. This is the one that I'm using to control the role level security across different semantic models. So of course, I have many of them here. And why is it useful? Because if I have like 300 of semantic models to manage, it's extremely difficult to go to every single one of them and verify role level security. So this is the reason why you can scan Power BI REST API and retrieve this metadata from the reports and get the information about the role level security setup within your semantic models. Okay, so I will just go here. Something happened. Okay, I can see. So first of all, you have the name of the role. You know to which semantic model it applies. You have the name of the semantic model, the workspace, also the reports that are connected to the semantic model, and so on, the name. And you can also see if the report, the role level security, is based on the entry ID group or not. So here we have the entry ID group, which is named Power BI all, and here is unassigned. So it does mean that this role in this semantic model does not use any entry ID group. It just constructed based on the user display name that you can find here. So what can I do right now? I can contact the person responsible for the particular semantic model. Okay, just let's pretend it's not the personal workspace, and ask this person, okay, you know what, maybe you should just do it a little bit better and build this role level security around the proper entry ID group. What's more, here I can see the table and the DAX expression related to the roles. So as you can see, those are empty. So most probably they shouldn't even be existing. But let's find the next one. Okay, so the next one, I can see that the next role level security is based on the fact table. It's normally it's not the best practice. So once again, I can reach out to the developer of the semantic model and ask him to or her to make some amendments to maybe do the security role a little bit better. This security role looks correct. And maybe this one, it can be done a little bit better. It's not terrible, but yeah. So it allows you to control the quality of the role level securities across all of your semantic models. Yeah, this is the one that I like, because this is the place in which you can basically check up all of the accesses to the given objects in your Power BI tenant. So of course you can choose whatever object you wish or the user that you wish. Also, this is the snapshot. So most probably will be interesting in the accesses as they are per today. But as we can have many different snapshots. In case of the security audit, you can get back, for example, 2 months ago and check how the security looked like 2 months ago and answer some audit questions. Once again, you can see if the access is provided on the user level or if it's provided on the Entra ID group level. So here we have the user level accesses. And this line is already the access which is provided on the Power BI admin Entra ID group. We have the user display names, the mails, and the object types. So here we have all of the objects in a Power BI tenant that you can use to attribute the accesses, and also the information, of course, of the name of the object, but also of the type of the access. So here we can see that someone has the build permissions on these semantic models. This report was shared through link. This person can modify the semantic models, and here you have also the short description. Basically, if this person can modify, it does mean that the role level security does not apply to this particular user. So how can you use it? First of all, it's a tool that you can verify all the accesses. And the second thing, you can just start and plan, for example, to make your governance, administration, and the security processes a little bit better. And you can just, once again, export it to Excel, play with it, and decide how, for example, your entry ID groups should look like to make your access policy better. Here I have something also which I use to track the self-service reports. As you can see, this is mostly focused, at least this variation of this report is focused on this private workspaces, the personal workspaces. But if you have neatly separated like the workspaces in your organization, which are like the standard enterprise BI and also the self-service, managed self-service workspaces, for example, using the prefixes or suffixes, you can create a very similar report which will be focalized, for example, on your managed self-service reports. And using this information, you can define how many users at the minimum a given report should have in the last, it's here 15 weeks, but you can have like half a year of any given parameter, and you will see the list of the reports. If, for example, you choose the parameter that you would like to note all the reports that have more than 100 users that are self-service, you'll have the list over there. So this list later just can go to your backlog, and you can consider the migration of all of these reports to your enterprise zone. Once again, here we are coming to the page that gives you the suggested business owners. The suggested business owners. So we are coming back to the situation from the beginning of my session, when I was telling you a story that some of the data source, the SAP instance, needed to be migrated. And the problem, of course, is who is responsible for the decision of what to do with a particular report. So using the information about the most active users, like here, for example, this one has 11 views, this one as well, but this is a dummy data. Most probably this person can be asked to become a business owner. If this person is reluctant, you can always threaten a little bit and tell him or her that if you are not ready to become business owner, this report will be deleted. If the reports are important for the people, most probably they will agree to become the owners, or they will indicate another person, like the boss or someone else, who should be the owner. Once again, this is one of the tables which is frequently exported to Excel because you have the emails, and using these emails and the information about the last activity date and the number, you can just also prepare like the standard email formula and send all the needed reports, all the needed emails to the correct people, asking them to become the business owner and solve the issue, for example, in the planning of migration or consolidation of the reports or anything like this. Next table, which I like a lot, this is the information about the lineage of all your objects in your Power BI tenant. So starting with the application name, going to the workspace dedicated for the reports, going to the report name, workspace dedicated to the semantic model upon which a given report is based, the semantic model name, the data flow if you use it, and the data flow workspace and the data flow name. Finally, to the gateway, if it does exist, like here, for example, and the external sources. So using this table, basically you have all the information about the main dependencies of the objects within your Power BI tenant. Of course, you can use this filter pane as well to narrow down to the particular, let's say, a semantic model if you just want to see a semantic model and all of this information about it, all of these dependencies. So quite useful, and I think that the table, it's not that bad as the visualization in the case of something complex as Power BI lineage. So what I didn't have enough time, unfortunately, to prepare the information about the tenant settings, and I didn't have the time to prepare the information, also the demo about refresh semantic models and data flows, but maybe one day in the next presentation, all of this will be already ready. Okay, so let's go right now to the adoption pane. So we'll start with this overview, and this overview is like dedicated for, let's say, for more strategical perspective. And I just want to bring your attention to the few key information. So first of all, tracking your adoption rates on the across all your tenants. So you can see your users activity here. So how many active users do you have in the selected period, and how many users are the users with accesses, and the percentage of this number. So if you hear this example, we have like 5K active users and 6K users with the accesses. So I would say that it's pretty decent, like the result. But in some organizations, you may have like only 1,000 users who are active and many different accesses. So this gives you the information, where are you on your adoption journey, and also gives you a benchmark, where should you go. The quickest way to increase, of course, the percentage of active users is just to retrieve the accesses from the people, but doesn't mean that it is the smartest one. So this is something that I like to use in this let's say long time horizon to check up where I am on my adoption journey. Something relatively similar is also this the usage of the certified objects. So if you have already an organization like the policy, like the governance policy, and the certification process, that some kind of the criteria must be met in order to certify the given Power BI report or semantic models, this is something that you can track. And the certification process can be used as a measure, as a tool that can be measured to check upon your data trustworthiness. So let's say that you are starting today, you are barely having like a few certified objects, but your goal may be to have in few years, in few years from now, maybe you will go to the number of 60% or 70% of the usage of the certified objects. The same rule applies to the workspace usage. So here you have the information about all the actions in the enterprise zone workspaces and also across all the workspaces. And these all workspaces can also include like the personal workspaces, or if in your data warehouse you define them correctly, it may also apply to your self-service, the governed self-service part. And like this, you can see how many actions you have in your enterprise zone, and what is the percentage of these actions in this enterprise zone versus the total actions that are executed by the users. You can also apply like the special AI to identify Power BI champions, so that people who are more advanced than the others. The fanciest AI that I like to use is the series of ifs. And in this series of ifs, you can just check up the particular actions of Power BI users. The actions, for example, like the bookmarks or the comments, or connects with Excel, analyze in Excel actually. So these people, they have a little bit more advanced skills than the others, and you can flag them as Power BI champions. And you can also track how many of them you have in your organization. The last thing that I mentioned also was the potential data source, and I prepared for you in this demo, is the NPS score, so Net Performance Score. If you construct like the proper Microsoft Forms phase and you have the process in place, the process that asks your Power BI users about their opinion, how do they feel with Power BI platform and service, how do they feel about the services delivered by your data or BI department, you can integrate also this information in your reporting and create this global overview. So those were like the most key aspects for myself. Of course, you can track all of this information in the time, and you have some information about the departments. So in this way, you are able to define like the most advanced departments and all the departments who have like lots of access and does not use Power BI in the manner you wish them to use. So this may be an opportunity to grow your Power BI adoption bigger. So once we've covered the strategical aspect, this is something more close to the ground. So this is this operational information. On this report, if you are building something like this, I would advise also to apply role-level security. Role-level security, and you can give the access to your business owners, business sponsors, for example, from the marketing department, pricing, controlling department, you name it, and everyone can see their own workspaces, semantic models, and reports that they are responsible for, that they are paying for, that they are maintaining, that they are making evolve. So imagining that let's imagine that we are this accounting representative. So if I have the access only to my accounting information, so I can go down and I can see all the semantic models, or I can go even more down and I can see the most used reports and basically all the usage of the reports. Once again, here we don't have many activities because this is like the dummy data, but I have this APAC report, which is the most used one, and I can see who are my users, what kind, who they are, what users are the most frequent ones, and what users they don't use this report at all. Here, everyone with the access apparently is using this report. I have also information about the activities. So the activities like who is viewing report, exporting, renaming, and so on. This is just the randomly picked up activities, but in real life you will have like next to 140 different activities to check up on, and you can very easily see, for example, who is connecting to the to which data model, to which semantic model, for example, with Excel. And of course, you can track all of these changes in time. And last but not least, you can have information also about the financial aspects of your Power BI deployment. So here, this report that I prepared for you is mostly about the individual licenses consumption. So here you can just put the price that your enterprise has negotiated with your CSP or in your EA with Microsoft. This is the premium per user price. This is the pro price. And once it's done, here I selected the accounting department. So in this accounting department, you can simply see how many licenses and what type of licenses do you have, and what is the monthly estimated cost. So this is one of the ways. Of course, you can find similar info also, for example, in Microsoft 365 pane, but you can also use this kind of report if you build it by yourself for the showback or chargeback purposes. You have the clear information about the active licenses and the inactive licenses. So here I can see that Eddie Nyssen, he's not an active Power BI user, So his license can be revoked, and I can reassign his access to someone else who will maybe use Power BI a little bit more than Eddie. How to identify inactive users totally depends on your policy. I recommend to identify a person inactive if there was no activity in the last 6 months. But this is just a parameter, and you can make your own decision. Okay. I believe that this is the end of Power BI demo. And the examples. So just a few cases right now to share with you. So you can clean up the reports. Here's this example that I mentioned already, that almost 3,000 reports that are unused. It gets a little bit more tricky with the reports that are rarely used, because sometimes you have this report which is like already orphaned, and the person just by accident opens this report and sees that there is nothing there that would be out of interest, so it's leaving the report, but you still have this view registered. So what to do with them? Basically the same thing. You can just list them. You can firstly contact all the presumed business owners what should be done with these reports. Once you obtain the decision and the report is not used and was opened by an accident, you can put it into the archival. Another case that I also like to use Power BI REST API is to do the proper audit of the Power BI estate or Fabric estate right now, just to know exactly by the numbers how everything looks like and how it's used, how it's set up. It's very neat and visible. Driving adoption of data products. So this is the reason why I mentioned to you that it's nice to give the access to this report, especially this tactical adoption overview to the business people, to the business sponsors or the business owners of the particular zones of reporting. Having this information, the data, they can better work with you on increasing adoption rates of your Power BI deployment, proposing the trainings to the given people, and also developing the reports in a given way, because maybe some reports are mostly used because either they are successful and really responding to the business needs, or maybe they were designed some way that make them better than the others. And as very often, as I mentioned also, it can be used in the migration cases if you want just to, for example, have the clear overview of your most critical data assets, and you are preparing to migrate, for example, from Synapse to Fabric or from Snowflake to Databricks or anything like this, and knowing the consumptions of your reports, you will know also what kind of the data assets are the most important. Just maybe last thing. As I look at this information, the Pareto rule is clearly visible, and almost in any single organization you will find this top 20% of the reports which are responsible for the 80% of the traffic. Sometimes it's 78%, sometimes it will be like 82%, but this is also like the Gaussian statistic, and they are just converging into 80%, whatever the organization is. So yeah, that's all. I hope that it was something interesting to you, and yeah, you can rate my session as well, but I see that also the organizers, they have the proper tool to rating the sessions, so you can use the official tool. It will be better, I believe. So thank you very much for your attention, and I think that in a few minutes we'll have another nice session.
Great. Yes, thank you very much for that, Michal. And yeah, it was a very informative session. You got a great set of Power BI reports there that give you a lot of information about a lot of the internals and how Power BI works. I'm sure that they're really, really useful in organizations that you're deploying them to. It's a lot of insight, actually, more than I expected you could get on Power BI. So yeah, really, really good work there. Yeah, it's great that you've got your contact details there. I'm sure a lot of people are going to want to follow that up and see how to do some of the things that you've got in there. Wonderful. Next up, we have got Andrew Madsen for the last session of our delivery. Let's put Andrew onto the stage as well. And that way we've got the three of us here saying hello and goodbye as we move into the last session, which starts in a couple of minutes. So, Andrew, how are you doing? Are you ready for the last session? The going out with a bang, as we say, basically, as the conference has been going all day?
Yeah, it's been really great. I've been listening into a lot of the talks, and there's been a lot of things that I learned. I actually particularly liked Michael's session. I learned a lot about Power BI.
Yeah, it's brilliant, wasn't it? I'm happy to hear it. Yeah, I think it's been pretty useful, all the way down from all the sessions that I've seen so far, or just managing the room. It's been great. And even, I mean, as an MVP, it's unusual, to find stuff. It's like, wow, yeah, I didn't think about that. And so it's been getting a lot of that sort of aha moments today as I've been watching these different sessions. So with that aside, I will hand over to you and let you introduce yourself and take over the stage.
Wonderful. Thank you.
No worries.
Right. Hello, everyone. Good morning, good afternoon. I'm personally in Vancouver, British Columbia today, just presented at another conference. And I was thrilled to speak at DataBash. My presentation today is about table formats, especially in the data lakehouse. So the who, what, and why of data lakehouse table formats. And this has been coming up a lot. So I think there will be some good questions and go through some of the intricacies between the different options that you have. And just a little bit of my background. Feel free to connect with me on LinkedIn. That's where I'm most active and respond to messages. Professionally, right now I'm an evangelist at Dremio, a data lakehouse company. And I focus specifically on data analytics and on artificial intelligence. And travel around the world speaking with external audiences, developers about how data lakehouses can enable unified analytics, semantic layers, AI. Before that, in my previous life, I was a leader of lots of different AI and analytics programs in higher education and financial services. I was a VP of analytics at JP Morgan, Senior Director of Analytics and AI at Arizona State University, and a bunch of other places. On the side, I teach graduate programs in data analytics and data science. It's the joy of and highlight of my week. I engage with a ton of students. At any moment, I have between 50 and 150 students. So they keep me on my toes and ask me good questions. So these presentations are helpful for me so that I can answer their questions. And just a quick overview of what is Dremio. This is definitely not a sales presentation, but I get a lot of questions about, like, what is Dremio? Before you talk about table formats, what the heck is Dremio? Dremio is a query engine that works on data lakehouses. It also does lakehouse management. So it works with one of the table formats, Apache Iceberg particularly, but it also can work with, for instance, like Delta Lake. And a bunch of people use Dremio. As a freebie for you, we did write the definitive guide to Apache Iceberg with O'Reilly. And so if you'd like a free copy of that, scan the QR code and get a digital copy. If you buy it on Amazon, it's $60. So I recommend don't buy it. Just get a free copy of it, and we're happy to provide that. We just signed another contract with O'Reilly. We'll have another exciting book coming out probably next year. The development cycle on that is about a year long, but a related topic and incredibly applicable. But yeah, please get a free copy of the definitive guide to Apache Iceberg. It takes you all the way from the beginning, like what is, some of the concepts we'll touch on today. What is a data lake? What's a table format? All the way up to how do you use Spark within Iceberg. All right, well, let's kick off. So talking about table formats for the data lakehouse, we got to start at the very beginning. What is a data lake? So going back to the very beginning, we've got the database, the data warehouse, And both of them have storage, table formats, catalogs, processing, and then databases are typically row-based, and data warehouses are typically columnar. And these have been the backbone of a lot of our storage systems in almost every industry for years and years. But they really only deal with structured data. And so there are some limitations. While there are a lot of efficiencies in databases, there's definitely some limitations there. You can't scale compute and storage separately. You need to increase them at the same time. Data warehouses, which typically hold the gold layer or application layer of our data, all the data sets that analysts and data science are pulling in order to feed their models or their dashboards, go through typically the data warehouse. But now we're making copies along the way. It can get expensive. Even though they're in the cloud, compute can be expensive and potentially inefficient. So we end up making extracts and things. So there's definitely trade-offs. So then we started with the data lake, and the data lake really answered the question, well, we don't just have structured data. We've got all this semi-structured and unstructured data. How are we going to store that? And Hadoop was really kind of the first object storage that came out on the market. And Hadoop was a big answer for everyone. So it really begged the question, like, wouldn't it be nice just to have a copy of data that anyone could access, where multiple tools could just work out of the same data instead of having it spread all over the place, different databases, different warehouses, but have it efficiently? So that's really when we started moving towards the data lake. And so the idea is, how about we just store the data as files, and then we can use different tools to work with those files. And so we came out with Hadoop, which was basically a system to take a bunch of computers and treat them as one large storage layer with a whole ecosystem of tools. So there was Hive, Pig, Impala, lots of things. A lot of it's still around. Hadoop grew like crazy. There's a lot of companies modernizing off of Hadoop, but Hadoop for a long time was really the standard of how you were going to work with object storage. And so that's really the storage structure. So essentially, you store the data as a bunch of Parquet files with structured analytical data sets. You could store images, basically anything you can put inside of Hadoop. But the problem was that maybe, for instance, these Parquet files really make up a table. Maybe instead of just seeing them as individual files, they're really a table. But there's no way to automatically know that those individual files inside of Hadoop are a table. So the Hadoop system, or an object storage system like S3 or ADLS, they don't magically know that these files are a table or that these files are another table. So the management of the object storage is a big challenge. So what the system knows, it just knows that these files are stored and that they're there and where they are. And so this really limited the ability of tools to interact with the storage layer because they don't necessarily have the metadata understanding, the context of the data on the storage layer in order to access it efficiently and intelligently. If you provided access to this Hadoop storage layer to a data analyst, there's really not much they can do with it. They're not able to work with the unstructured text file or semi-structured text files, the Parquet files. They needed that extra ETL process of moving it into a warehouse. So while storage could potentially be cheap, it wasn't useful. Some data scientists were able to get in and work directly on the object storage layer, But for the most part, most business cases and application level cases were not able to use Hadoop directly. There had to be another level. And so that limitation caused a lot of companies to start investigating, like, what else can we do to maybe make more use of our storage level, of this object storage. And so the data lake paradigm was often used for ad hoc querying, but it was so limited. And so the dream of having one copy of the data that could work with multiple tools was still out there. This is where we started moving towards the data lakehouse. So what the heck's a data lakehouse? And so it's an architectural pattern. And so your storage is still in a data lake, and the architectural pattern on top of it makes it a data lakehouse. And there's a few things that go into that. It provides structure, performance, flexibility, scalability, a unified platform, and cost effectiveness. And let's look at how it can do that. So when we look at the data lake, let's break it down into different components. What do we have? We have the storage layer. We have compute and processing. So it's deconstructed, right? On the data lake, storage is separate from compute. And that's one of the main things that makes it easier, is that you can swap out your different engines and your storage. There's lots of tools like AWS Athena, Dremio, which can help with that, Trino. But it's not quite, it doesn't have all those benefits that a data warehouse had. Remember when we looked at a database versus a data warehouse? Data warehouse, while can be expensive, it really was so easy to use. I mean, data warehouses are amazing for data analytics and getting that gold level where you can just plug a bunch of tools into it. But again, expensive. We've made a bunch of copies of the data along the way in order to get that ETL into that state. So if we could just have the data accessible in our data lake, so then we get the cost effectiveness, but also the ability to have application level and quality data there where a lot of tools could access it. That's the dream. And that's what the data lakehouse is trying to accomplish. And so that's really what makes it the data lake, is those two components. So data lakehouse with this architectural pattern comes in. They have the storage and the compute, but add in a table format, which we'll talk about, and then a catalog to interact with the table format. So a way to identify things as tables and somehow being able to collect and understand that the tables exist. That's what was missing from a data lake in order to make it accessible and useful for downstream consumers. So when we add that in there, you now have all the functionality of a warehouse, and it's in this flexible, agile, decoupled modular structure. It's deconstructed, so you really can swap out storage, table format, catalog, processing, and query engine. And so this architectural pattern is what a data lakehouse is, with the end goal of being able to provide that data warehouse capability directly on top of the data lake. Yeah, happy to see that my title is it's trippy there, so I apologize for that. So if you're looking at it in practical terms, you have these data sources. You ingest them in to your data lake. And because you're using a table format, which we'll go over, which provides all the metadata for all those data files. Remember, we looked at Hadoop as tons of Parquet files and images and text files. So we're ingesting those type of files into our data lake. And we've got the metadata, we've got a catalog, which is going to track for us which tables exist, which files roll up to which tables. And we can use tools like Dremio, Snowflake, Apache Flink, Apache Spark, Upsolver, they can all begin working with that system. They can all begin accessing through that table format the underlying data in those tables. So the table format is really the key to enabling us to have one copy of the data on the data lake and treat it as an application layer. So the data lakehouse architecture is particularly suited for AI workloads and unified analytics. But I'm seeing it a lot in AI right now because, I mean, traditional AI, of course, with deep learning, and AI is not just the model, right? We talk about in generative AI a lot, you know, how many billions of parameters was this foundational model tuned on, trained on, and then tuned. But it also needs to be the quality of the data. Companies that are building their own generative AI models have to have quality data underneath in order to build a model that's going to understand the context of their business. If they have a RAG model or a graph RAG model, which can provide a little more of that context, the underlying data has to be good. It doesn't magically know. It doesn't like an AI model doesn't magically fix poor data quality. And also training these models, the best is if you can have a 360 view of your business. Well, what does that require? It requires integrating data from all kinds of different sources: SQL Server, ADLS, MongoDB, Cassandra, ERP systems like SAP, Salesforce data. Well, how do you get that in there? Let's get it in the data lake and then use a table format to create a unified layer. And then the AI training can read from there. So even if you need to go further downstream and move it into Elasticsearch or into a vector DB like Pinecone, at least you've got a unified layer where everything is in one spot, rather than trying to ingest directly into the vector DB. You're now getting it all into the data lake, getting it unified and organized so that the AI model can then do its work. Not only that, moving into the data lake, the process there, which we'll talk a little bit about, is incredibly powerful and fast, and there's different table formats which you can choose depending on your priorities. But companies like Uber and Facebook have already adopted lakehouse architecture, and they have reported significant improvements to their capabilities. So we talked about how the table format is really the key to enabling the data lake to have these abilities similar to a data warehouse. And there's really three main options for a table format. And let's look at those. So as we dive a little bit deeper, to appreciate this, let's talk a bit about the fundamental unit when we talk about the data lake, which is the file, which we alluded to earlier. When it comes to analytics, the standard way to store structured data is in a Apache Parquet file. And the Apache Parquet file improves upon the formats of CSV and JSON. Parquet files are awesome. And when you use something like a CSV or JSON, there's a couple different problems. One, they're text files, which means you're using text encoding, which takes up more space for the same content. Two, especially with CSV files, they're inherently row-based. So basically, if you want to do something like get an aggregate analysis off your data, like, hey, what's the total of all my sales? You would need to read every row when all you really want is the total column. So you want to be able to add up the total of each sale instead of reading every row. So they can be pretty inefficient. And as data grows, which is growing, it's growing incredibly. I saw a Gartner chart 3 days ago about the potential amount of data that they're projecting that's being stored, and it's exponentially higher than last year. So just hundreds of exabytes of data is being stored. And if we're trying to do analytics, especially aggregate analytics on top of that, which, let's be honest, we typically are, if we're doing metrics, KPIs, a lot of that's just aggregated data. We can't have row level, like we just can't. We can't read an entire table in order to provide an aggregate number. That's what leads to insanely slow analytics, or having to do a large extract to launch it into Tableau or Power BI. And now if you've got a extract feeding your dashboards, it's no longer live, and you're storing it twice again. So there's lots of challenges there with having the row-based storage. So a Parquet file helps fix these problems. One, it's binary format, so it can store that same information from that CSV file in a much smaller space that's specifically engineered for the structure and purposes of analytics. Two, it structures the data as columns, so as a columnar format. See that 10 times twice, columnar? I say it a lot, and sometimes I still have problems with it. So instead of having groups of rows, you have groups of columns. And so that column for total sales in our example would essentially be a separate data structure that I could just pull individually. I wouldn't need to read all the rest of the rows in that file in order to generate that aggregate number. But you may not necessarily need that particular column for every record. So it helps you really prune down and have efficient queries if you're using Apache Parquet. So to make it more efficient to scan, you have groups of rows, and what they do is they take those columns, groups of columns, and break them into chunks of rows. So each row group is made up of the columns for those rows. And the beauty of this is that each row group has a footer with metadata about that row group. And metadata is really the key. So imagine saying, hey, this row group contains all users between the age of 20 and 30, and this row group has users between 31 and 40. And this allows the query engines like Dremio, Trino to do what's called predicate pushdown. So instead of scanning the whole file, it can say, okay, based on the data in the footer, do I need to scan this row group at all? Or I can skip these row groups based on the metadata and scan more efficiently. Because it's columnar, I can only grab the columns that I need. So overall, it allows for much faster data loading and data processing because it can load the data faster. Because I only load the data that I need from that entire file instead of loading the entire file. Then I can process the data very quickly. And because it's columnar, it can be quickly converted into memory formats like Apache Arrow, open source, which is incredibly fast for processing in memory. And so if we've got something bigger than that, if we've got data sets that are bigger than just a single Parquet file, when the Parquet file is really good, while the Parquet file is really good at doing analytics, but what happens is your data sets grow, and we all experience that. And so you might have a situation when your user's table might be, in this case, 3 Parquet files, and each Parquet file has different row groups. In this case, I want to describe to whatever tool I'm using that these 3 files really are a single table. They roll up into a single table, and that's how I want to treat them. If I do that manually, it leads to all sorts of potential problems. So what happens when one of my analysts accidentally says that only user 1 and user 2 Parquet files as a table, but they forget to include user 3? You will have inconsistent data sets. Analytics won't be right. There isn't an absolute way of defining that in the table. So when you have multiple Parquet files that make up one data set, you really don't want the users to define these rules around the data set, because the files, they don't understand one another. They need something else to help organize that. They're not aware of one another. Each one's a unique file containing a piece of data, and we need some sort of glue to treat them as a bundle. And so that's the challenge of, we have multiple files. They really are a data set. There's nothing inherent that's making them aware of each other. There's nothing inherent that makes it very obvious that these should go together. And so manual manipulation of these is incredibly inconsistent. And this is where the table format comes in. So the original table format was called Hive, and Hive metastores are still around. Before, there were things like Apache Iceberg and Delta Lake and Apache Hudi, which we'll go more over in a little bit. There was Hive. And so just a little history about Hive. Hive was created because you had all this data in Hadoop. Remember our original object store? And you had to use a tool called MapReduce to run analytics on it. Shout out to all our MapReduce folks, if you remember that. That's when I was entering analytics, is when, probably at the peak of Hadoop and Hive and MapReduce and Pig and all these tools. When I first got into data, I was like, I have to learn Pig. Like, what is going on? I don't even understand this. And then I got into it, and it started to make more sense. But it was very manual and burdensome, to be honest. And MapReduce required you to use a framework in Java to write an analytics job. So you'd have to write this Java code that would define the data set and say, hey, here's the files that equal this data set. And then these are the operations I want to do on it. And this is all written in Java. So most, analysts, most data engineers, they don't write Java, but you really had to if you were a data engineer, if you were working with Hive. So even if you know Java, it really isn't the easiest way to write a basic analytics query. So people wanted to do the things the way they're used to. That's SQL. SQL, love it or hate it, which I personally love it, is the common language of data. We use Python. Yes, we do use JavaScript and some Java out there, but the vast majority of data operations are going to be in SQL. So being able to use that common language of SQL would make things easier for everyone. Data analysts know SQL, data scientists know SQL, data engineers clearly know SQL. So people really wanted to use SQL in order to do some of these operations. Hive was created to make this process easier. So if you would say, hey, give us the SQL and we'll translate it into a MapReduce job. And that's really how Hive worked. So Hive was taking the SQL query, translating it into MapReduce. Other formats and frameworks did come along later. There was Tez, which could supplant that. But the idea was that Hive would translate to something. Initially, it was translating into MapReduce. But to do SQL, you need to know where the table is. There has to be a way to understand it. And just based on the name of the table, what's inside the table? That's the key. You need to be able to say, here's the table name, and something needs to understand what files roll up into that table. So the paradigm Hive used was a folder. And there's a folder called user. And the files in that folder are the user table in this example. And so that did work. It helped us get organized. This became the way that we could recognize what's in the table. It's whatever is in the file, whatever's in the file, the data inside the file made up the table. And so this allowed us to write SQL, and it made asking basic questions like a lot easier. Could you imagine telling your data analysts today that they need to write Java in order to get their analytical query done? It just wasn't happening. It wouldn't happen today. And so the problem is that the work that the query engine has to do in this Hive structure is that the way we define the table is so simple, but we don't know how many files are inside that folder. So the user folder. I think I misspoke earlier. I was saying the files in the files. The files in the folder. And so there's not a lot of info about, hey, what's inside here, approximately what's the size, all of those things. So we know that the folder's a table. Everything in there rolls up to a table. But now the engine has to do file listing operations. Whatever you're using to query it has to do file listing operations. It has to bring up a list of every file in the table and then individually read each one. And then every time you open and close a file, that's work the computer has to do. And the more work it's doing, the longer it takes to execute a query. It might not need to read all those files, but it's going to if they're in that folder. So you might have to read 1,000 files when you really only needed 30 of them to really get the info from the query that you're trying to do. So it wasn't ideal, but it was better than what we had before. And it was, it was also really hard to do granular updates because generally you would track the tables through something called the Hive Metastore, and the Hive Metastore would track, hey, this folder is the user's table, but it would also track partitions. And partitions, in this case, were treated like little subtables inside that table. And so it would say, hey, here's this user's folder, and these folders are the partitions within that table, but it wouldn't track the individual files. So it stopped at the partition level. And if you ever wanted to update just one record, like CDC, you would have to update the entire partition folder. So that could be a much more expensive and time-consuming operation. You had a very limited table evolution. If I wanted to add a column, I would potentially have to rewrite every data file and rewrite the whole table. If I wanted to change anything about the table works, how it's partitioned, the schema, and so on, it would really require rebuilding it. And all these challenges made it difficult to do the same type of work that you would do inside a data warehouse. And so the data lake was still not to the point where you could use it to the same extent as the data warehouse because of all these challenges that we just talked about with Hadoop and Hive. So there's a modern approach to table formats, and this is what it's trying to solve. Companies, Netflix, Facebook, they're dealing with all of these challenges. They're dealing with giant amounts of data, and they wanted to be able to access it efficiently on their data lake. They wanted to be able to do analytics on the data lake. And with Hadoop, and Hive, it didn't make it easy enough to make the data lake your source for analytics. So this new generation of table formats began to arise. They work more like this. So essentially, you have a group of files. We're still talking about the groups of files that make up a table. And instead of saying, hey, the table is the files in a folder, the way Hadoop did, it says more, hey, we're going to have this metadata off to the side. And the metadata will tell you which files are in a table. And it doesn't matter where they're physically located. The metadata tells you, hey, users1.parquet, user2.parquet, even if there's 300 files in the folder that there are or aren't part of the table. So only the files defined in the metadata will make up that part of the table. It makes it super efficient. So what's the schema of the table? It's what the metadata says. Even if the files are missing a column or have an additional column, we can apply the schema defined in the metadata so that the query engine creates the output after reading the files. It's always going to conform to the schema, which is incredibly helpful. It also makes it possible to change the schema. The same thing applies to partitioning. And we talked about how in Hadoop and Hive that you're doing almost subfolders when you're creating partitioning. And so when we do partitioning in a modern table format, it's really saying, hey, this file and that file are partitioned in this certain way. And we're aware of it because the metadata is allowing us all sorts of flexibility with how the data is managed. By having all this metadata, I can do a lot of the figuring out that I'd have to do by opening each file individually. Don't have to do that. We can do it by reading the metadata. And so I can have a handful of files and get a lot of work done. An analogy I like to use when it comes to the metadata is to imagine a kitchen. If I go to my kitchen, there's a bunch of drawers and cabinets. And if I were to look for one thing, like one fork, and I don't know where the forks are, I might have to open every cupboard, every drawer to try to find it. And that's going to take a while. But if I had a clipboard with a list of every item in the kitchen and their location, I could save myself a ton of time by just grabbing the clipboard and saying, hey, where's the forks? Oh, it's here. Let me go straight there and grab the fork. And that's what the metadata is. It's like an index, a separate structure that tells you about the thing that you want to look for so that it makes it easier and faster to find it. And so the metadata-centered approach defines much more than what we just had with the folder in the Hadoop paradigm. But what the individual files that the data's in, you're able to fix a lot of the associated problems of the Hive format, making it easier. So for instance, features will include ACID transactions and the different table formats we're going to talk about. So ensuring data consistency and reliability, which again, crucial for AI and analytics. Schema evolution, allowing changes to the data without breaking queries. This flexibility is essential for AI analytics when the data requirements are often changing. Hidden partitioning, optimizing data organization for faster queries without complicating the data model. And this can significantly speed up analytics, make it very fast if you do efficient and effective partitioning. Sometimes I'll meet with companies and their queries are running slow, and we'll look at how it's partitioned, and that's the problem. So there's a balance to it of having just enough partitions, but not too many partitions. And then another benefit is time travel and rollback, allowing you access to historical versions of the data, which is really crucial for reproducibility. So these are the benefits that modern table formats are bringing to the table. So Apache Iceberg is the first table format that we'll look at. Apache Iceberg comes from Netflix. The creators of Apache Iceberg created it at Netflix and then open sourced it. And so Apache Iceberg, how that works. So the query engine, if you're going to run a query through Apache Iceberg, here's how this would work. The query engine is going to run down and consult the catalog. The catalog is going to, remember we talked about the clipboard with the metadata. The metadata file has information on the different manifest lists, and the manifest lists have information on the different manifests, and then the manifests ultimately know the files in the storage. And so having this cascading query path allows for the query planning to really prune off a lot of things that aren't needed. You don't have to read rows and files and columns that aren't required to fulfill the query. And so as you go down, the metadata file is read for partitioning, schema, location of the manifest list for the desired snapshot. Manifest list is used to do partition pruning and identify the manifest with relevant files. And then the manifest is used to do the min-max filter, prune individual files, and the remaining files are scanned for the query. And so the query planning, well, it may even take just a couple seconds longer. The actual total query execution is insanely fast with Apache Iceberg. In the Apache Iceberg architecture, the metadata files are stored as JSON. Just like we talked about, the metadata files are the high-level definitional table data really helps determine what is where should the query begin to look. The manifest lists are Avro, the file that lists all the manifests, and then the manifests themselves, again, Avro, files that contain the lists of the files with their table level statistics. So Apache Iceberg is growing in popularity quite a bit. We recently saw Databricks purchasing Tabular a few months ago, and Tabular was the company founded by the creators of Apache Iceberg. And so Databricks, who created Delta Lake, which we'll talk about in just a second, is also now working with Apache Iceberg. And so there was a while where companies were really wanting the benefits of having this open table format and being able to do analytics and AI directly on the data lake. But because there's multiple table formats, Iceberg and Delta Lake, for instance, there's Hudi, but we'll talk about that. They didn't know which to choose. They didn't want to make the wrong decision. It's kind of like when in the video era, when there were two main DVD formats and people didn't want to buy the wrong DVD player because they didn't want it to become obsolete. They didn't want to buy Blu-ray if Blu-ray wasn't going to be around for a long time. So that was the mindset and challenge for a lot of companies for a few years. But with the acquisition of Tabular by Databricks, a lot of companies are much more comfortable moving into Apache Iceberg. It's open. There's a million. There's not actually a million, so I guess I shouldn't say that. There's a ton of different contributors from companies like Apple, Amazon, Dremio, lots of Apache Iceberg contributors, all working to make this the table format that's most efficient and effective for everyone. And that's the beauty of open source. And so the catalog is really going to be the source. When you're reading Iceberg tables, they need to roll up into a catalog, and the catalog is what you connect the query engine to. So the catalog is the key. And like we talked about earlier, it's modular. You can really swap in one Iceberg catalog for another Iceberg catalog, totally fine. You can swap out Dremio for another query engine. It really makes it very easy to just swap in and out, which is a huge benefit. And so another open table format is Apache Hudi, which comes from Uber. So if you think about Uber, with the type of data that they have a ton of streaming data. Their data is moving super fast at a very high quantity. And that's where Apache Hudi comes in. So Apache Hudi is really great at being able to identify streaming data and transactional data. And so Apache Hudi is used by companies where high quantities of streaming data need to be accessible and queried quickly. So Apache Hudi really thrives in that environment. And then the way Hudi is formatted, let's say we have our sales folder, and we've got our data files inside of our sales folder. Then we've got our log files associated with each data file. And so Hudi really relies on the transaction log, and it's going to be able to help us query our transactional data much more quickly. And so Hudi is really the table format for real-time, quick processing and querying of transactional data. And the way it does this is by reading those logs. So if we're looking at the timeline, it's got all these commits and compaction, rollback, but that's what it's reading. And so Hootie, when you query it, is really looking at those log files in order to get to the data that you want quickly. And so the way that it's structured, you've got partition folders, base data files, and log files that all describe the changes to the base files. And so this is really what helps it move quickly by focusing on those transactional logs. I'm looking at time. I want to make sure that we have enough time to get through the other table formats as well. So a Hootie query would look like this. So it would set a timestamp to query the table it's based on. Based on the timestamp, determine which files are part of that table and which logs should be should the changes applied from. Use file stats, column state, and Bloom filters in the metadata folder to prune the files. So that pruning's key. Pruning's really what makes things go faster. And then scan the files that weren't pruned to execute the query. So those log files are key and what sets Hootie apart. We also have Delta Lake, which comes from Databricks. So the way that Delta Lake is structured, if we're looking at the same thing, we've got our sales table, and it's made up of all these data files. Delta is really great with working with Spark. And the way they do this is that they have their what they call their checkpoints on their logs. And so Delta is able to use the checkpoints in order to query efficiently. And so the checkpoints really help organize the logs, and the logs help you understand which files should or shouldn't be included in the query. And so Delta Lake is another fantastic table format created by Databricks. And if you exclusively use Databricks, then you likely already use Delta Lake. Delta Lake isn't necessarily super interoperable with other tools, but if you're only using Databricks, then that's not a concern for you. And the Delta architecture, as we just talked about, right? We've got the overall file, the table. It's going to have that checkpoint file, which helps group them, which goes down to the logs, and then the logs help us understand which underlying data needs to be queried. And so similar to with Hootie, this is how a query would be performed. You build the current file list based on the existing checkpoints. Once the checkpoints are exhausted, continue with the log files, use the stats collected to prune the file list, and then scan the files that were not pruned to execute the query. So you're seeing a pattern here that it's very similar to, for instance, Hootie, but a slightly different methodology. And so all of them, when we're looking at what do they accomplish, all of them give us those ACID transactions, which is critical in order to have trustworthy data accessible for analysts and end users to query, just like a data warehouse would provide. So boom, we get all of that with all three table formats. With table evolution, all of them do schema evolution, which is fantastic. With partition evolution, currently only Iceberg is providing partition evolution, but you never know with the development cycle that may come to Apache Hootie and Delta Lake. But right now it's Apache Iceberg. So if partition evolution at a large scale is important, then Iceberg's likely the way to go. With row level updates like merge on read, so Iceberg has merge on read, and with position deletes and equality deletes, and there's a really cool way that Iceberg handles that with the delete files. Hootie does it with merge on read that uses log files, and then Delta will use what they call deletion vectors. I'm much more familiar with Iceberg and how it does the merge on read and deletes. It creates a little delete file that the system will then later read and execute. So it's incredibly fast. So that's why it's really great for schema and partition evolution. In terms of Lakehouse versioning, catalog versioning, right now, I was just looking at the Delta Lake Unity catalog. I still don't think it has catalog and table versioning. The Apache Iceberg catalog that provides all the versioning is Nessie, which is another open source project that you can use with Apache Iceberg. But again, you can swap in any compatible catalog or query engine to work with your Iceberg or Hudi or Delta Lake tables. It just has to be compatible, and you can swap it in and out. For instance, with Iceberg, you could use Nessie, like I talked about, which has those kind of Git-like versioning features where you can branch and merge and do all of those awesome things with your data. You could use Polaris, which Snowflake has contributed to Apache. I think it's still incubating at this point, but lots of contributors to that. AWS, Snowflake, Dremio's contributing to that. In fact, intends to merge Nessie with Polaris if that commit will be approved in the future. That's the thing with open source. You don't 100% know if it'll be approved, but that is the intention, is to kind of merge those catalogs together. Unity catalog with Delta Lake is awesome. If you're using Delta Lake, Unity is an incredible catalog, which is really great to work with. And the interoperability is coming. We recently saw an interview with Ryan Blue, and then who is the creator of Apache Iceberg, who now also works at Databricks due to the acquisition of Tabular, and then also the creator of Delta Lake, who also works at Databricks. And they were talking about how interoperability is key, because you don't want to have to stress and think too hard about what is my table format. You really want to abstract a lot of that away from the end user and just have it work. You just want the end user to know, hey, here's my query, and I'm going to run it, and I don't really care where the underlying data is or how it's structured or what the table format is. I just want it to work, and I want it to be super fast and correct. And so interoperability among these different table formats and catalogs will be critical here going forward. And I think that's the vision from those creators and from the open source contributors. In terms of partitioning, right now, Iceberg has the upper hand on partitioning. So as we talked about, like, Iceberg is best for evolving schemas, evolving partitions at a huge, super efficient scale. Because if you think about Netflix, who was the first use case for Iceberg, that's really the type of data that they were dealing with. Hudi doesn't need to do that. They're dealing with transactional data. And then Delta Lake does need to do that, but the capability isn't quite there yet. So in terms of interoperability, so that's the nice thing with being able to have this data lakehouse structure, is that you can swap in, as I've said, probably too many times, you can swap in different components that work with each other and put the control in the power of the user. You can swap in and out query engines as long as they're compatible with the catalog and the table format. You could swap in and out catalogs. If you're on in Iceberg, if you're on Nessie one day and you want to switch to Polaris, you can. Both of those are open source, so you really have a lot of power. You can do a proprietary catalog like Glue, AWS Glue. You can do the Dremio catalog. It's your data, and as long as there's lots of components that are interoperable, you're going to be able to pick and choose the best components for you to create your own data lakehouse pattern. So Apache Xtable, also incubating right now, is working to convert the metadata between the formats and try to make like a crosswalk. So that's exciting to be able to read and write and talk between the different formats. And using Delta Lake Uniform to write to Delta and sync to Apache Iceberg and Hudi metadata is something that's coming. So right now, a lot of catalogs can read from Delta, but they can't write to Delta. So at least there's that. So at least if you had, for instance, a bunch of data in Databricks, and you had a bunch of data in ADLS in Iceberg format, so you've got both Delta Lake and Iceberg, at least you would be able to get a consolidated uniform view by reading from both formats. So there is that, and more is planned and coming. And so the Data Lakehouse catalog, which we touched on, and I don't want to drill too far into this, but the Lakehouse catalog is really organizing the metadata. I really wish that they had probably chosen a different name for it instead of catalog, because it's not like an enterprise data catalog. It's really a metadata catalog, which just says where the metadata is, because it's comparing it to an enterprise catalog like Calibra or Informatica has a catalog. Well, any of these enterprise-wide catalogs, it's not the same thing. So then if you have a metadata catalog for your table format, it does not replace the need to have a enterprise data catalog. So the role of, in Iceberg at least, the role of the catalog is really to connect your Iceberg tables to the query engine. So the query engine hits the catalog, and think of the catalog like the source. It has all the metadata. It knows where all the tables are through that query plan that we just looked at. And then it goes down and gets the data. So you could swap these catalogs. You've got Nessie, you've got Tabular, you've got the Dremio catalog, you've got Glue with the query engine. You could swap those out. You've got Flink, Spark, Dremio, whatever. It doesn't matter. They are interoperable. And so that's really, really exciting. I know we're at time, but with thinking about the table format, I hope that this gives you a good overview of, what are table formats? What's the benefit of a data lakehouse? Why are people talking about it? Well, it's to get that all of the data warehouse capabilities inside the data lake so that you can really minimize the amount of ETL that you have to do, that you can have open tools that you can swap in and out and make it modular, more agile, and then have a uniform view that you can then use for downstream use cases like uniform analytics, building a semantic layer, doing AI across all your data, building a customer 360 without having to move it into a warehouse and pay to hold the data twice, increasing your compute and storage costs, sometimes dramatically. And so that's the purpose of the data lakehouse. Be super fast, be super efficient, be cost effective, and give you access to your tables and data very quickly, but then also give you the power to swap in and out the components that are best for you and for your use case. All right.
Thank you very much, Andrew, for the session. We have some questions if you've got a couple of minutes spare.
Yep, let's do it.
First question here is, how does Hoody's pruning and time traveling differ from Delta?
Yeah, that's a good question, and we should follow up on that because they are pretty different. I don't know if I have enough time to explain it succinctly because Hoody's really, there are different use cases because Hoody's really for ingestion. That's where Hoody's strength is, where Delta's more comparable to Iceberg, where based on the partitioning and the compaction and the cleanup, the vacuuming, that's much more similar than Hoody and Delta. Hoody's, in my opinion, really not super comparable to either Iceberg or Delta. Delta and Iceberg are much more similar because Hooties just
Okay.
get the logs in order as fast as possible and then read the logs. Where Iceberg and Delta are much more about the overall schema evolution and vacuuming, compaction, those type of things.
Okay, great. Thanks for that. And the second one here is probably more of an opinion. Microsoft has focused on Parquet and Delta Lake for their platform. Are we using the wrong base, in your opinion, given this is mainly a Microsoft conference?
I think I missed the question. Can you tell it to me one more time? I'm sorry, I didn't hear it all.
Yeah. It says that Microsoft is focused on Parquet and Delta Lake format for their platform. Are we using the wrong base, in your opinion?
Microsoft?
I guess for big data analytics. Yeah.
Microsoft also uses Iceberg. But again, interoperability is key and coming. So I don't think that there's a wrong choice there. It's what's your use case and aligning the parts that work great for you. There's a lot of companies who use Delta Lake, and especially if they got large Spark workloads, and that's the way they should go. And then it's really kind of up to the contributors to figure out ways that we can make them interoperable. Again, like a lot of the catalogs can read Delta. So if you were looking for outside Delta, you could do that through their uniform table format, through their uniform format. And Delta is working to read Iceberg per their recent interview. So I wouldn't stress too much and say like there's a silver bullet, because there's not. It really depends on the use case. And if you're using Databricks and you've got Spark and whatnot, Delta's a really great table format.
A lot of different areas there, and a lot of internals and how things are set up on the data lake and the different file formats and things like that. So thank you very much for that, Andrew. We are at the end of our session, and I see that there are no other questions or comments actually there too. So thank you very much. I know this is not the first session you've actually delivered today, so thanks for delivering that, and we look forward to interacting with you in the future. If there are any other questions, we'll let you know. But yeah, great session. Thank you very much. Really complimented everything that was being delivered today as well.
Wonderful.
As we close off, you're welcome. Thank you very much. As we close off, I will bring up the thank you screen, if I can find it. Here it is. And we would like to, of course, thank the sponsors of the conference. Without them, we wouldn't have been able to hold it. It's nothing comes for free, as they say. And although we're volunteering to do this as MVPs and data advocates within Switzerland and Austria and Germany, we'd like to really thank Digital Recruitment and TrueViz for sponsoring and helping us put forward this event today. So thank you very much, everyone, for contributing and for joining and for asking questions. We will have these videos available to you on our YouTube channel, which you're probably watching on already. So in the future, feel free to take a look. We'll be breaking them up into different sessions so that you can find them. And the sessions are all listed here. If we take it through to the, I'll take off the overlay. They're over here. And feel free, this was our room that we were in today. There are 4 rooms in total. This was for room 4, room 3, room 2, and room 1. And so thank you very much, everyone. My name's Charlie. We're signing off, and we'll sign off with our snazzy